Big data analytics helps organizations harness their data and use it to identify new opportunities. That in turn leads to smarter business moves, more efficient operations, higher profits, and happier customers. Understanding this, we have come for this tutorial on big data analytics. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now let's have a quick glance at the agenda. We start off by understanding the concepts of big data and Hadoop. Then we will learn about Hive. And then finally, we will learn about Spark.
So today we will be covering big data. What exactly is big data? And then we will look at something called a Hadoop ecosystem and Hadoop architecture, basically. So these things are the foundation for all your machine learning, statistics, Spark, anything that you are learning, the foundation is this. So today we will be understanding big data and Hadoop ecosystem. We'll ensure that we go through all the basics and all. So my name is Raghu Raman. You can call me Raghu. I have been in the IT industry for about 12 years as of now. And I have been working on big data platforms for about 7 to 8 years. From 2011 onwards, I started on big data. I trained people on Hadoop, Spark, the big data typical tools that we use. I train a lot of people from corporate backgrounds. I'm a regular trainer at Flipkart, GE, EMC, and many other companies. The definition of big data, if you Google, you will get. First thing, you can just go to Google and say, what is big data? You will get tons of articles, PDFs, and presentations. That is not what I'm going to teach you, right? What I'm going to teach you is that, let's take a practical use case, right? Let's take a practical use case and try to understand how big data actually makes sense, right? So, first of all, big data is related to IT. So, you need some level of IT knowledge to be fair, right? This has something to do with IT. I will share my personal experience, okay? So, when I started working in 2007, 2008 and all, okay, I was working with a company in Bangalore, and we had created an application, a sales application. So, basically what we'll do, if you install this application, there was a retail company, the customers will input all their sales data in that, so they will say that today this much quantity item sold, sold and sold and sold. And this application will capture all the data, okay, and store it. Now that was a very simple world. We did not had mobile phones, we did not had Facebook, WhatsApp, nothing was there, 2005, right? And we were using an RDBMS system to store this. You know what is an RDBMS? Okay, at least you are good at that, right? So this is your culprit. We are not going to use this kind of big data, okay? So RDBMS is what we were using to traditionally store the data, right? And what is an RDBMS system? It has a row column format. You have a table. You insert the data. Now, if somebody is teaching you RDBMS, they will say that, well, RDBMS is great. It can store everything, that's all fine. But unless your data starts increasing, right? So originally, RDBMS can store everything. I don't have any, I'm not against RDBMS or something. Even for transactional management, we use RDBMS. There is no doubt about it. MySQL, Oracle, we were using MySQL actually. So whatever the customer is inserting, this MySQL will capture it. End of the year, you do some processing. You will understand how many items were sold. Everybody is happy. This is what was happening in 2005. Fast forward to 2011. I am working with ICICI Bank. ICICI Bank want to migrate to big data platform. So 2011, we run a project in which we migrated the entire ICICI Bank into big data platform. Okay, so I was part of that project. I was not doing everything in that project. So what is the problem with ICICI Bank, right? So that is the question. Why ICICI Bank want to go to big data, right? Now, this example will also help you to understand the IT world, right? So for people who are not coming from the IT background, they might need to understand how things are working, right? So we went to ICICI Bank, we spoke with them, we said, hey, what do you want? They said, you know what, we are facing a lot of problems. We want to go to big data. We want to go to Hadoop. We'll see what is Hadoop later. So we asked, what is a big deal? What is your problem? So there were a lot of problems which they were facing. One of the problem is that if you look at this RDBMS system, right? your typical RDBMS system. What is RDBMS systems doing? They will store the data in the form of a table, right? Now, if your table size is very, very small, it's not a big deal. Even if you look at MySQL or if you go to enterprise scale Oracle and all, they can store gigabytes and sometimes up to terabytes of data. But as the size becomes big, so let's say I ask you, okay, you have to store the data in Oracle. The data is keep on increasing every week. You are not ready to migrate anywhere. Oracle, if you talk only about Oracle, they have storage separate and DBMS engine separate. I don't know how many of you have worked extensively with Oracle. In Oracle, what I can do, I can purchase Oracle and I can add storage boxes, as many as I want. So these boxes will be in the network. So my database engine will be connecting to them and storing the data, whatever data I'm giving. So you can argue saying that I can increase the storage capacity and then Oracle can store as much data as you want. There is no doubt about it, right? But there is also a limitation for this storage, one problem. Second problem is that as this box increases, the storage in Oracle increases, you have to divide your data. You have to partition your data. So let's say, for example, you are working with Oracle, okay? So let's say you are working with Oracle and let's say we are looking at iPhone sales. iPhone, right? So you are selling iPhone. Let's say you are working with Apple, right? So one of the example is that if you are creating tables to store iPhone data, typically if you look at the schema and all, what we will do is that there will be one table, okay? There will be one table wherein you will be having properties like, how many items were purchased, at what rate they were purchased, how many people bought, so on and so forth. So this will be your items table. So in the items table, you will have all the data related to the iPhones you were selling, right? You will also have another table where there will be the user data. You will also have the user data. User data means which customer bought, from where he bought, all this data. This is called normalization. You know what is normalization? In RDBMS systems, in order to avoid duplication of data, what we do is that we normalize the data. We always keep the data in different tables. And whenever you want to get the full data, what you do? Joins, right? So if I want to get both the data from this, I have to do something called a join query. I fire a join query and all the data from here will come and join and produce me the output. This is good if you're having small amount of data. What if you have terabytes of data here and here? My join query will fail, right? Or the join query has to wait. Now, another point that people say is that if your RDBMS is becoming bigger and bigger, why don't you partition your data? That is possible. I can have like 4 boxes. My one table, okay, if this is my table, right? It can be logically partitioned and kept on 4 machines if it is becoming bigger and bigger. Okay, this is possible. There is something called logical partitioning. Look at the iPhone data. I can say all the data where people from India are buying the iPhone, go to this machine. That's called logical partitioning based on the country column. So here I have all the India data where people are buying iPhone. Here I have the US data where people are buying the iPhone. But the problem is, here I'll have the Burma data also. India data will be, let's say, 2 terabyte. China data will be 3 terabyte. This will be KBs actually. So the problem is that if a table is becoming so big, okay, I can cluster it. I can take 4 machines in my RDBMS or data warehousing architecture and I can say partition the data. Because if a table is so big, if I fire a query, the query will take a lot of time. So what I do, I say that, okay, don't store the full table. Divide the table or partition the table. To partition, I will say that you have to use some logic for partitioning. I cannot physically divide the data. That's not possible in RDBMS. I cannot say that take a table and cut it into 4. Doesn't work. So I have to logically partition. So I have to say that there is a country column. How many countries are there in the world? Maximum 155, right? I'm not much of a geography person, but I think somewhere around 155, right? Or at least people who buy iPhone, 155 countries are there. So I will say take the country column. So everybody who is buying an iPhone will have a country column. So based on the country column, it will partition your data, right? Now I have 4 boxes. This box has India data, US data, Burma data, and something data. Again, same story. If you are running the join query, This box has to process all the India data for join query. This box will complete very fast. This guy has to wait. So again, so the problem is that traditionally people were using RDBMS systems and data warehouses to store the data. Now, what is the drawback? One of the drawback is that as the size of the data increases, your processing will become very, very slow, right? You can't do it. Now, the problem with classes in big data is that there are a lot of technologies. So when you start talking about them, why don't you denormalize the data? Why don't you denormalize the data? For example, all the transaction data, user data, everything I'll keep in one table. Is that possible? One duplicates. Second, what is the maximum number of columns you can have in a table, RDBMS table? 1000. Oracle says 1000. What if my data has more than 1000 columns? If I keep all the data, I can't do. So that is the reason they don't provide the denormalized solutions. If you look at RDBMS systems, they will always say normalize your data so that it will be represented in different tables, and whenever you need the answer, you do a join and you get the result. Second drawback, this is only structured data, meaning anything which you can represent in row column, I can dump here, like an Excel sheet data, right? Can I dump images and audio files in this table? Yes or no? Can we store unstructured data in RDBMS? Yeah? Yes, you can. There is CLOB, blob and all objects, right? But can it process unstructured data? Not possible. So, in the modern day, if you look at the modern day, what is our problem? So, if you look at a typical bank like, so let's first complete this part. So, one of the drawbacks of RDBMS is that as the size of the data increases, it cannot cope up with processing. One of the problem, right? Second problem is the schema, meaning anything which you can represent in a row column format, I can dump in an RDBMS. Anything apart from that, I have to figure out a solution. So what is the actual solution if I have to store images and retrieve them in real time? How does Flipkart stores the data? I was working with Flipkart for some time. Flipkart has around 10 million products. Each product has 10 images. That is 1 billion images. So when you click on a iPhone X picture on Flipkart, Flipkart will say that come after 10 minutes or immediately display. Have you ever thought how it is happening? Good question, right? How it is happening, right? So do you think they're dumping in an RDBMS and picking it from there? 1 billion images? No. NoSQL databases. There is a whole arena of databases called NoSQL. Fortunately or unfortunately, it is not in my course, so I don't have to teach, right? But if you are going to, so your end goal is to become data scientist, and I think that is why you're learning this course, right? You're learning Spark and other things, right? So I would suggest you to Google and learn a little bit about something called NoSQL databases. If you have heard about MongoDB, Cassandra, HBase, Neo4j, Voldemort, these are all popular vendors of NoSQL database. So NoSQL databases will help you to store and retrieve unstructured data at any speed you want. So what Amazon.com actually does, Amazon has something called DynamoDB. DynamoDB is a NoSQL database. So in DynamoDB, I don't have a row column. I have key value pairs. So what they do, the key will be the product name. Say you are clicking on iPhone X. iPhone X is the key. The value will be all the data you have. So the moment you click, boom, your page is there. So NoSQL databases are really faster. Also, it helps you to store unstructured data. How are you booking a cab using Ola? Right? I go out. I didn't get a cab yesterday, by the way, in Chennai. But if I try to get a cab using Ola, right? I open up Ola. How many customers Ola has? Millions in India. And all of them are booking at the same time, right? Do you think all your requests are taken by an RDBMS and searched in the table and give you a cab? Does it work? Can an RDBMS system handle 30 million, 40 million concurrent sessions on this amount of data, calculating route? MongoDB, NoSQL database. Ola runs on MongoDB. I was working with Ola for one of their design problems actually. So I didn't design anything, but they told me that they are using MongoDB. So The problem is the new world that we see today does not fit our old description. When I went for my first job interview in 2006, my technical guy who interviewed me asked, what is your strongest skill? I said Java. He said, you're selected. Because Java is like, if you know Java, you will get a job without an interview. Now, if I say Java, he will not allow me to sit in front actually. Because Java is still good, but the new world demands new skills actually. That is my whole idea. So the second drawback of your RDBMS is scalability is there. Okay. Third is price. Price is a problem, right? Obviously, if you calculate the cost, if you look at Oracle and all, they are very, very costly solutions. ICICI Bank was paying around 30 crores only in support fees to Oracle. 30 crores, not even a year. I think 3 months they were paying 30 crores, 40 crores only for support for Oracle, because it is an enterprise grade product, right? You have to pay money. There is no other way, right? Now, if you switch to NoSQL platforms, they are all open source. You don't have to pay this much amount of money, but that's not our discussion. I'm just saying. So all these problems means traditionally storing the data on an RDBMS and retrieving is not good for the modern day. In the modern day, what is happening is that every company want to collect and analyze the data. Be it banking industry, e-commerce industry, or any industry that you want, they want to collect and analyze the data. So to give you an example, if you visit Amazon.com or Flipkart.com, what is happening? They start tracking from which IP address you are visiting the website, how long you are clicking on a page, which items you are adding to cart, which images you are clicking, which offers you are clicking. All this data is analyzed to understand how a customer will behave. That is how they do marketing, right? So the more you start visiting the e-commerce companies, you start seeing recommendations and all the more. The more you visit Amazon, they will start recommending products to you, asking you to buy. So they have to collect all this data. So when I was working with Flipkart said that they collect data from the apps that you're using, from the website that you're having, even from social media. Flipkart is very active in social media, like Facebook, Twitter, all these places they are active. So if anybody tweets about Flipkart or visit their Facebook page, all this data is being collected. Now this is actually called a big data. So the technical definition of big data is this huge amount of data which you cannot process using your traditional methods. That is called big data, right? So why that is of interest to us? We are going to figure out how to store this data, huge amount of data, right? And how to process this data. So using the traditional techniques, you will not be able to store it or process it. That is not possible at all. So we will be seeing how you can use Hadoop as a solution to store all this data and process all this data, right? So interrupt me anytime if you want to ask anything. I'll keep on talking. Yeah. So when I say NoSQL databases are there, it does not mean your RDBMS is gone. So many people ask this question. Okay, RDBMS is the only solution for transaction management. So even if you're buying something from Flipkart, who will complete your transaction? Oracle probably, or any transactional system. For transactional management, and why is that? Because RDBMS systems are the only ones which can ensure the ACID properties, right? If a transaction goes or not goes. You bought something from Flipkart, tomorrow Flipkart cannot come back to you and say that, I don't know whether the transaction happened or not. Probably you got the money. It's not possible, right? Then you will start complaining again Flipkart, right? So Flipkart comes to you and say that, you know what, we are using Cassandra. As per Cassandra, your transaction is, we don't know, we'll come back to you in another 1 week. Is that possible? No. So transaction management, very good question, is still handled by RDBMS. Technically, it is called polyglot persistence. So I'm not a person who uses a lot of technical words, but polyglot persistence. That means coexistence of traditional databases and the other ones. Even if you look at Amazon or any company, they will have their transactional data and a bunch of NoSQLs to handle other type of things. Okay, polyglot persistence. Well, you don't have to really. I'm not a person who really use a lot of polyglot persistence. Persistence is E or A, I don't know. Even my English skills are at stake when I'm training people. Persistence is E, I think, right? What do you think? Take a vote for that probably.
So Hadoop is an NoSQL.
No. Yeah, so that's what. We have not come to Hadoop so far. I will explain. Hadoop is not a database. So teaching big data in 16 hours itself is a challenge actually, because it's a vast topic actually. In the world of big data, there is a separate category of systems called NoSQL databases. And they are databases. So what is a database does? Real-time, queries, right? And in that area, we have MongoDB, Cassandra, HBase, and these guys. Now, these guys are used in real time if you want to fetch the data. Say, for example, you are opening an e-commerce website. Probably it is given by a NoSQL database, right? Or millions of people are booking flights through cleartrip.com, and Cleartrip has to identify how many people are booking in a particular route so that it can give a better offer. This is probably done by reading real-time data from a NoSQL system. Our area is not NoSQL. NoSQL is a DB actually, it's a database. Our area is not NoSQL. We will come to Hadoop, right? Now, so this is that technical term for coexistence of DBs and NoSQL and all. So now let's understand. So we established the idea that RDBMS is not good for us, at least in the world of big data. But don't say that RDBMS is not good, because transaction management is still handled by RDBMS. So you cannot say that get rid of RDBMS, right? Now there is a very important term, even though it is not directly related to your syllabus, but I think it makes a lot of sense. How many of you are aware of this term? Raise your hand, I will raise. Oh, a lot of ETL guys, good to know that. So you know what is an ETL, right? And some people do not know what is an ETL, that's fine. So ETL stands for extract, transform, and load. So what is the idea here is that, see, if I'm working with a company, right? The company will have RDBMS systems, right? So these are all RDBMS systems. So probably this guy is using MySQL, and he's also using Oracle, right? A lot of RDBMS systems are being used by a company, right? Now these are all serving the customers. So if you take the example of ICICI Bank, all their core banking data is in Oracle. All their core banking data is in Oracle. So if you are making an online transaction, the data hits Oracle. All their CRM data is in MySQL. What do you mean by CRM? Customer relationship, right? Your name, address, blah, blah, blah. So they have these two type of data. Now, is this the only type of data that they have? No. ICICI Bank had also acquired a lot of other companies when we were working with them. So their subsidiary companies were giving them data in the form of XML files. XML, right? Now, ICICI Bank also had a Facebook page, okay, from where they were getting around 10,000 people visiting every day that Facebook page, and they used to click on some item. So they have to do this cross-selling, upselling. If a user goes to Facebook page and say that I really like your loan, take more loan, right? So that is your cross-selling and upselling, right? So what they do, they collect all this data from social media. That comes in the format of what? JSON. JavaScript object notation, JSON, key value pairs basically. So this is where their core banking data, this is where their CRM data, this is from their partner companies, this is from the social media data they are getting, okay? And they had customer care. This one, the social media data, they want to do analytics. So every day 10,000 people are visiting their web page. They want to know a person clicked on, let's say, a loan offer and how much time he stayed on the page and what age group he belongs to, so that they can recommend products. Recommendations actually. A lot of recommendations. So social media data was being used. They did not reveal all the things that they are doing because that were internal to, but basically using the social media data, they were doing recommendations. So they will download all this data. So if a customer is clicking on the Facebook page, they will get the access of this guy. If you are clicking on ICICI Bank's Facebook page, they will know your age, your occupation, everything you shared in Facebook. That is by default given to me. In most of the cases, you can restrict the information, but most of the public customers, they will share this. So by downloading this data, today they will understand 10,000 people clicked, and out of them 5,000 were youngsters, and they clicked on this loan. That means the trend is towards a particular bike loan. If we give an offer on bike loan, youngsters may actually buy it. So this is analytics, right? So all the social media data they can use in multiple ways actually. So this was getting in the JSON format actually. And this type of data was there. They also were collecting their customer care log files. So that is again flat file. It was coming in a format of flat file. Flat file means text file. So customer care log actually means the chat logs that they were having, also the call logs. They don't get the actual call, but how long the call happened and what you pressed. So when you call customer care, you press, right? This. That is actually captured. And then they want to figure out how many people are called on what category, how much time they spent, right? So if you are clicked on a complaint button and you talk for 1 hour, chances are very high you are a bad customer, right? I mean, 1 hour you're scolding probably, right? So they want to figure it out, right? So that is the call record that was coming in flat file, this format, right? And at that point in time, ICICI Bank also wanted to offer a solution. So previously what they used to do, their agents were there, people who go to your house and make you buy loan and all. So they used to go to every place. So this agent will get a list and he will go to that place and he will go to your house and say that, sir, please take a car loan. You will say no, he will say buy. He will get money. He is getting salary, right? So this technique was not working because if I get a list, okay, one customer will be in here. This is what place? Vadapalani? No. This is OMR, right? One guy will be in OMR, another guy will be in some other remote place in Chennai. So by the time he travels from here to that place, day will be over. So he is able to cover only 2 customers. So what ICICI Bank had in mind, they will track his location. He has a device, okay, and give him customers in real time. So if he is in Kannanjavadi, he'll get all the customers nearby him. So this guy has to go, right? He cannot say I can't go. So the customer application, it was a tablet, will track this guy, and wherever this guy goes, the nearby customers will be provided to him. So he can cover more customers, right? And this has a lot of impact because why it was practical? Because sometimes the customers will call and say that, please come, I'll give you a loan. So what you do from here, you might travel to, there is a European city, Paris in Chennai. Yeah. So you'll go to Paris, right? And because the customer called, right? So you go to Paris and meet the customer. Now you don't know how many customers are around Paris. That this application will track and send it to you. So these guys were collecting that data also from all the tabs. And that was quite some big amount of data they were collecting. So how many customers they met and whether they closed it or not closed. Okay. That was coming in, I think, some other format. So some format I forgot actually how it was coming. So this is the whole data they have, right? And some more data was there. And this data is lying on different systems. It's not in one place. The core banking data is in Oracle. Some other data is in some other place, right? And if you want to analyze this data, one thing is that I cannot go to Oracle and say that I want to analyze your data. Why? Because this Oracle DB is already busy serving customers. Correct. This Oracle DB is the core banking database. So if you are making a transaction, Oracle is handling that, right? So I cannot go to Oracle and say that let me run some analytics on your data. Doesn't work that way because then Oracle will slow down. I can't do that. So I have to take all this data from all these places and dump it into a central place. So that is what is you call as your data warehouse, right? That is called a, how many of you know what is a data warehouse? So a data warehouse is nothing but a database only in one way. It understands the language of SQL, but the major difference is that it is not facing the customer, right? So you will do something called ETL, okay? So there are ETL tools which can get the data from all these places, right? And this guy will dump it into a data warehouse, right? So data warehouse is also called as your OLAP, online analytical platform, so on and so forth. And what is the purpose of this guy? So this guy will have all the data from here. Okay, and you can transform the data as well. So that is why it is called ETL, extract, transform and load. You don't just take the data and dump it here, then it is useless, right? I can read the data from a flat file and give some structure and then dump it here, like a proper table format. So now all my data is here from this, right? And I can run business intelligence here, BI tools, Tableau, right? If you have heard about MicroStrategy, Tableau, what I can do, I can connect a visualization tool here and it will show me in charts and diagrams what is happening. I mean, this is traditional enterprise architecture. This is how people used to work forever. I mean, every company you go, this will be there by default. They will have these disparate, discrete data sources and ETL tools. So if you have heard about Informatica, Informatica is one of the biggest ETL tool. Informatica, Talent, Pentaho BI, SSIS. So these are all ETL tools. So these tools, what they do, they will connect with here and take all the data and apply some schema and push it to a data warehouse. Now the data will be here. So now all the data is in one place. So if I'm Chandra Kochar, I wish I would be, I can go here. Chandra Kochar is who? ICICI Bank's CEO, right? Who is that place? So I can go here. So Chandra Kochar may not know SQL, right? You can't expect that, right? If you're a CEO of the company, I can't ask you, do you know Java? I'll be fired next moment, right? So, but the CEO want to know what's happening, right? By getting all this data only, you will understand what's happening in the company. But you don't have time to sit and learn all this language or anything. So if I'm Chandra Kochar, I'll go here, I'll connect my Tableau and I'll ask my Tableau, show me the last month's transaction, this quarter, this product, this area, show me. It will show a nice bar chart. I'm happy. Now, why this is very, very important? If you make any mistake in any of this entire stuff will be changed, right? And what she sees will be different, right? She has no idea how this is happening, right? Only you know how this is happening, right? So your ETL tool should run proper, the data should be captured and dumped here and then analyzed. So for CEOs and CTOs, they use visualization tools to connect with a data warehouse, then analyze the data. So all the data is inside this data warehouse, right? And this is not accessible by public. Public has no access to this. Only internal company has access, like maybe CEOs of ICICI Bank, they can go here and visualize the data from here. Others, public does not have any access to here, right? And then they visualize the data, they make a decision, they may not make a decision, that is up to them, right? In the whole setup, there is no Hadoop so far. And this is how ICICI Bank was running so far. Now, what were the challenges they faced? One of the challenge was that this ETL tool, okay, I don't know how many of you have run on ETL tools, okay? They typically run on a single machine, okay? So they get installed on a server. So there is a limit as to how much this guy can pull to a data warehouse, right? How much amount of data this guy can pull from here to a data warehouse, there is a limitation, actually. You can't have terabytes of data being pulled, point number one. Point number two, none of this is real time. None of this is real time. I go to Tanishq store, Tanishq is a jewelry stuff. I go to a Tanishq store, I buy something from there for 20,000 rupees. I use ICICI credit card. I should immediately get a message saying that again you shop 20% discount. That is real time. I can't do it here because all this is separate data and these ETL jobs run at the night. So today morning if I'm shopping, tomorrow I'll get the message 20% off. By the time I'm out of Tanishq shop, right, I may not use it at all. So ICICI Bank's first problem was that since the data was increasing, they were not able to run ETL properly. Second problem, none of this is real time. They wanted to push customized offers. Their requirement was that whenever any transaction is made, they want to capture it, analyze it, right? And based on that, they have to recommend something to the user, right? Say for example, you are using credit card or debit card, or even you're clicking on some link, immediately something should happen. Now that is not so easy, right? Because your data might be somewhere in here, Oracle, and I cannot track each and every transaction here because this is my transactional DB. I can't say that track each and everything from here, right? That's not possible. Third problem, this data warehouse. This data warehouse is a very costly affair. I have worked with a company called Teradata. They are the leader in data warehousing market. I had a US client, they were using a product called Teradata for data warehouse. They were paying around $5 million every year only for this setup. Now it is good. You can analyze the data and all, that's okay. But you're paying a lot of money actually. So data warehousing is actually a very costly affair. It's not so cheap if you want to implement. But companies like ICICI Bank, they must use it, right? So they can't say that we will not use it. So they wanted a cheaper solution. They don't want all their data in this data warehouse. They want an alternate solution. It should be real time, cheaper, scalable, right? And anything they want to integrate, any type of data that comes, they wanted to integrate. And that is how they came to us and asked us, like, can we migrate to some big data solution? And we recommended Hadoop, and then the migration took a lot of time. That is a different case altogether. But if you talk about Hadoop, Hadoop actually comes here. In a way, I can say it is,
Traditionally, these OLAP tools are designed for accuracy of the data at the speed.
Right.
But the online transaction processing,
Exactly.
the throughput time is important.
Right, exactly.
Both are at different extremes.
Right.
You cannot give a suggestion that when the customer
Exactly.
at that time I cannot really do
Not possible. Not possible.
It's
Not.
the problem of this system.
Exactly. So here you have your n-dimensional cubes and other things, like in the data warehousing. You will have your what you call schema. What schema you call? Star schema, snowflake schema, right? And so this is actually, OLAP is actually not designed for speed. That is true. It is only analytical. It is batch job actually, right? So with this architecture, I can never give a real-time solution.
That's actually a limitation of architecture. Either you can go on one side or
Exactly.
you have to find a middle one.
Exactly. So a lot of people argued saying that you can actually beat it if you do parallel processing. There is something called MPP, right? There is something called MPP. MPP means massive parallel processing. So a lot of people came saying that. So these systems are actually Teradata and all are really faster actually. I mean, not like RDBMS, but they are faster. Okay. So a lot of people came up and said that, okay, if your data warehouse is very slow, why don't you do parallel processing? Okay. You install it on 4 or 5 machines and you can do parallel processing. That is possible, but still the same problem exists. You cannot physically divide your tables. Only logical division is possible. Like I said, country based you can divide or month based you can divide. End of the day, if you want to do a join operation or something, same questions will happen. So I can never propose this as a real-time solution. So that is my crux of what I'm trying to tell you. And this is how even ICICI Bank was running. And cost was another problem. They had a lot of cost involved. So, and obviously, since they wanted to collect a lot of unstructured data, they wanted to go to a better solution. Okay. And that is how Hadoop came into the picture. Not really. Mostly here you have structured data. Mostly structured data only. They are used as the final place where you get the data. From there somebody can visualize. And in here you very rarely you modify the data. You don't modify the data. Because this is the place where the final data is available. From where you can connect and visualize the data. That is all you do. Or probably you can run a query and get the output. That is all you do. It is analysis only. You are not doing any transaction. Transaction management, all you are doing here. Right? Now the point is that, now let's discuss a little bit about Hadoop. So what I thought is, like, today probably we can cover the architecture and a little bit of theory, so that tomorrow, so if you look at your syllabus that I'm supposed to teach, we have something called Hadoop and Hadoop architecture that is anyway required, right? And then you have MapReduce. Now there is a catch here. MapReduce is the default programming framework on top of Hadoop. So if anybody want to analyze the data on top of Hadoop, they use something called MapReduce. Point number 1. Now MapReduce came long back, okay, and today there are a lot of ways to analyze the data, not only MapReduce. Now as per your syllabus, the curriculum says teach MapReduce and then some concepts in MapReduce, and I will be doing that. But one other thing is that if you want to learn MapReduce, ideally you should be an expert in Java, because MapReduce programs are written in Java or any other programming language. So you can write in Python and other things, but natively people write MapReduce programs in Java. Now I know that not all of you are familiar with Java and comfortable with Java. So if I talk a lot about Java, it may not make much sense out of you. But then why you are learning MapReduce is to help you in Spark. So next you will be learning something called Spark, right? 16 hours of Spark content will be there. Spark also uses similar concepts as MapReduce. So even though you are not able to understand each and every line of code that I am writing, that's okay. But you need to understand the logic, how it is working. Because Java programs, not everybody will be able to follow and understand and debug. So that is not expected also from you. But if we discuss MapReduce, I write a MapReduce program and we run a MapReduce program, you should be able to understand what is happening inside that, right? Logically, not like syntax wise, line by line wise, right? So once we complete Hadoop architecture, like tomorrow, I will be discussing MapReduce theory and MapReduce programs will be running. And then in the next 8-hour syllabus, we will be completing bit of MapReduce and going to something called Hive, Apache Hive. So Hive is your data warehouse in Hadoop. So that is more of SQL side. So you can understand that point. Yeah, somebody had a question. Sorry. Someone asked a question in the middle. I just said, I will complete. Who asked? Nobody asked? Okay. So just rub this. Right? Now, what I'm going to do, I'm just going to delete this part for the time being. Okay, I'll just remove this part for the time being. Yeah.
In the enterprise architecture, they will have both the data warehousing and the big data, or they will migrate from
that's what. So now what is happening, the traditional data warehouses are there, like Teradata and all, but they are not so popular. And in the market, like people used to say, if you cannot convince, what you do? You confuse people. And it is very easy to do that, right? Because why am I saying this? Because I see a lot of people getting confused. Because so when Hadoop came, Hadoop became a very popular solution for data warehousing, right? And since Hadoop is open source, and you can read the McKinsey report, it will be only 1/4 of cost of a traditional data warehouse. So what will happen? Everybody will use Hadoop, obviously. Why should I pay extra money? But then what is the drawback? The traditional data warehousing companies, they cannot sell, right? So if today you go to the website of Informatica or even Teradata, they will say that we are selling Teradata plus Hadoop. Previously, you had to give me $10 million. Now you give me 9.5. Take it. Well, that's useless actually, because why should you buy Teradata? But they are saying because Teradata has a name in the market. That is a different thing, right? So Teradata will say that buy our data warehouse, we will also give you Hadoop. That too cheaper, right? Previously you paid us 10 million, now pay 9.5. You're like, okay, great solution. I'm getting Hadoop also. You don't actually need to use Teradata. You can build a custom solution, but the couple of problems are that one, the name of the company like Teradata and support also from them. Second, it takes a lot of time to migrate to these things. One fine morning, you cannot go and say that, okay, from tomorrow onwards, we are using only Hadoop. Doesn't work like that, right? In a company, you need time to do migrations and processes and all. So people stick with their traditional tools. So what I have been saying, in some of the companies where I went for consulting, they have completely migrated to big data platforms like Hadoop. And they keep Teradata and all in a very less level. Like the hot data we call, right? Hot data, cold data, warm data we have. So the immediately accessible hot data will be there in Teradata and all. And you have the cold, warm data, which you don't need to immediately analyze. You will dump it into Hadoop or something and keep it. So you can reduce the overall cost in this architecture, right? So now speaking of Hadoop, our architecture is here still. I just changed a little bit, okay? I'll just write it here. The question is when all this happened, right? So a lot of people, so I handle a lot of trainings in Hadoop and Spark. So a lot of people ask me that, okay, so we are learning a completely new technology called Hadoop. And I will say that you are wrong, because Hadoop came in 2005. So almost 13 years now. So it's almost like very old, but for people it is still very new, for those who do not understand Hadoop. So in 2005, this framework called Hadoop was created, okay, long back, right? And there were two guys called Doug Cutting and Mike Caffarella who created this framework. They took the original idea from Google. So Google was already doing a lot of distributed computing, and Google was dealing with a lot of big data, right? So they published a couple of white papers, and this Doug Cutting and Mike Caffarella, they took the idea from Google and then created a framework called Hadoop. And later they gave it to Apache as an open source project. So Hadoop is a open source project actually, which means it is with Apache right now. You can download it for free, install it for free. You don't have to pay any money. But if something is really free, you have drawbacks also, right? Correct? For example, you have Android phones. I have an iPhone. I used to use Android phones, but you know the difference, right? The difference is not show off. That is not the difference. The real difference is that Android phone might get a lot of bugs, which may not come in an Apple phone. If you have used both, you will understand. The problem is Android is open source, right? And open source means every company will modify according to the requirement. As Samsung phone will have their own Android, right? So accordingly, a lot of bugs may come. The platform may not be so stable as it is. If it is an Apple phone, only Apple produces it, right? And if there is a bug also, if I call Apple or somebody call Apple, they will fix it, because there's only one version of it available, and they know what bugs may come, may not come. So the same story here. Originally it was Apache Hadoop, and even still you can go to the Apache website and download Hadoop. But soon people realize that if they are using Apache Hadoop, it is open source, but if something does not work, something crashes, nobody is there to fix it, because it is open source. And accordingly, a company called Cloudera came. There is a company called Cloudera. You might have probably heard. Cloudera is the first company which created a commercial distribution for Hadoop and related tools. So today you can go to Cloudera and ask them to give you Hadoop. What is the advantage? You will be getting the same Hadoop, almost similar what you find in Apache website. But if you install it and if something is not working, they will fix it. You have a support. Since you are paying money, you get support, just like a vendor, right? So one of the companies which is very popular in the world of big data is Cloudera. So they sell Hadoop, Spark, everything as a bundle, okay? Even your lab actually has Cloudera distribution. The lab we are going to use actually runs a Cloudera distribution. And I can also use this thing, right? If internet is there, because I just want to show you this. So if you just go here and simply type, not now, probably you can do it later. Simply type Cloudera, you can see Cloudera's website, right? And Cloudera came in 2008. So today, if you are buying any big data platform, the leading vendor is Cloudera. So they will give you everything packaged in one product. Like Hadoop will be there, NoSQL, HBase will be there, other related tools will be there, data science tools will be there. So commercially, they are actually the number one provider, Cloudera, right? And somewhere in 2012, we will discuss Hadoop in depth, okay? I'm just giving you some idea. We'll discuss the architecture and all. There is also one more company called Hortonworks. Hortonworks came in somewhere in 2012, okay? And Hortonworks is also the next major competitor to Cloudera. The major difference is that Hortonworks sells original Hadoop, Apache Hadoop. They don't modify it. Cloudera sells a modified version, which they say it is better.
So, didn't they have any legal issues like the technology was with Apache?
No. So it is actually Apache open source license. So what Apache says is that anybody can modify it and sell it. Only thing, they should also provide a free version, and they do it. So if you go to Cloudera, you can download the Cloudera's product for free. You don't have to pay any money, but you will not get support. So what people do, they will buy only with support, right? So if I want to sell Hadoop, I can start a company, I can download from Apache, modify the source code, I can sell it to you guys. But two things, one, I should give a free offer also, no support. Second thing, that is the story with every open source, right? You have Ubuntu Linux, you have Red Hat Linux. What is the difference? Red Hat, yes, not open source, whatever their product, because Hortonworks is open source, Hadoop, and you can download from their product. Cloudera's is not 100% open source, it's a custom product, but you can download it for free from their website and install it on as many machines as you want, but you will not get technical support. So ideally people will not do it, right? Because you need technical support, so you will pay money and get it actually, right? But these are the companies, the Hortonworks and Cloudera as the leading vendors in the big data world. They also provide certification. So if you want to write a certification exam, probably after the Spark class, you can try that. Cloudera provides certification exams in the big data world. You can write it and get. There is also one more company called MapR. Three are there. There are many companies actually. The most common ones are three. There is also somebody called MapR. Apache doesn't do it, right? It's open source community. It's not a company. It is like you and me. So I can edit for free, you can also edit for free, but you will not. So if something crashes, what you do? You post a question in the community. Hey, yesterday my old servers were crashed. I am fired from the company. Please help me to fix it. And you don't want to do it in an enterprise world, right? So the real thing is support. To be very fair with you, why still people are trusting all these companies, Microsoft or Apple or Oracle? They get support, right? Something doesn't work, you cannot be able to fix, right? You have to call them and make them fix. So MapR is the third company, which is sort of like popular. This company, if my information is correct, was created by a couple of people who quit Cloudera and Hortonworks, Indians only, right? And they found this company called MapR. MapR is very popular these days, actually. No? A very, very popular vendor. The highest paid edition is also MapR. Cost-wise, they are bigger than Cloudera and Hortonworks. Cloudera and Hortonworks license is cheaper than MapR. MapR's license cost is very high, actually. MapR's architecture is also very different, not like traditional Hadoop architecture, right? So for that reason, like I went to GE, I went to Flipkart, they are all using either Hortonworks or Cloudera. They don't use MapR much. They also downloaded the open source Hadoop, modified it and selling it. Same story, but they made a lot of change to the architecture of Hadoop actually. Apart from this, IBM has their own flavor. It's called Big Insights. Microsoft has their own flavor. That's called HD Insight. HD Insight is there. Amazon has. Every company has an edition of their own Hadoop and big data platform. But most popular ones are Cloudera, Hortonworks and MapR. These guys are the most popular ones actually. So, so for a developer, there is not much difference. For example, if you are writing a MapReduce program, it will run the same way on all three platforms. There is not much of a difference. The difference actually is that Hortonworks is totally open source. They sell the same what Apache gives. Cloudera modifies it a bit. And they say that with the modification, Hadoop is more stable. That is their claim. We don't know. It's all marketing gimmick. It is same like buying an Android, Samsung mobile phone and HTC mobile phone. What is the difference? End of the day, internally it is Android. But Samsung will say that our Android is better, more bug-free or something. HTC will say that this phone will never hang. So only HTC or Samsung know what they have done inside the phone. But end of the day, if I download, let's say WhatsApp, it will run on both the phones, right? Because it is Android. So same thing only. It's just a commercial distribution. Same story with Linux. You can buy from Red Hat. There is also one more provider, right? SUSE. Red Hat Linux, SUSE Linux, internally everything is same. If I type an ls command, it will work both ways. Kernel might be slightly different, but end of the day, they are paying open source original Linux only. So same story here, but considering the platforms, Cloudera seems to be more popular, okay, because they got a head start. 2008 they started, right? Long back they started. Hortonworks is also gaining a lot of popularity these days. I have been seeing that. So we are using Cloudera. In our lab, we have a Cloudera distribution. Okay, so but we have not talked about Hadoop, right? So we have been talking a lot about the company. But when did we start the session? I didn't check. 2:30? So when do you have breaks and all? I think 3:30, right? Now, see, I don't have any control on that. Breaks are controlled by her, right? I don't have any control. She has to approve. I don't have any control. Trust me. See, she is talking about schedules and all. I don't know any of this. Okay, I can teach. I can stop. You say stop, I'll stop. Okay. By the way, if you don't like my class, you can walk out also, but you will not do it because you paid money, right? If it was a free class, half of them could have walked out. But since you paid money, you will stay. I know that. Okay. Yeah, sure. Please ask as many questions as you want.
Because nowadays we could see like Spark is having momentum.
Yes, correct.
Companies using MapReduce, are there any opportunities?
No, no. MapReduce nobody is using.
Even the positions also not there.
In the enterprise, MapReduce is gone. Only Spark is there. That is what I'm saying. In your curriculum, there is MapReduce. And why you are learning MapReduce? Two reasons. One is migration. A lot of companies will already have a lot of MapReduce programs and they want to go to Spark. So if you want to go, you should know what is MapReduce. Second reason, even for learning Spark, the concepts of MapReduce are important. Spark also was built on the basic idea of MapReduce. So how MapReduce works, how the program runs, these basic concepts, if you can understand, that will help you to learn Spark in a better way. That is the reason we are learning Spark, MapReduce actually. In the enterprise, totally gone. There is nothing called MapReduce so far.
What is the Java framework and the coding?
No, Spark uses Python in your course. That is the reason I am not teaching Spark. So initially, Great Lakes asked me, can you teach Spark? I said yes. And then there was a problem because I teach Spark using Scala. I am a Scala developer. You are learning Spark using Python. Spark can be programmed in 4 languages: Scala, Python, R, and Java. 4 languages are there. And you learn with Python. I'm not a Python guy, so that's the reason I am not teaching Spark. I actually like to teach Spark because most of my trainings these days are on Spark, actually. But I know Python also. I can teach, but not immediately. I said we'll pick it up later, probably, and teach that. Sorry. Scala is similar to Java. No, not like, similar to Java 8. If you know Java 8. It's a glorified version of Java. Actually, Java 8 was developed based on Scala. So Scala is another programming language. It's a very nice language actually, but I don't know, people do not really like it. Okay, so like it in the sense it's not as popular as Java, right? Java is very popular, but Scala is not so popular, but it's a very interesting programming language. I use Scala a lot in my programs and trainings and all. Anyway. So any other questions before we go to Hadoop and architecture and all? Not many questions. So if there are no questions, ideally, either people understood everything or they understood nothing, right? So both.
So Hadoop is basically replacement for data warehouse, right?
Yeah, you can consider, but it is not just a data warehouse. That is a difference. So you will see soon what is the difference, because if I am buying a traditional data warehouse, it can do only one thing. It can become a data warehouse. I can't do anything else. Hadoop is not like that. It can become a data warehouse and much more, and we will see that.
So new companies will never go for data warehouse. They'll start with
No, they still, so your architecture is,
a new company who just starting and then who starts saying, when they go to data warehouse and migrate, or they directly go with the new platform.
See, now the situation is very complicated actually, because if you are starting a new company, and ideally you don't have much money, what do you do? You go to cloud, right? So every solution is offered in the cloud, and typically companies will go for this Hadoop and all are available in cloud also. So they will go for cloud distributions. And so always you cannot say that Hadoop is 100% replacement of data warehouse. Okay, it can work as a data warehouse, but performance considerations are there. So sometimes you might need some reports within milliseconds, second, 2 seconds, which probably Hadoop may not be able to do. Hadoop is a batch processing system. It's not real time. So if I have Teradata or what is that, Exadata, Netezza, these guys are really fast, right? MPP. So what companies do, they keep the hot data there. Probably my company has 100 terabyte data. In that, 2 terabyte data I need every day very fast. I'll keep it in Teradata. 98 terabyte I'll dump it in Hadoop. I need it once in a while, and even if it takes some time, it is fine. Okay. Same story with the cloud. So most of the organizations are now deploying everything over Amazon Web Services. So Amazon offers fully managed Hadoop solutions on the cloud. Like you can go to Amazon, ask it, give me a Hadoop cluster. In 10 minutes, you will have fully functional Hadoop solution. Everything installed, up and running, servers, everything. Automation, right? So there they also give you data warehouses. They have something called, what is their data warehouse? Redshift. There is a solution called Redshift. Redshift is an online cloud-based data warehouse. So Amazon offers Redshift to you if you want hot data to be stored. So like I said, everything cannot be given in one solution. You need cheaper, you need the same speed, everything you have to package in one solution. It may not be possible, right? So like someone was suggesting, right? You can compromise speed either, right? Or real-time access, right? So same like that. So Hadoop is a solution most of the people adopt, but not everything can be guaranteed at the same time. Okay, so that takes us to the question, what is Hadoop and why this is so popular, or what is the architecture of Hadoop? It's fairly easy to understand actually, because the idea is very simple. I have a single machine. How much amount of data can I store in a single machine? What do you think? I'll give you a server. How much will you store?
Based on my number of orders.
Based on what?
The capacity of the order.
Okay. So, and that is based on what? Yeah. So storage capacity, how do you decide? If I give you a server, how many hard disk or how much space you can dump?
Sorry, can you repeat?
Yeah. So I'll give you a server. How do you decide how many hard disk I can add in that?
Based on the operating system that can handle the
Motherboard, right? Motherboard is who decides. So the motherboard will say, I'll support 10 hard disks. You can have 10 hard disks. So the idea is very simple. So people initially thought I can use one machine. And when that machine was not sufficient, what they did? No. No, distributed computing did not came so early, right?
big servers are.
They added disk, they reached this disk. So one machine is over. What do you do? Huh?
Archive the data.
No, I don't want to archive. Super computing. No, I want cheaper. I can't sell my house. Now, another machine is what I'm going to talk, but in between something came.
Clustering, right?
External storage, NAS and all, right? Network storage. Probably you guys are not much from storage background. There was something called network attached storage. Very, very popular. Have you heard about EMC and all? Company called EMC Square. They survived only because of these things. So you have something called network attached storage, NAS box. You can buy a box, install the box anywhere, and you can dump the data there. So the system can dump and process from there. That is called NAS. So that will support more storage actually, but it is not within the machine. When NAS was not enough, came SAN, storage area network. SANs are even popular these days, okay? So a full room full of hard disk, you get a fiber channel connection. So if I can dump all the hard disk there, I can store as much as I want. But the problem is, even if I'm using a SAN, this is my SAN. This gives me unlimited storage. Okay. Problem is, it gives me only storage, no processing. If I want to process the data, can one server process all the data in a SAN? No, not possible, right? So processing cannot happen. Storage can happen in a SAN. And SANs are very costly, clumsy to manage. You need separate people to manage and all. So people got fed up with SAN also. So NAS was there, SAN was there. So, and that is where you started thinking about distributed computing. Distributed computing is not a new idea. It was already there. Okay. So in Hadoop, what we are doing is very, very simple. Rather than one machine, you take a bunch of machines. Okay. So I will say the bunch is, just for sake of argument, 4. Okay. So I take 4 machines. 1, 2, 3, 4. These 4 machines are, let's say, Linux machines. To be fair, they can be Windows machines, but the support for Windows is very limited in the open source community. So typically we recommend the boxes to be Unix or Linux. So I take a bunch of boxes, say 4 boxes, 4 servers, right? And I can download and install this Cloudera or Hortonworks, any of their Hadoop on this. While installing, it will ask me which machine is master, which machine is slave. The idea is one machine has to be master, the rest of them can be slaves. So in this architecture, I come up with an idea. One guy is master and 3 guys are slaves. Fine. So we have not discussed what is the master doing, what is the slave doing. That's later. Okay. But you install Hadoop in a setup that when there is one master and let's say 3 slaves, right? Now the idea here is that if I want to store anything, okay, Hadoop will help me to store among these 3 boxes, right? So I can use the storage space of all 3 boxes. So if each of them are having a 2 terabyte hard disk, I will get a total capacity of 6 terabyte in my Hadoop cluster. This is called a Hadoop cluster. A cluster means a group of computers where Hadoop is installed. Yeah, so Hadoop is a framework actually. It is not a software. So one confusion people have is that is Hadoop a software? No, it is a platform. Okay, and I will show you the different components we have in the Hadoop platform. So if you install Hadoop, let's say we don't know anything about Hadoop, but let's say we install it in a 4 system setup. While installing, it will ask you to select one as master, remaining as slave. So I have 1 master and 3 slaves, right? And what Hadoop can do, it can take the storage space of all these 3 machines and project it as a single 6 terabyte storage box, right? So the beauty of this architecture is that let's say you start dumping the data and the data gets stored here. And let's say your 6 terabyte is over. I can add machines on the fly. From 3, I can expand to 30,000 without shutting down the cluster. Meaning your storage problem is solved. You don't have to ever worry about storage in a Hadoop cluster. Hadoop allows you resizing without any downtime. So I can add more machines or I can remove machines, up to me to decide, right? I'll tell you how the data is stored. I will come to. So as of now, we have not discussed storage and processing. I'm just giving you a 10,000 foot overview, like what is happening in a Hadoop cluster. So one of the advantages is that you can start with like 3 machines and expand to 30, 300 or 3,000 machines. Yeah. Yes, you can also add. When you have your data here and you are analyzing the data, okay, I can keep on adding machines without shutting down them.
So even though my programs are running with the Hadoop framework,
yes,
I can simultaneously add machines or remove.
You can remove, but if you're removing, it will have a problem. For example, if the program is running here, if I remove it, the program might crash because this machine is needed. That is not the idea. If you have one more machine here where nothing is running, I can remove it gracefully. Nothing will happen. So you are getting something called scaling out. This architecture is called scaling out, meaning you keep on adding more machines so that, you can get unlimited scalability. Now I will tell you how storage happens. I mean, so far I did not discuss how storage happens. Yeah.
Why is it not possible in relational database?
Which one?
SQL.
This sizing.
Yeah.
It is not possible. SQLs are designed in that fashion. If I want to modify anything, I have to first stop reading and writing from my database. Then only I can alter my table or increase anything or decrease anything. Probably I'll be able to add a machine extra, but it doesn't make any sense in a SQL world actually. And in a SQL world, I cannot come up with a 30,000 server setup. That's impossible. Cost, first of all, scalability. Like I said, the major difference here is that in the SQL world, logical division of data, you cannot physically divide the data. So when you're logically dividing the data, like I said, country India, 2 crore people. And if one machine is taking that, it will have more data, another will have less data. I don't have any way to manage it. Here, that will be handled. I'll show you how that is happening. So this is called a Hadoop cluster. So the technical term for this is a cluster. Cluster is nothing but a group of machines, right? So that is available in a Hadoop cluster. Now, typically, if you go to companies and check with them, like I was with this 24/7, a company called 24/7. They are a called center company, and they run Hadoop clusters for analytics and all. They had a 50 machine cluster, 50 node cluster. Each node has around 256 GB RAM and 10 terabyte storage. So 50 into 10 is what? Sorry, not 10. What am I saying? 100 terabyte storage. So 50 into 100 is what? 5 petabyte of storage they had, and 256 times 50, that is the RAM capacity of the cluster. That is a very minimal Hadoop cluster, cheap Hadoop cluster. So typically you'll have 500 nodes, 1000 nodes Hadoop clusters. Because the amount of data you're storing is in petabytes. 1000 terabyte is 1 petabyte actually. So most of the companies, they will have huge amount of data to dump in this. So the size of the cluster will be in that level actually. And Hadoop is distributed, meaning if you install it, it is not getting installed in one machine, it is installed in all the machines, and the components will talk. So it runs in a cluster, not in a single machine or two machines actually, right? So the basic idea in storage is that you can add more machines and get more storage, right? No. I got your question. What if the master goes down, right? I'll come back to that. Now, the slave will be acting only as a slave, actually. Yeah, so good question. Another thing is that, let me ask you this question. So, I am asking you to build a Hadoop cluster with 50 machines. Take an example, 50 slave machines. That is 50 servers. Do you really think it is a cheaper solution in terms of hardware? Like you buy 50 servers or 500 servers, isn't that really a cheaper solution? What do you think? Yeah, so let them say. Correct. Now, my point is, if let's say you're buying 500 servers, each server will cost you some money, right? So if I say 500 times that money, right, it is really a huge amount of investment for me. That is the reason we call these machines commodity hardware. What do you mean by commodity hardware? Commodity hardware means any machine without any label. You will never buy a Dell server to build a Hadoop cluster. You will build it with cheap throwaway servers. Right? You are not going to buy a Volvo bus. You are going to buy a TM, what is that? Tamil Nadu. I'm not blaming Tamil Nadu. Don't take it regionally, okay? Even Kerala, whatever. You're not going to buy a Volvo bus to accommodate your passengers. You're buying a bus, which can break down at any point in time. See, you want to carry all your citizens. Will you be buying only Volvo buses? No, right? If you look at most of the buses that are here, what is your idea? Citizens need to travel from one point to another point, and the bus should be there. That's all. You are not investing crores in buying Volvo buses everywhere, right? You buy just some bus. Same idea here. In a Hadoop cluster, typical Hadoop cluster, the machines that we use are called commodity hardware. Commodity hardware means assembled servers. So you can get it actually. So you're not actually buying an IBM server, because I was also working as a design architect for one of the Hadoop solution. There we got servers for around 35,000 rupees, 40,000 rupees. 40,000 rupees you cannot buy a server. If it is an IBM server, you will pay 2 lakh, 3 lakh. So this was like somebody will assemble and give you. The only thing it will work, it will crash also. It will definitely crash, 100%. So then you will be thinking, if I'm having a 500 node Hadoop cluster, if my slaves are crashing, what is the reliability there? I will answer that question. Just park the question for the time being. No. Server is just a big storage box, right? Storage and processing. Yeah, so server is what? A server is, so this is your desktop, normal desktop, right? So normally you have something called desktop at home and all. Server is something which can serve multiple clients in one way. It is a bigger box with bigger storage and processing. So if I want to buy a server, I have multiple options. One is that I go and tell IBM or Dell, buy me a server. So they will give me a branded server. So they will charge a lot of money. They will also give me support and all, but I have to pay 2 lakh, 3 lakh for a server. So normally when I say server, this is what people buy. But in a Hadoop cluster, you never do that. You buy cheapest servers possible. because you can afford to have failures in a Hadoop cluster. I'll show you how failures will be handled in Hadoop cluster, but you are not investing a lot of money on the hardware. That is the idea, because otherwise the solution is not feasible. If I'm buying 500 IBM servers, I can take the same money and give it to Teradata. So as good as same thing, right? So I don't need support or anything. I just need some normal machines. And Hadoop also does not say what kind of a machine you need. You can even build a Hadoop cluster using desktops if you want. Performance will be less, but it will beautifully work. Or laptops or anything that you want. It doesn't say that, right? So that is the, so I'll keep this diagram because I need this diagram again. That is why I'm not removing it actually. Yeah. Right, correct.
But I may teach Teradata stage also.
Right. So new businesses might take Hadoop more because after 5 years, I may not buy Teradata, right? If this is a situation, I might buy a Hadoop solution probably. I'll tell you what is the biggest challenge in my experience, in my consulting experience. The biggest challenge is knowledge. See, all the companies want a better solution only, right? No company want to unnecessarily pay money. But one thing is that if it is a Teradata solution, in the market if you go, there are a lot of people who understand data warehousing. Data warehousing is not a new concept. If I go to the market, I can get n number of people who know what is data warehousing and they can easily install a Teradata for me. I just have to pay money. But building a team of Hadoop expertise is not easy. That is why you're sitting here, right? If I go to a company also, if all of them have to understand how Hadoop is working, and Hadoop is not like click, click, install. There are a lot of things you have to configure and tune. So people don't want to spend that much of a risk. So one reason is that the knowledge curve we call, right? The learning curve is a bit high. You can't learn it in a day and say that, okay, I'll implement Hadoop. It's not possible, right? So most of the companies are stuck in this position. I'll tell you a real story since you asked this question. So when I went to one of the companies for training, okay, the company said that we want to learn Hadoop basics. I said, okay, no big deal. I'll teach you Hadoop basics. I went to the company. I started the training. They started asking me like a name node, block size, which are all related to Hadoop. I said, hey, I'm teaching you Hadoop basics. You're asking me all these questions. They said, we already know Hadoop. Then why am I here? They said their company got a project related to Hadoop. They implemented Hadoop. They're working on Hadoop for 2 years. Okay. They learned everything on their own. Now they want some training to clarify everything is correct. No, it's actually something really happening. You check with any of your friends who are in any company who are working in big data, they will tell the same story. Because the manager will say, okay, tomorrow your big data project will start. Those who are here can join. Half of them will run away. Okay, half of them will stay. Okay, and these guys have to learn on their own. I am able to share this experience because I go to many companies and most of them are self-learners. There are no resources or training programs like this to learn. They will sit and learn on their own and then learn over a period of time. So that is another problem because if I want to learn Oracle, I can get official trainings a lot. And I have a lot of people who know Oracle. They can teach me, right? So the learning curve actually makes a problem in these cases actually. So I think you guys are better because you will know all this, right? If you're joining in a company, you can say that, hey, I am aware of all these things. Probably you can get an immediate project. Anyway, you are learning to get a job, I believe, right? End of the day, your idea is to get a job, right? I'll show you. I'll show you the architecture. So now what you need to understand. So since we were looking at the high level definitions only, let's dive a bit deeper. Hadoop has 3 major components. There is something called HDFS. There is something called yarn. I can share the slides and PDF. If you want, you can make a note. That's all. It's not mandatory. Third is called MapReduce. So when you download and install Hadoop, only Hadoop, these 3 things will come by default. HDFS, yarn and MapReduce. These 3 components will be installed by default. And you don't have to do anything. They will get installed, right? In this guy is the storage. This guy is handling storage. Okay? This guy is resource management. This is the resource manager. This is processing. The pen is not writing. So HDFS is the guy who is responsible for storage.
You need to say that this is the software piece that manages this.
Inside. So if you're installing Hadoop, it'll have 3 components actually. You can see them actually. HDFS you can click and see. I'll show you. Okay. So HDFS stands for Hadoop Distributed File System. It's a file system actually. It is called Hadoop Distributed File System. I'll write it here probably. Hadoop Distributed File System. That is HDFS. Now, from your course point of view, HDFS is important because this talks like how the data is stored. Yarn is not that much important, but we will cover yarn. MapReduce we will learn for sure. So MapReduce I'm pushing for tomorrow. So the processing part we will do tomorrow. We are not going to learn how to process the data today. Okay, because if I teach everything also, end of the day you have to go back and recollect all these things, right? You will not get it. So this part I'll push for tomorrow. And how many of you are from Java background? Oh, some of us are here at least. Okay. So because MapReduce is actually in Java. Okay. So we will look at the code, and many people are not from the Java background also. So, and like I said, in the industry, it will never happen that you have to write a MapReduce code because MapReduce is gone from the industry. Migrations only happen. So even if you are able to understand the logic, that's more than sufficient actually. So first, let's look at this guy called HDFS, right? What HDFS is doing. So I will probably push yarn and MapReduce for tomorrow because once I complete HDFS, I just want to show you something called Hadoop ecosystem, okay, which I have to draw here. So we'll complete HDFS storage part. Yarn is a simple piece. MapReduce anyway tomorrow we'll be covering, right? So this is the guy who is handling the storage. And a lot of you are asking, how do you store the data in Hadoop, right? Okay. Is this pen? This is gone actually. We have extra pen. This is not writing actually. This one. These are used pens, I think. Also, is it red and green? You'll get black. This is okay, I think, right? Yeah. So let's take a hypothetical situation where you have installed Hadoop in one master. Okay. And in my example, we have 6 slave machines. Now, this picture will pose a lot of questions usually, okay, and that's okay. So there is one master and 6 slave machines, and we are talking only about storage, no processing. The master will have a process called name node. The master machine will be running a process called a name node. When you install, it will start running this process called name node. Okay. The slaves will be running a process called data node. Data node. So I'll call it as data node 1, 2, 3, 4, 5, and 6. So technically we will say that there is 1 name node and 6 data nodes. I mean, that is how you say in a Hadoop cluster, right? So name node is the storage master and data node is the storage slave. Okay, so thus far we have understood. Now, the next thing is that let's say you want to store a file in a Hadoop cluster. Hadoop does not care what you're storing. Meaning you can store any format. Can be XML, JSON, images, video. Hadoop doesn't really care what format of data you are storing. While processing, you have to make sense of the data. So that is in MapReduce. If I stored a text file, I have to write it in MapReduce that read this text file and do whatever I want to do. The HDFS file system does not really bother about what type of data you're storing. Second point, and probably the most important point, is that once you store any file, you cannot edit it. Modifications are not possible. You store it, delete it, that's it. In HDFS, modification is impossible. And now you have to understand these facts really well because you get confused later, right? So how will I edit? It is not possible in HDFS as it is. So why, you may be asking why it is not possible? Because HDFS is designed as a file system for handling huge amount of data, terabytes and petabytes amount of data, right? And if I want to modify or edit, row by row, like in a transaction that is happening, it is not possible, because if you look at a hard disk, right, there is something called seek time. If a hard disk want to fetch a record, there is something called seek time, right? And if I'm having 1 terabyte file, I want to edit the 100th line, it's not possible for my hard disk to seek and get the data in that. Because you're using all commodity machines here. They are not even faster. I'm not using solid state drives or anything. Very commodity level hardware I'm using here. So Hadoop's idea is that you want to read files sequentially. There is no random access. There is only sequential access. So if I store a file, I can read the entire file and process it. I cannot say needle in a haystack problem. Needle in a haystack problem, meaning if you have a 1 million row table, you cannot say take the 100th line and edit. Not possible in Hadoop, at least in Hadoop. It is impossible. So either you can read the whole data and process it. That's all you can do. And the result can be stored, obviously. If you process the data, you get some result that can be stored. But on the file system, editing is not possible. You can't edit.
You need to say when HDFS is concerned alone, editing is
not possible. But directly update is not possible. I cannot open a file and update, say. That is, appending is possible. Appending is always possible. I have a file, I want to append the data, that's okay, because you are just adding in the end. But I'm just reading the 100th row and edit, that is not possible. Now you may be wondering, what if I want to do it? There is a solution. You can do it. You have MPP engines on top of Hadoop which can do it. I'll show you how to do it. I mean, it is possible, but considering only HDFS, ideally if you're storing a file and you got some modifications in the file, you delete it and restore the file. Meaning you don't edit it actually, right?
Can we take the whole file?
Can we take the?
Can we take the whole file?
Yeah, you can delete. You can delete the whole file. Delete is possible. I am saying that minute edits are not possible because Hadoop is considered to be a system where you are doing analysis of the data. It is not transactional system. Where will your minute edits and all come? OLTP systems. If I'm having an RDBMS, I want to do insert, update. It's not an RDBMS, right? If you're an RDBMS world, it is possible. I don't have any objection. But here it is not possible by default.
Those days, storage is costly. They needed an update.
Exactly.
Storage is not costly.
Not costly, exactly.
So update is then
Correct. And also, we are not doing any transactional, it's not a real-time transactional DB, right? So I don't want to minutely edit also. But worst case, if I want to do it, it is possible. So we have MPP engines on Hadoop which can do it actually.
One more thing, right? If at all if you want to read one particular record, it must not be read.
Exactly. So if I'm storing a 1 TB file, if I want to process the file, probably I want to process only the 100th line. I have to load the 1 TB into RAM with HDFS alone. So then the business use cases will come. So that is where you need to make a decision. I will train you on that. Meaning, if I'm writing a group by query or an aggregate query, right? Probably I need the whole data. I have a very big table. I'm writing an aggregate query, right? Which will say group by and order and something like that. It makes sense I load the full file because I don't know where is the data. Whole data need to be scanned probably. But if I'm doing a select something where name equal to something, name equal to Raghuraman, only one line need to be processed. For processing only one line, why should I load the whole data? Not required. For that, you have an option. That's called MPP engine. I will show you how to do that. A massive parallel processing engines on Hadoop. So you have tools like Hawk, LLAP, Impala. So there are some guys who can do that actually, and I will show you how they work on that. No. They are dumping in data warehouse, right? From there, they don't want to update. Transaction data update happens here, right? This is where the transactions are happening. Correct. So this is where customers are placing their order, and this data you don't want to change. This data was created by customer. I just want to get the data, right? Probably I want to modify and get it. So once it is here, I don't want to make any changes. I just want to analyze the data. We will see that anyway. Now let's take a hypothetical situation.
One last question, like name node has the store any of the data?
No, I'll tell you what is the role. Okay, so what is going to happen? Let's say that you want to store a file. I got a new marker, by the way, right? So let's say you want to store a file of size, I don't know, 192 MB. You have a file, text file, imagine, and you want to store it. The size of the file is, we'll take a break at 4:30. Okay, it's 4:10 actually. So probably we'll take it at 4:30 anyway. So the file size is 192 megabytes. You want to store it in a Hadoop cluster. Now, there are a lot of things which actually matters to your real-time experience. Here we are just learning the basics, because in a real company, if you want to connect with a Hadoop cluster, the Hadoop cluster will be somewhere else. So if you are sitting here, the Hadoop cluster will be separate, you will be separate, right? So you will get something called a Hadoop client package. Okay, so one way is that you get something called a Hadoop client. Using that, you can access from your laptop. Second is that you can log into a node. There is something called a gateway machine. This is called gateway machine. So if I am sitting here, this is me, very nice, right? So I can just connect to this machine. From this machine, I can connect to the Hadoop cluster. You don't directly get inside the Hadoop cluster. That's my point, for security reasons and many other reasons. So companies do two things. Either they will install something called a Hadoop client. Even that is very rare. What we used to do, there will be a Linux machine called gateway node. You will get a username and password. You type it, you connect to this machine. This machine will already know how to reach here. You don't have to worry. You issue the commands here, it will run here. Got it, right? But whatever way. So let's say you want to push this 192 MB file from your machine. You connect it to the gateway machine. You said, okay, upload the data. What is going to happen is that, first thing which is going to happen is that your name node machine, this is a master. This guy will tell you something called block size. There is something called block size. This block size can be configured for every Hadoop cluster when you are installing Hadoop. So I am assuming that the block size for this cluster is 64 megabytes. So what is block size? Block size will tell you what is the maximum size of data that you can store. Meaning, if you are storing a 192 MB file, what will happen? It will divide that into 3 blocks. Same thing happens on your laptop. If you're storing a song on your laptop, what happens? Will the song get stored as it is? What do you think? Okay, you store a song, MP3 song, right, on your laptop. What do you think? The hard disk will actually take the song as it is, or it will divide it? It will divide it. It will not store as it is. I think Linux uses 4 kilobyte of 4 KB block size. Linux. Windows also uses similar. Any file system will chop your data and store. Same thing happens in Hadoop also. So I am assuming that this Hadoop cluster has a block size of 64 MB. So this name node will get back to your client package and say that divide your file into 3 or whatever you want, because the block size is 64 MB. So what is going to happen? This file will get divided into 3 blocks. You don't have to do this. This will happen behind the scenes. Like, you don't have to say that what is your block size. It will happen automatically.
Who will do that?
Hadoop client package.
But in this case, gateway.
This gateway has Hadoop client installed. That is what. So this Hadoop client on the gateway will already communicate with name node. Name node will say that, boss, in my cluster, the block size is 64 MB. You manage yourself. So the client will divide your data into blocks of 64, 64, 64. Total is 128. So now you have 3 blocks, B1, B2, and B3. You have 3 blocks now of the data, right? And then again you go back to the name node. You ask the name node, I have 3 blocks. Okay, now tell me where to store. And the name node, what it does, it has communication with all the data nodes. It knows how much space is available. It will tell you that do one thing, store the first block probably here, just an example. Store the second block probably here, B2. Store the third block here, B3. Most of the cases, the name node will give you different machines. It will never allow you to store everything in one machine. So you divide and distribute. That is how you're storing the data. So now your data is divided into 3 blocks and they are stored in 3 different data nodes. So this is like 6. In reality, you have 500 machines. So 3 blocks is easy, right? But sometimes a couple of blocks may end up in one machine also, depends on the storage. But ideally, it gets stored like this. Now you may be wondering why the block sizes, it's not random. It has, name node has an idea like how much storage space is available on each data node. So it will come up with the free machines. Okay, within that, it just picks randomly 3 of them and say that you dump it there.
What is the need to do that? It can store 3 blocks in same machine?
Yes, that has to do with processing, and I will tell you. So if you think logically, now if I want to process this data, okay, 3 machines can process this data, right? If I store all the 3 blocks on one machine has to process 3 blocks, right? That makes a difference, right? So ideally, you divide and distribute the data. Most of the cases. You don't have to do it. Name node will do it for you automatically. This is all inside a LAN. This is all inside a LAN. All these machines are communicating with each other. The data nodes all send a heartbeat to the name node saying that they are alive also, so that the name node can detect how many of them are alive or down or anything. But yeah, so but now we have a problem. What is the problem? If this machine crashes, because this is our BMTC bus, right? It's not a Volvo bus, right? And it can crash at any point in time. If this crashes, my block 1 is gone. I can't get my data. So by default in Hadoop, there is a replication of 3, which means each block gets replicated 3 times to other machines. I'll just draw this, then come to your questions. Give me a moment. B2, again B2, and I'm just drawing randomly. I mean, just taking that these are the machines. B3, probably from here. B3. So if you look at each block is replicated 3 times to different machines. So now let's say this machine crashes. This B2 is still available here and here. I can recover it from here. And now what happens is that the name node will store the metadata. Meaning the name node will write here, there is a file called abc.txt. It is divided into 3 blocks. Block 1 is available on where? 3. Where is it? 3, 2, 6. So B1, 3, 2, 6. B2 where? Where is B2?
4, 5,
1. B3?
2, 5, 6.
Yeah. So this is your metadata. Meaning, if tomorrow you want to read the file, you have no clue where is the file. You just go to the name node, not you. The Hadoop client will connect with the name node, and the name node will pass this information. You go to B1, B2, B3. Sorry, you go to data node 3, 4, 2, you will get it. If any of them are down, it will give the alternative one. So the purpose of your name node is to actually store the metadata or the index. And if the name node crashes, you cannot access the cluster. That is for sure. Because if the name node is gone, then everything will be gone. To prevent that, in most of the Hadoop clusters, you will have an active name node and a standby name node. Meaning, there will be 2 name nodes. These 2 guys will be in constant communication. So if the active name node crashes, the standby will take over. I will talk a little bit more about this later, how this active standby is working. But you don't have to worry. If the active name node crashes, standby will immediately take over. So now coming to the questions. Yeah, please. Correct. Now 3 blocks are there. The replication. 3. Sorry, repeat it. Very rare. All the 3 nodes going down at the same time is very, very rare. Even though we say commodity, they are not really commodity these days. I mean, even though we say that Hadoop, because the storage and server cost is very cheap these days. So all the 3 machines at the same time going down is very, very rare. But what is the other possibility? Kim Jong fired a missile, right? From North Korea. What will you do?
Nobody will be there to run the query.
Exactly. Nobody will be there, but let's say King John fired only to Chennai, okay? And so in Chennai, the Hadoop cluster is gone, right? So what you do? You are not there to run the query, but the company should survive, right? Disaster recovery will be there. So typically we set up a DR, disaster recovery, and the disaster recovery, to set up that, there is a company called Van Disco, dance. Van Disco, very interesting company. So Van Disco is one of the popular companies who set up disaster recovery for Hadoop. But you don't do disaster recovery like in traditional systems. Meaning, if I have a 100-node Hadoop cluster, I won't set up a 100-node backup cluster, right? That is waste of money. Very rare King Jong will fire a missile, right? If he fires, God saves, right? So what I will do, even in the Hadoop cluster, you have to classify the data. You are storing 100 terabyte data. Probably not all 100 terabyte is so important, right? Is it? No, a lot of data is like archival and all. So in the 100 terabyte data, I will identify probably 10 terabyte, which is very critical. And I can periodically back up that data to my DR center. I don't set up a 100 node cluster in Noida to back up a cluster from here. So we use a tool called distributed copy, distcp in Hadoop, that can synchronize these 2 clusters, primary backup. Distcp it's called, distributed copy. I'm not lying, so some people say I'm making up stories. I'll show you. Yeah, so very excellent question. I'll just come to that. Just give me a moment. So go to Van Disco. Very interesting company, right? I like the name. Who named the company? I don't know. Van Disco. So Van Disco is not only a Hadoop company, by the way. They provide replication solutions. Solutions, backup, disaster recovery. If I go to disaster recovery, why your internet is very, very slow, right? See, it is not even opening up the page. Yeah, disaster recovery. 100% Hadoop availability, right? See, this is what I'm talking about. We used Van Disco in one of our projects. That is why I know. Usually people do not be aware of these things. So I was working as a Hadoop administrator also for some time. That is why I know this, because these are all like real-time things. Okay.
I have a question.
Sure.
Said about the command, right?
Sorry. This CP is the tool.
Yeah, tool. Why I want to rely on a third party just for this disaster? I know like what is my data.
Yeah, it is same thing. Yeah, but managing this on your own is very difficult actually. DistCP can be run, I know that, even Cloudera and Hortonworks supports, but there are a lot of things you have to consider in running DistCP. First of all, resource utilization will be a problem because you keep on reading and writing the data. Second, if it fails, you don't know how to manage. DistCP can fail at many point in time. So if you are implementing Van Disco, they use DistCP only again, but they have their own ways to handle it actually. I mean, they'll ensure the replication happens properly. You don't have to bother about it. Now, I'm not suggesting that you must use it or something. If you want DistCP, you can do it on your own. Even Cloudera provides their own some tool for disaster recovery for Hadoop actually. But we are here, right? So my question, why the block size is 64 MB, not 4 KB? Block size can be 4 KB, right? Maybe, I don't know. I'm just asking questions. Seek time. If I'm storing in 4 KB, I can't read. How do you read 1 TB? You want to? Exactly. Now, this I showed you because my math is very weak. 64 times 3 is 198. I know that. That is why I showed this example. In real production cluster, the block size is 128 MB, not 64. I don't know what is 3 times 128 MB to be honest. Okay. So real production cluster block size is 128 MB. It is configurable. They use 64 also. There is a parameter I'll show you where you can change block size. Okay. Hadoop, the default block size is 128 MB. You should also know, also understand one more thing. There are 3 major releases of Hadoop. Hadoop 1, 2, 3. Hadoop 1 is the older release and nobody is using it these days. So you don't have to worry about Hadoop 1. It is not available in production right now. 2013 was the last year when this was used. So no longer used. Hadoop 2 is what you are using, I am using, we are using. This is the current edition. Hadoop 3 released in 2017, December 15, like 3 months back. Okay. Now let me ask you a question. If you are storing 100 terabyte data in a Hadoop cluster, how much storage you need?
300.
Is that true?
No, it can be more than 300. We need to add software also running, right?
But only replication considering 300, right? Into 3. Is it good or bad? Bad. What is your thoughts? I mean, see, trainings are always interaction, right? I might know a lot of things, I might not know a lot of things you know, right? So you can, so what is your thought on that?
Fault tolerance can be achieved, right? So 2 can be fine.
2 can be fine. I don't know, I'm just asking. I mean, it's not a yes or no question. I'm just asking, what do you think?
Storage are really cheaper.
It depends on how much you are about to lose the data.
So there are multiple approaches. One thing is that some companies, this replication factor can be changed, by the way. It's not hard coded. Some companies say 2, right? So you get 2 copy of data. Also, while copying the data, you can mention the replication factor. Very interesting thing. I am copying a file, 1 TB file. This file I can afford to lose. I can say copy with replication 1. But it had led into a debate in the Hadoop world. So a lot of people said that this is very bad actually, because 3 times replication means you are losing a lot of space. That is why in Hadoop 3 there is no replication. Very interesting point. I was just beta testing Hadoop 3, even I don't know completely. In Hadoop 3 we use a technique called erasure encoding. It is similar to RAID, RAID 1.0, parity. How many of you are aware of it? Parity based RAID. Okay, there is something called RAID, not the Akshay Kumar movie, something better. Okay. Redundant array of independent disks. That's called RAID. RAID is a fault tolerance technique. Okay. So based on RAID, they have formulated a new strategy in Hadoop 3 where you don't replicate the data. There is another technique called erasure encoding. If you enable that, you can still recover the data if it fails. They say it will use only 30% of additional storage. Meaning, if you are storing 100 GB, you need 130 GB. Better, right? Much, much better. You don't need 300 GB. But Hadoop 3 will not make it to production very soon. So don't worry, right? Still we are on Hadoop 2. Who needs tea break? Yeah, tea break. So you want the question or you want the break?
Finish this question.
Huh?
We'll finish the questions and we'll add anything.
Oh, so you guys are too interested actually. I thought you will all sleep in the class. We should get the Hadoop class in the morning and the other class in the evening. Right? No, don't do that. Why?
It should be reversed.
Why?
So that is more theoretical.
Statistics is good. I actually wanted to learn statistics. It's good, right? I can probably come and sit in the morning probably. Now, statistics, if it is in the afternoon, you will definitely sleep. 100% guaranteed. I'm not blaming the trainer, okay? Don't take it that way. Statistics itself is a subject which is a bit boring actually, right? Today. No, tomorrow again, second half I am coming.
No, I'm talking about last week's statistics for second half.
Is it? So first half what you learned? R programming. Oh, okay. You got it.
But I have one fundamental question.
Huh.
When it's a text file, I can understand we split the files into 3 different
And dump it.
You can read it individually. Okay, it gives some meaning.
Yeah.
What if it has some other file? Let's assuming it, I do not know whether it makes sense. Picture file. The bigger picture file.
I will give you a solution. So the processing has to be handled by the framework. So we have something called MapReduce. In MapReduce, you have a Java class. There is an abstract class in Java. I mean, so for those who do not know Java, there is a class, there is a technique where you tell what type of a file you are dealing with. And there are only limited types. You can read text, XML, sequence file, key value. So some limited number of types of files are there. And how do you, so this is a very good question. How do you handle unstructured data? So it is also a very confusing concept. Many people believe that in the world of big data, you are always playing with videos and images. Actually, no. See, many people believe every day you'll go to office and run some facial recognition like you see in the Mission Impossible movie. And yes, I got big data. No, you don't do that actually. You can analyze images and videos. There is no doubt. It's very difficult actually to do. Analyzing video and image data is very difficult because you can't directly analyze it. You have to convert it into binary. Once it becomes binary, in Hadoop you have a format called sequence file. You have to read it as sequence file and write a program to analyze it. It's actually a very difficult job to analyze these kind of files, and not everybody need to analyze it. Let me give you a real-time example. I was working with 24/7, right? The customer care company. What is their primary business? Customer care. In customer care, people call, right? Do you think they will listen to what customer is calling? Yes or no? So you are running a customer care company, not your company. You are giving support to other companies. And you are running a call center. In a call center, customers will call, right? Do you actually listen to what they are talking? Let's say take IDEA for example. How many calls IDEA will be getting in customer care? Do you really think they analyze your calls? Two things. One, it is legally not possible, I think. I'm not 100% sure. Maybe it is possible.
But they say that now we'll be calling it, your call may be recorded for
Fine.
blah blah purpose.
Fine. That is just for the quality, accent and all. That is not doing big data analytics. For example, if you were an angry customer, you spoke for 1 hour, that call is recorded. The person who took the call will go to the manager, and the next meeting, manager will analyze that call and say that this was your mistakes. I am saying, do you actually analyze big data analytics on these kind of things? Not really, right? You will analyze the metadata, not the actual data. How many people called? What was the duration? What they pressed? This is the data, not the actual audio data. Because you can do it. I'm not saying it is impossible, but then you have to. So how do you understand what he is speaking? You need voice recognition, right? And it may fail, it may not fail. You are not 100% sure. If it is a US customer or something, we can approximately match. If it's an Indian customer, how do you identify all this? It's not possible, right? He may speak any language, any accent, right? So practically these things are not possible. I'm saying you can analyze unstructured data. There is no doubt about it. And companies like Facebook and all do. Facebook actually analyze video data. They have to, for some reasons that they have to do, right? And there they have written complicated algorithms to read and convert to binary and all. But if you are going to work in a regular project, you will all see structured data, CSV files, JSON data, normal text data. But if you're storing also, so you need a class to read these type of files. That's what the question was, right? Yeah, sorry.
This replication factor, suppose one data node goes down, do Hadoop framework again replicate that one?
Oh, that's an excellent question. I also missed another question from this side. That was same question? No. Yeah. So I think we'll take a break because I need more time to explain anyway. When I say Hadoop, it is this. We know there is HDFS, YARN or MapReduce. But that is not only Hadoop. You have a lot of other tools on top of that. So you need to have at least a rough idea as to what are the tools we have in the Hadoop ecosystem, the whole stack, right? So I will talk about it. Once we complete HDFS discussion, I will go to the ecosystem stack, because in the ecosystem stack, you will have a lot of questions. How this work, how that, at least a basic idea, because I'll take the same ICICI scenario and I'll tell you how we moved. Then you will get a better idea probably, right? Yeah, so we were on this question side.
Yeah, sorry, I've been raising my hand for quite a long time.
I'm sorry, I didn't notice you.
See, question is, like on the data nodes, say like one of the nodes gets failed and you plug in replacement node. Okay, and will Hadoop automatically take care of copying the lost data from the remaining nodes? How would that
that's an excellent question. So the question was that if one machine is totally gone, if I plug an additional machine, will Hadoop automatically take care of copying the data? No. The point is that that's called commissioning. So if you add a new node here, Or let's say we are simply adding a new node. Let's say the existing setup is that if I add a new node, this node will be empty. So you have to do something called balancer. There is a utility called balancer. I will run balancer so that Hadoop will analyze and understand that this is underutilized, this is overutilized. It will move some blocks here. If you don't run balancer, it will keep it as a new machine, but the data will not be balanced. So we run something called balancer to manage that. There was another excellent question. This replication, how does it work? So replication, it works in a very interesting way, because if you're writing the data, the first block goes here, B1, right? Now this guy will tell this guy to get a copy. And this guy will get a copy. And then this guy will tell this guy to get a copy. So third copy is got. Finally, this will send an acknowledgement here, here, and you will get an acknowledgement. Then only a block is written. So it is called pipeline write. You are not pushing everything at the same time. As a pipeline, it writes and gets an acknowledgement. That was one question. Yeah. Sorry. Yeah, so this will be communicated when you are doing a Hadoop copy operation. You will talk to the name node, and the name node will give you a list of data nodes, a chain of data nodes which should get the replica, primary and replica. This information will be passed to them.
What is the maximum storage for you?
Maximum storage. Excellent question, because the name node actually stores metadata. This metadata is in the RAM. When the name node is running, the metadata is being served from the RAM. Actually, it also persists in the hard disk, so that in case it crashes, it gets. For 1 trillion files, 64 GB is the RAM required. So you should actually calculate the RAM size, not the hard disk size. 1 trillion file, a file size can be anything. I'm not talking about file size, because for a single file, 256 KB of metadata is created. One file means how many blocks are there, its replica, that is the metadata, right? So 64 GB can handle 1 trillion files in a Hadoop cluster. So accordingly, you have to increase the RAM size. Hard disk size is fine. You don't need much hard disk size.
What is the typical file metadata size? Is it 256 KB?
KB per file.
Per file. So once the data name nodes increases, storage nodes increases, so it means that the number of files are increases.
Exactly.
You will replace it with a new machine for later?
No. You can increase the RAM of that machine, right? And the name node is not a commodity hardware. Very important point. The name node is a costly machine. You don't want that's a Volvo bus, right? Because you don't want that to crash unnecessarily.
One more thing, right? While this, suppose a particular data copy has been lost due to some reasons, maybe the hardware problem, does automatically Hadoop
Yeah.
recreate that copy?
Exactly. So if let's say this machine is down, very good question. If this machine is down, this B3 and B1 is gone. Automatically, it will create one more B3 and B1 somewhere. And if this machine comes back online, it will delete them. Because it has to always maintain a copy of 3. Always the replica should be 3, should not be 4 or 2. So that is automatically handled. You don't have to worry. It will delete and recreate if it wants.
In the same line, this suppose while making the replicas, it is taking into consideration data locality, whether data name nodes are near
Yes,
or not.
yes.
It will take into
It will take. Data locality, nearby considerations will be there.
In that case, how the metadata will be updated on the name node?
Okay, so I will come to that in just a moment. Metadata, I have to talk about it. Yeah.
One more thing, the first thing you told, block size is 64 MB.
That was because 128 is actual. Okay.
Let it be whatever MB.
Okay.
As Hadoop, as I understand is, HDFS is an abstract file system. but
On top of
underneath-
Linux.
underneath the
Ah.
native file system is there.
Correct.
But how come it is going to reduce the sync time? 64 MB is not going to store continuously, right? Suppose a file,
Ah.
I'm going to file
Ah.
with the block size. So, what does it significantly, what does it do?
So when you are installing HDFS, even though internally it is Linux file system, it will talk to the Linux file system, and the 64 MB will be further chopped down. The 64 MB is on Hadoop. Internally on Linux it is 4 KB. But this entire 64 MB will be 1 point. It will not fragment it. You are getting my point, right? If I'm simply dumping 64 MB on Linux, it will divide it into 4 KB and fragment it in many places.
It will be continuous in this point.
Here it will be continuous. So read and writes are fast. Any other questions you have? So balancer has to be ideally run by the administrator, Hadoop administrator. You have to manually do it. And there is a command called Hadoop balancer. You can run it. From the GUI also you can run it. I will show you. So tomorrow if you guys can remind me about this, I'll show you all this. I may not be able to run a balancer, but I can show you where it is. I will forget, right? So tomorrow I'll show you the Hadoop cluster. I can show where are these things actually. So the balancer is part of your Hadoop installation. HDFS. So you can say run balancer, but normally we will run balancer only during off-peak hours. Like during the daytime, if you run it, it has to move the blocks and your processing and all will get interrupted. Won't interrupted, but it will be slow. So let's say midnight, 12 o'clock, I run the balancer. I make sure that the blocks are evenly distributed. So this block size, that is also a very good question. This block size is just a logic, okay? So my question is that if I have a 200 MB file, how many blocks will be there? 2? No, let's take 64 MB and 200 MB file. What will be the size of fourth block?
No, you take the same size.
So how many of you say that the fourth block is 64 MB? I will say yes. How many of you say fourth block is 12 MB? Not 8 MB, right? Very less. It is 8 MB. It's not 128 MB. The block size is valid only when the file size is more than the block size. Any file you divide, ultimately you will end up in a 10 MB or 8 MB. So Hadoop will keep it as it is. Otherwise, if it is storing in a 128 MB piece, the remaining data is unnecessarily. So it is a logic actually. It is a logical, even though physical division happens here, okay, logically it will keep a block of 12 MB only because you have only 12 MB data left there. Got it? It's not like physically I'm marking a space and filling only this much. That doesn't happen like that.
As you said, the HDFS is going to contact the native file system and
Yeah.
going to have that one registered, right?
When you are storing only it contacts, right? If I'm storing a file of say 200 MB, it knows 4 blocks need to be created. Right. Fourth block size, it will say that 12 MB only I need because I have only 12 MB data.
So this 12 MB also will be sequence.
Exactly. It will be in sequence only. Otherwise, remaining space is wasted, right? And every file will have some wasted space. So why are you wasting that much space? If I store 1 trillion file, how much will be wasted? Can you think? Lot of file size, right? That is not required actually. So it is a logic internally built in to HDFS that the block size is valid as long as the file size is bigger than the block size. Once you chop and last 10 MB, that is 10 MB only. It's not 128 MB or 64 MB, right? It will increase, exactly. So if you append, that block size will increase. So that's a good question. So in this 200 MB file, if I'm appending the data, right, it will increase. It will provide a room for that actually, because the last block was only 8 MB. Now you keep appending the data, that block will become a 128 MB. It will keep on.
But this block will not be available, right? If something else, this block will not be available. Somebody else would have been taken away.
No, in Linux, what it does is that when it is creating a block, if the block size is small, it will say that give some room. When you're creating the next block, don't keep it immediately next to that. The hard disk is so big that it should not immediately create it there, right? Most of the cases append will happen. Very rarely, probably it may not work there. Very rarely, okay, it is almost impossible. In most of the cases, you will get that data there. Yeah, so that is for processing. I told you I will come back to that. So if I'm putting all the file, one big file here, if I want to process it, this machine only can process my file, right? If I'm splitting it, now 3 machines can parallelly process my data, right? My processing is faster. So if I'm, the same time you will not run all the processing. Another misconcept that people have is that in a Hadoop cluster, if you have 100 TB data, all the 100 developers at the same time will say run. No, it doesn't work like that. Are you getting my point? You have a lot of data in a Hadoop cluster. You wrote a program, I wrote a program, he wrote a program. We won't come to office exactly 10 o'clock and say run the program same time. Doesn't work like that. You may have a lot of data. People would have written programs. but you schedule the program. So that is where scheduling comes. I was about to talk about it. So if you're working in a Hadoop cluster, resources are very important, right? Because each machine has processor, then hard disk and network, right? And each machine will be processing your files, whatever you have written. So we have a tool called Oozie, Apache Oozie. Oozie is a tool actually that comes along with Hadoop when you install as a tool. So in Oozie, you will be scheduling your program. You wrote a Spark program, analyze 100 TB data. If you immediately submit the program, probably the program will not work because already somebody is analyzing the data. Where do you have space to fit all these things, right? So what you do, you write it in Oozie and you contact your Hadoop admin, say that I want to analyze 100 TB data. When can I run this? He will say tomorrow 11 o'clock. Okay, submit. Most of this analysis is batch, not real time. Real time is a different case. But batch jobs, you schedule it via Oozie. Also, you have something called queue in Hadoop. For example, you are working as a developer. I am a tester. Can we have same access in the cluster? Of course, testing cluster will be different. But let's say I am a researcher. You are a developer. He is a data scientist. Can we have the same access on the Hadoop cluster? No. Probably you are a developer. You need more resources. Okay. Probably I need less resources. So what we do, we create something called queue. Okay, there is something called queue we create. In those queue, we allocate resources. If you're coming from the developer team, you will get 30% of the resources. If you're coming from other team, you get 40%, right? Otherwise, I can utilize all the resource, right? If I write a program, I can make the cluster only for mine. That's not possible in a Hadoop cluster. So management is entirely different. How do you run these jobs are all different. But to just answer the question, why you are dividing is that you can use parallelism. Otherwise, a single machine has to process everything, right? Quota size is different. Queue, right? Queue means multiple teams will be there. Each team can get a queue. So when you submit a program, you will submit to a queue. You will not directly submit to the cluster. So let's say, just for an example, we take a
It's queuing in terms of processing time when it will be processed.
queuing in terms of resources. Say for example, in your Hadoop cluster, you have
You mean data nodes?
you have 10 data nodes. Each data node has, let's say, 10 GB RAM, right? So total you have 100 GB RAM in the cluster, right? And let's say 10 data nodes, each has 4 core processor. So you get what? 40 core processor, right? Now, if somebody want, they can get all these resources in their program. If he is getting, nobody else can run a program in the cluster. It should not be like that. So what we do, we create 4 queues, let's say, or 2 queues. In this queue, I will say 60% of the resource should be there. Here I'll say 30% should be there. Here I'll say 10% will be there. So this will be the developer queue. They will get 60% of the resources. That means 60 GB RAM and what is that? 60%, right? 24 core processor. So they will never get more than 24. So multiple ways of scheduling is there. In the normal scheduling, they will get maximum 60% only. Or if the other queue is empty, they can claim the resources from there.
Queue is a tool or just a
No. Queue is actually a Java class. You can create something called schedulers in Hadoop. There is something called capacity scheduler, fair scheduler and all. So the scheduler is called a queue. So if I am creating something called fair scheduler, within fair scheduler, it will allow me to create queues. So I can say create 3 queues, and whenever somebody is submitting a program, they have to mention the queue name also, otherwise the program will not run.
So, for example, developer team has been provided 60% of the data.
Okay.
Like number 1 to 6.
Okay.
And you want to use, the other team is provided 30%.
Correct.
But the data might be different in different data.
No, this is not talking about the data. Data, they will get their data. I am talking about RAM and processing power.
Okay.
Data is available.
Okay, so the allocation of RAM from different.
So if I am running my program, we will come to MapReduce tomorrow.
This is what will explain the yarn process, right?
So if I am running my program, I need a RAM and processor to run my program, right? How do I run my program? I need RAM and processing power. That the cluster should give me, right? So I can limit people based on queue. Only this much resource you can get. That is possible. That is called scheduling in Hadoop.
And one more thing, when as you told, we are submitting jobs only to the queue. The processing is dependent. It can be first in, first out. It depends upon the scheduler.
So when you submit to a queue, inside the queue you can write a policy. The default policy is FIFO, first in, first out, right? Apart from FIFO, you can also have priorities and other things. You can write your own policy, whatever.
But at a time in the cluster, only one job is running.
No, at a time 3 jobs can run. These 3 queues people can submit, right?
Okay. 3 queues, 3 jobs at a time.
3 or more than. For example, this queue has, let's say, 60 GB RAM, right?
Yeah.
I need only 20 GB RAM. You can also use 20, right? 3 people. Depending on how much you want to process.
Available.
How much resource you want, that has to be, I'll tell you how to calculate that.
All this, what is important for lab exercise?
None of this is important, but these are all admin activities. None of this I discussed is actually related to your course, but this may all make sense when you start working. See, learning is one thing. Okay, if we just want to learn, we'll just learn MapReduce and run some programs and go home. But when you actually start working, these things are actually used in real life.
Yes, useful. I
Right.
just want to know.
No. Don't worry. Scheduling and all, Uzi, nothing comes in your lab part. In the lab part, actually what is there? HDFS is there. You will load the data, read the data. MapReduce is there. Hive is there. That's all. None of this actually comes. But I can show you at least from the Cloudera Manager UI, this thing. What is that? Balancer. And where is the name node? Where is the data node? These things we can see. Since just we want to look at it. So are we clear about HDFS? I think at least we can say that on a basic level we are clear. Probably not everything, but yeah.
So how the records will be saved? How the records will be saved?
I didn't get. Records means?
Records means in RDBMS we will store it in a table.
So here it is text file or flat file. Any file you can select. So by default, like I said, if you are storing something on HDFS, HDFS does not care what is your format. You store an image, it will store as image, JPG. You have to make sense of it while reading the data. It is not like RDBMS. So that is one thing. It is not like RDBMS at all because HDFS is a file system. So if you dump, say for example, on my Windows machine, can I store an MP3 file? Can I open in Notepad? Why?
Don't know how to pass it.
Exactly. I can store an MP3 file in Hadoop. If I want to process, I should write a logic to process it actually.
But any query has to process multiple documents and then it has to send themselves. So
That is for only queries. MapReduce is not query. MapReduce is programming language. Queries you are talking about Hive. So Hive is your data warehouse on Hadoop. Hive will accept normal SQL queries, whatever SQL on the data. Yeah. So you have to create a table and all from the data. Exactly. So Hive is like your data will be in HDFS. You have to create a table, give a schema, then it looks like an RDBMS table. Then you can run your queries. No, it's not an RDBMS at all. Actually, the data is running line. Exactly. It can be a CSV, it can be a text file, regular files it can save. Yeah. I will show you in Hive how to store and process the data, right? Yes, in Hive you have something called indexing, but it is not as efficient because indexing will really work well if your data can be managed by the RDBMS system or the data warehousing system. If I'm indexing the data in Hive, the data is actually managed by HDFS. Right. So I can get some performance improvements, but not like in your RDBMS. Never compare Hadoop with RDBMS. You can, at the most, you can compare with a data warehouse because it is not transactional, right? It's equal to a data warehouse, I can say.
so it's not as so can we afford loss of data while saving or while doing something?
I didn't get you. You're asking if I copy a file, can I?
So we don't, for example, if we like to create a new record and some
No, you don't create a record. That's what I'm saying. You are again talking transactional, right? You don't create a record. See, this is a big data platform. So you dump terabytes of file. You are not creating a record. Very rarely you edit. That's what I'm saying. This needle in a haystack problem, right? So very rarely you say that I want to create a new record. You will be adding files, continuous streams that will be huge in size. You can afford to lose. You can afford to lose the data. I will talk more about that in the ecosystem side. Okay. Ha. So a lot of companies actually run this using virtual machines. It is possible, but performance we cannot always depend on VMs. I mean, VMs are ultimately what? They don't use, if it is a bare metal virtual machine, you can guarantee, so there are two types of VMs, right? You have something called bare metal like a Hyper-V and all. There you can get good performance, or VMware. If it is not a bare metal, no, performance will be compromised, because again you have to go through one layer, then talk to the storage and all. Yeah, it can be configured. So I will just talk about something called Hadoop ecosystem, and then we will discuss further.
Let's say that the client wants to read a file that is Hadoop.
Okay.
And it first checks with the name node. Name node will basically give the metadata on what are the nodes where
Correct.
The file is located.
Correct.
And is there any process that will actually collate the data from all the nodes and provide to the client?
No, it's all a Java call actually. These are all, so the Hadoop is actually written in Java. So client is also in Java. Everything is a Java method actually. So you are just invoking a Java object. There is a fs read object which you call, and this object will get all this metadata and give it to the client. And the client will keep it in memory and then go and read one by one from wherever it wants. Okay. So I will just explain this ecosystem and come back to your questions further. I know there are a lot of questions and it is good, but we should finish a couple of topics more as well, right? So I'm just taking this ICICI use case so you guys will understand better. So traditionally we do something called ETL to bring the data, right? And now what we have this Hadoop. So I'm just writing here HDFS. So this is your HDFS file system. This is HDFS. And in the world of Hadoop, we very rarely do ETL. Why? Because ETL means you are reading the data, transforming the data, and dumping the data. If you are getting big data, transforming it on the fly is very, very difficult actually. So in the world of Hadoop, what we do is something called ELT. Instead of ETL, you will do something called ELT. That is extract, load, and transform. So first thing is extraction. How do you get the data into a Hadoop system? So there are multiple tools. First of all, if you are having structured data, say you have data in Oracle, you have data in MySQL. So this is all structured data which understands SQL. There is a tool called Scoop. Scoop can get this data to your HDFS. Scoop. It is an ETL tool. You can't call it as an ETL tool. Scoop is used to bring the data from any SQL system to Hadoop. Transfer the data.
It's an external tool out of
No, it is part of Hadoop ecosystem. So what is going to happen when you say that you want Hadoop from Cloudera? Cloudera will give you Hadoop. On top of that, it will give you all these tools which I'll be explaining now. So Scoop is part of your Hadoop ecosystem. And Scoop is used to bring data from SQL stores. It can take from, let's say, Oracle. It can take from MySQL. But it cannot take from flat file, JSON, nothing. Only SQL, only places where SQL understood. So from ICICI use case, we got all the data from CRM through Scoop to Hadoop. Okay. So Scoop is an Apache tool. It is a very lightweight tool. We faced a problem there. I wanted to discuss that. Let me ask you this question. This is ICICI Bank's core banking Oracle database. Do you really think they will allow you to touch it? Then how do you get the data? Meaning? Who will copy?
They should be copying
Replication. Any tools or how do you replicate? I mean,
CDC.
So you can take a dump of the database and then put it to another database and you can
excellent. CDC, change data capture. So we face the same problem. There is Golden Gate. Oracle has a solution called Golden Gate. So CDC, change data capture, meaning they will not allow you to touch it, right? So they will have some replica solution. So where they will write it into a replica DB, it's actually a log file. From there you have to capture and get it. They won't allow you to directly touch their Oracle DB by any way. It's called CDC, change data capture.
That will be having the real data?
No, that will have only the delta. So what they will do, they will give you the original data, backup data they have. The CDC will capture only the changes in the database. Got it? And then you have to, from CDC, you can write a Java code and then get the updates dumped into here. That is how you get it.
You mean to say the original core database is going to have a replica in another instance?
Okay, CDC will discuss later because I need to spend half an hour here to explain. Just understand the changes can be captured because it is anyway not related to your big data platforms. This is just a business scenario.
I mean to say from the core banking itself, they are going to have a replica in
Yes, of course.
where they are going to give all these
Exactly. So we will not discuss CDC in detail because it will take another half an hour. I don't want to spend half an hour. It is not related to your syllabus anyway. And even I didn't do CDC because there will be teams who will do that. Even I was not aware of it.
It's a technique.
It's a change data capture is a technique. So whatever changes are happening here, it will capture and dump somewhere. From there you can read it.
Something in the main
Database, exactly. From there you can read it. So I was just saying that we use CDC to get the data. So Golden Gate is a product that Oracle uses for CDC. Anyway, we use Scoop to get from here and here, right? Now comes the place where we are having a lot of debate, actually. Okay. Now the real question is that, okay, I know how to get the data from here through Scoop, right? What about the other data, right? Now, if you want to get the other type of data, there are multiple ways you can get, okay? One of the most popular used tool is called Flume. Apache Flume. Flume is a point-to-point delivery tool. What Flume does, it takes the data from source, give to the destination. The source can be anywhere. And normally Flume is used for unstructured data. Say for example, in a folder, you're getting all the JSON data or XML data or flat files. I can create something called a Flume agent. And this guy will keep on polling that folder. Whenever there is a new data, this guy will read it and it will send it to HDFS. This is what Flume does. Now, the real interesting thing is that Flume can do two things. One thing is that it can simply read all this data. Let's say this is in a folder. Okay. It can simply read this data and say send it to Hadoop. This is fine. But ICICI Bank also had another requirement. So this is simply you're collecting the data and dumping into Hadoop. They don't want to do that. Okay. So they wanted, they had a requirement in which what used to happen was that this Flume was capturing some data. Okay. Some data was getting generated in the form of JSON here. So in the social media, if somebody is clicking on one of their products, they wanted to send an SMS. Real time. So this JSON data will keep on coming. You will keep on getting it. And Flume can directly dump into HDFS. But that is useless for me because I want to analyze the data whenever the data is getting generated. That is where this guy comes into picture, Kafka. So there is a difference between Flume and Kafka. Okay, you have to understand. Flume is like a point-to-point delivery. You give me the data, I will dump it there. That is all Flume does. It doesn't do anything. And Flume does not store the data anywhere. Meaning, it will take the data, temporarily it may store and then immediately push the data. Kafka is a message queue. Anybody aware of message queues? So, Kafka is your message queue in the big data world. Meaning, what this guy will do, this guy will be running in its own cluster. No Hadoop cluster. This guy will run on its own cluster like 30 machine, 40 machine. This guy, Flume can send the data to this guy, Kafka. And Kafka is a cluster, so it can store the data. By default, it can store for 7 days. By default. Okay. Anybody can go to Kafka and get the data. Publish, subscribe system, we call it. The advantage is it will store the data so that multiple people can ask it. Flume is point to point. If Flume gets the data, it dumps the data here.
But here it's 2 points.
Yeah. So here what we used to do, we didn't do this. Okay. We got the data to Kafka. From Kafka, I can push it to HDFS one way. So I'm getting the original copy here. Okay. Now in ICICI Bank, So the next question is that how do you analyze data in real time? So somebody is clicking on Facebook, the data is coming as XML, right? And immediately when the data comes, Flume will read it, push it to Kafka. So now the data has reached till Kafka, but I want to analyze the data in real time. That is where your Spark comes into picture. There is something called Spark streaming. In Spark, you will learn this, I think, I'm not sure, okay? There is something called Spark streaming. So Spark streaming is a utility which analyzes real-time data. Now, Flume can read any type of data. I didn't get, sorry. Point to point.
Source to and the destination.
Yeah, yeah.
Point to be transporter.
So it just takes from here, dump it to Kafka.
Is it possible for you Flume to contact the SQL Server database and get the data to?
No. Flume will not work with SQL Server. Only Scoop will work. Any SQL data, Scoop. Any other type of data, Flume. Now, Kafka can also directly get this data. Now, this is a bit confusing, I know, okay, because this is very new to you, first of all. But Kafka can also directly get the XML file. But the advantage is that Flume is pull based. Pull based means if I install Flume without disturbing this setup, I can pull the data. Kafka cannot pull the data. You have to install a tool here and modify the existing setup. Flume is pull based, meaning if you install Flume here, it can start reading the data automatically. I don't have to modify anything. If I install Kafka directly, Kafka can also get the XML data. It can read the XML data, but I need something called a Kafka producer. That has to be installed here on the ICICI source system. That is not possible, right? So since it is an existing setup, I can't directly get through Kafka. I get through Flume. Flume will give to Kafka. Kafka will send one copy to HDFS because I need to keep the original data. Second copy it will send to something called Spark streaming. Spark streaming is a library available in Spark where it can do real-time processing. The moment you give the data, it will process it real-time. So somebody clicked on that, immediately the data is here. Spark streaming will process it and say send an SMS or you can take an action, whatever you want. Now, what are the other tools which can do real-time? Apart from Spark streaming, you have something called Flink. You have something called Storm. These are all real-time processing tools. You might have to make a note of that. Yeah. Sorry. Yeah. Yeah, correct. So Kafka can be Facebook, Flume can be WhatsApp because WhatsApp is point to point, right? One to one. And Facebook is like distributed, right? Anybody. Eh? WhatsApp also they will keep it, right? I don't know. Oh, okay. That context. Yeah. Correct. Good. I didn't understand that point. See, so that's very easy. So in WhatsApp, it is push, right? Flume is like WhatsApp. Okay. Once Flume gets the data, it will push it to somewhere. It will not store the data. Kafka means it will get the data and store it for you as long as you consume it. So in ICICI Bank, this was the architecture. We got it through Flume, sent it to Kafka. Here one copy will go to Spark streaming. So this guy will do real-time processing and do something. Okay. One copy will go to HDFS. So the data will remain in Kafka as long as you want. You can configure. By default, it is 7 days. You can also mention the size of the data. I want to keep only 10 GB data, 20 GB data. There is something called topics in Kafka where you can mention how long the data should stay here. It's a cluster, right? To store the data.
Why can't Flume send to Spark directly?
It can, but it can do only one. Then it cannot send here, right? You're getting my point. Flume can send here, then this will not happen. It is point-to-point delivery. I need a copy here, I need to send there also at the same time. Also, probably tomorrow, I want to build one more application, okay, which will do something on this data. And that application, I have a new application I build tomorrow, that can also get the data from Kafka. Kafka is like, if you give data to Kafka, anybody can take it from me. I will store it for you. Got it. Flume is like point to point. Got it. Kafka will store it so that anybody can come and get the data. 10 applications can read from Kafka.
So if we have Spark
Yeah.
take from HDFS.
Sorry?
Why can't Spark streaming take from HDFS?
Slow. It will be very slow. Hardest to read. I can directly push in real time, right? So before you get out of Tanik's shop, I want to send an SMS, right? after processing. No, this will be one golden copy will go here. The original Facebook clicks and all golden copy will go here. That tomorrow you can analyze. Now you clicked on a page, insurance page in Facebook. I want to immediately contact you. So it has to be processed and understood, and then some decision has to be taken. So I'm sending one copy here, one copy here. Here the processing will happen. Here simply the original data will be stored.
So there, after the process, data will be discarded.
It will be discarded because original data is anyway here. You can store it also.
But generally here, people store it.
Yes, golden copy will be here. It's called golden copy.
The map produced with the help of, like, in the HDFC, the map produced will not give similar.
No. Map reduce cannot do real time. It is batch.
That's what is the batch process.
Yeah.
So if we have Flume and Kafka, so do we still need Scoop?
Yeah, because how do you read from Oracle? How do you read from Oracle? No. Flume and Kafka cannot. Only Scoop can read from SQL-based stores. Now, Kafka is a very interesting thing. I teach a 3-day course only for Kafka. 3 days. It's not enough actually to teach Kafka because it's such a big topic actually. Because Kafka can be a message queue. ELK stack, right? No. ELK stack will not come here in this example. We didn't directly use ELK stack. We were using, that's what I was telling in the break to somebody. What we were doing is that we used to store the data in Hadoop. To process, we were using something called Splunk. There is a tool called Splunk. Splunk can actually replace your ELK stack. It does ELK both in one tool. So that is for visualization, right? You have some log files, machine learning, you can just apply and visualize. We were using something called Splunk. So this is the big pipeline I'm talking about. You can also build it using ELK if you want, I'm just saying. ELK is a stack actually, Elasticsearch, Logstash, Kibana. It's a, probably he can explain, right? So who was working on ELK? Somebody was? Yeah, so you can explain probably what is ELK.
That's also like similar to the Hadoop architecture, but only thing it is very lightweight.
Lightweight.
So we can install it in simple Linux server.
But probably not for 100 TB, 1000 TB.
For 10 TB, 5 TB, 2 TB also.
So let's say you're getting a lot of log files. You want to make sense out of it, right? From different places. Let's say I'm collecting all the logs from this network. I want to make sense out of it. So I need a tool which can easily collect it, clean it, and then display in a dashboard. That is ELK, what it is doing. There is a tool which is very similar. That's called Splunk. That is not in the big data, in the Hadoop ecosystem. It is not there. That is a third-party tool actually. Open source. Yeah. Exactly.
Can we use Flume for SQL and...
No. That's what. SQL only Scoop.
Does it mean that we cannot do the live processing of the Oracle or this data?
Exactly. So that's a good question. So when Scoop is getting the data, right, Scoop will ideally push only to here, HDFS. Okay. But I can say Scoop to push to Kafka also. That is also possible. Once the data is available in Scoop, okay, I can say give it to Kafka. So either it can be read for live processing, or Scoop can push to something called Hive. We have a Hive here, which is a data warehouse. From there, I can analyze in live if I want. But normally, this transactional data is not much used for real-time processing. You are doing it based on this Facebook clicks and all. Based on this transaction, I can get it. Now, just to answer his question, that's a good question actually. Can you give me a suggestion? So a customer is making a transaction. Using ICICI credit card. He made transaction for 50,000. I have to immediately send him an offer. So if he's making a transaction here, I made a mistake here. I want to show that. If he made a transaction here, 50,000, okay, where will be the data? In Oracle. How do you capture the data from here?
Scoop.
You will say Scoop. We were using Flume because your CDC will be producing a log file. The log will be captured by Flume, not Scoop. So here Scoop will not come into picture. Here Scoop will come because I'm directly reading from CRM. My CRM is in MySQL. MySQL is original table and I can read directly. But in the Oracle case, I was not directly reading the table. If I want to read a table, Scoop. But we were reading the CDC, change data capture. That was a log file. That was being collected by Flume actually. So you can actually make it. So this is the answer. If you want to make real time, Okay, you need some CDC system which can push the data to Flume, actually. Huh.
You might make a purchase of, say, for example, 50,000 or 30,000. Immediately when you log into the credit card transaction history, you
Huh.
give an option like convert it to EMI.
Exactly, exactly.
Nothing but
Real time. I have worked on a banking use case where, so I'm talking about this side, Spark Streaming, Flink, Storm. So Spark Streaming is what you will be learning. Flink and Storm are other frameworks which can do real-time data processing. So you will be wondering why real-time data processing is so critical.
But all these things are same datasets, right?
All three are real-time. You may use any of them. Flink is Apache, Storm is also Apache. Storm is almost out of the market. Okay. Spark Streaming and Flink are popular right now. We have worked on a use case with Citibank. You swipe your credit card, right? How do you know it's a fraud or not? You are swiping your credit card. I want to find out whether it is a fraud transaction or a real transaction. Correct?
I'm living in Delhi.
Hmm.
And my native is 27. And the max for the past 1 year I was traveling to say South India. Suddenly when I made a transaction in Delhi.
Exactly.
That's a problem.
Huh.
What happened to the last
Prevention, not prevention. Even I.
No, even you don't have to be a fraud. Let's say I use a credit card regularly. If I, one fine day, if I suddenly pay in US dollars or something, I'll get a call from customer care. Did you really make it? That means, imagine the HDFC Bank, how many credit cards will be in circulation and how many people will be transacting every day? Do you think somebody is sitting and monitoring every swipe? Spark Streaming. You are collecting all the data, all the credit card transactions will get dumped, okay? They won't come in a relational form. They will come in some flat file or something. Your Flume will catch it. The moment it comes, it will push it through Kafka or directly to Spark Streaming or Flink or Storm. And there I could have written a logic, okay, match this transaction. If this guy's limit is something or his last transaction made places outside India or something, trigger a mail to customer care. That is how you are getting this EMI calls also. When you make a big transaction, immediately they will call and say, do you want to convert to EMI, right? These guys are responsible for that.
even in the stock market when you do a stop loss.
Same. Stock market, very big example. Yeah, same thing. Because all real time, right? Because tomorrow if I get a message for today's stop loss, doesn't make any sense, right? Now, since you are interested in this, I think in your Spark course, streaming is not there. Very bad. Okay, but I can give you some example because what is the difference? This Storm can process one event also, meaning one credit card transaction Storm can process. Ideally, one credit card transaction it will process, minute. Spark Streaming can process only bunch. It cannot process one, meaning it will collect probably 2 seconds worth all the transaction and predict. So that's called micro batching. It is creating a batch and then from that it is processing. Near real time, exactly. 100% real time is only possible with Storm. And Flink also does the same, I think. I know there are a lot of information I'm passing and a lot of you are actually almost like dead by hearing these terms and all. But I can't really help it because I'm not making it up. You can Google for that, okay? And probably now it may not make sense if you're listening to me, but probably later when you start working, if somebody talks about Spark Streaming and a use case, you will think, okay. Oh, this is what he spoke at that. So ICICI Bank's use case was that if somebody is clicking, they wrote a Spark Streaming code. Okay, now I have a question for you. Yeah.
For example, in terms of ICICI Securities, there is a bank, you make a purchase for them and as a real-time transaction to my core bank. And also to my other kind of SMS and all those.
No, this securities we were not handling. I'm not 100% sure how it is working. Our use case was only limited to this, right? But now I have a question. Okay, the question is very much valid. You are making a credit card transaction and Spark Streaming catches it. Spark Streaming catches it, but that is the real-time transaction. How does it know that this is a fraud based on the previous transaction?
See, it can able to think Hive database, right? You can able to
Fine. Yeah, the batch data is there. But how it is working? Machine learning. They could have built a machine learning model, profiling all your past within Hadoop only.
Within Spark or because
Spark, MLlib.
but it needs some historical data for that, right?
Yeah, they already have historical data. All this customers transaction is here. These are all on top of HDFS only. This is running on top of HDFS only. This is part of HDFS. Huh?
You'll be able to query that directly.
When you install Spark, exactly. So Spark is getting installed on top of Hadoop only. HDFS is the storage for Spark. So if I am making a credit card transaction today, all my previous transactions are already here. They could have already built a machine learning model. And if you simply feed this new transaction, it can predict. Otherwise, how do you compare with batch data? I cannot run a batch job. It will take a lot of time, right? All the customer data. So they will run a MLlib. It's called MLlib in Spark. Machine learning model will be running. That will easily compare and say it's a fraud. You know? If you want to compare the batch. Otherwise, see, now I am just making a transaction, right? It has to compare with my previous transactions to understand whether I'm a fraud. So like he said, I was traveling only within Chennai for the last 10 years. Today I'm swiping in New York. So New York swipe, if you want to understand it is an anomaly, you should compare it with previous swipe, right? Now each time you cannot go and compare for each customer. So they build a machine learning model based on all this data that can, if you feed a data, it can predict, you know, whether he will be a fraud or not. No, Kafka, okay, so Kafka will not send, Spark will get, because it is a publish subscribe system. It is called Spark streaming is an application which will poll a Kafka topic and get it from Kafka.
Okay.
It will get it.
The Spark pulling the data from the Kafka.
Fine.
Okay. But you again said a Spark has been built on the HDFS.
Correct.
So why do we need to HDFS is not storage system?
No, this is your permanent storage. Spark can read from here, also from here. Spark can read from a variety of sources.
Okay, so data what the Kafka will never store only for the minute period of time.
Like 1 week by default. So this is your real-time data.
Yeah, that's correct.
Right. I'm just reading it to get my current information. All my original information is going here only, right? The golden copy is here. So if tomorrow I want to run a Spark job, yesterday's data, I can read from HDFS.
So machine learning will happen with a Spark streaming using the HDFS.
So this original data will get from here, current data, and there will be a machine learning model which is already built based on this data. It will not read the data. The model could have already read and learned. That is, so you guys have to teach me this. You are learning machine learning, right? Not me. You have to tell me how it is working, right? How would I am a data engineer. So what is your machine learning, right? Your topic is machine learning, right?
So what you're saying in securities, if I buy money or gold, that is my historical data. Today's price is my current data. What Spark is doing is the loss comparison.
No. I am saying in this HDFS, you have all the transactions made by all the customers for last 1 year, credit card. That's a repository. You feed it to Spark's machine learning algorithm. It will build a model which, if you give any new data, it can predict whether it is fraud or not. It need not have to go here.
I didn't purchase for last 1 year. My purchase was 1 year ago.
Ah.
My purchase cost is there. Purchase cost is there in here.
That you have to adjust in the machine learning. That's what I'm saying.
Today's rate is available in the Kafka. And Spark will get me what is my loss and profit for the day.
No, it will not directly compare and get. This I'm talking only about fraud detection. So your use case is your this thing, right? Stock market price variation. Recommendation. Recommendation you can do.
Recommendation for, let's say, you can reduce your loss, or you can increase your, you can wait for a profit, this is the current profit.
No, historical price, historical purchase is there in HDFS. Today's price is there in Kafka. So I'm comparing 1 year old price, what have I bought, and today's price, what is the profit? It will compute and
You're computing a notional value. You're computing a notional value.
That's okay. So my point is, this historical data will be huge. It will be in terabytes, right? So you could have already created a machine learning model which, by feeding this data, which if you give any new data can predict whether it is fraud or not. That is happening in real time. I cannot say that once if somebody swipes a credit card, I will tell you whether it is fraud tomorrow. Doesn't make any sense, right? I have to do it immediately. Now, the flip side is that all this requires resources. Nothing is going to work if you don't have resources. So you need to give enough resources for all these things to work. Machine learning and all are very resource hungry. CPU power, RAM power, right? So these clusters should be capable of doing this. Anyway, for the time being, let's move on from Kafka, right? So we are just taking a use case, right? Now, I'll go here. Once your data is in HDFS, if you want to do batch processing, the default framework is MapReduce, MR. What is MapReduce? We will see tomorrow. But I have my data, I want to do batch processing. I don't care how much time it takes, 1 day can take. I just want to process the data, I can use something called MapReduce, right? You also have one more guy called Pig. This is almost gone from the market. Pig, the animal pig. Pig is a scripting tool on Hadoop, but not very popular now because of Spark. So nobody is actually, so even if you are not aware of Pig, it is perfectly fine, I think. Okay, you don't have to worry. And then you have somebody called Hive. This is there in your syllabus. So Hive I will teach in the next month, but basically what Hive allows you to do is to write SQL on top of Hadoop. But the drawback is you say create table and select count star from the table, hit the query. It will convert your query into a MapReduce program. So it's a translator. It is not a native SQL engine. Yeah, if I'm writing an Oracle query, Oracle will execute it for me. If I write a Hive query, MapReduce will execute it for me. So you will understand when we speak more about Hive, don't worry. So, C++, exactly. So MapReduce itself is very slow because this is batch processing. In Hive, you write a SQL query and Hive will not execute your query. It will write a MapReduce program for you. Even more slower.
And there is a possibility to configure the Spark also, right? Hive to Spark.
Hive to Spark can be configured. Yeah. So, but the problem is Hive was the original tool. It was built in 2005 by Facebook. Okay. And at that point, it was very popular because there was no other tool. Right. So people were writing Hive queries. Even though it is slow, it is SQL, right? See, which is better? You can suffer some slowness or you have to learn Java. You can suffer SQL, right? Right. So ETL. 15 minutes, it is fine. Yeah. So Facebook developers thought that instead of learning Java, right, we will stick with SQL. ETL jobs we will run. They created this tool called Hive. So if I'm a Hive developer, I don't have to learn anything. It's SQL. I say create table, join. But once I say join, it will write a MapReduce for me. Then the MapReduce will run. I may have to wait for. In fact, in Flipkart, there was a Hive query which took around 12 hours to run. Today they will fire, tomorrow they'll get the result. 12 hours was the typical runtime. A huge amount of data, obviously. But then they fine-tuned it and all. But that's a different story. But so a lot of time, batch processing. So these are all batch processing systems built on top of Hadoop, right? And then you have Spark. You will learn Spark later. I don't want to confuse you a lot. So Spark is there. And this guy is inside Spark, okay? Even though I wrote it here, this guy is inside Spark. Spark is an in-memory execution engine. Spark is again classified as a batch processing system, but very, very fast than MapReduce. The only difference is that Spark programs are faster than MapReduce programs.
Just now these are right, Spark is able to handle real-time data.
Near real time, not real time. So Spark streaming is actually real time, but I will say near real time, not like 100% real time.
You mean to say till the buffer has been completed, it can't submit?
There will be a buffer always, like 1 second, 2 seconds. You can define that and it will process like that. I cannot have microsecond real time. That's not possible.
So basically, these other MR, Pig and Hive are obsolete.
So MR and Pig are obsolete. Hive is not obsolete because Hive is your data warehouse where you create tables and store the data. So this guy will remain, but now what is going to happen? Spark will connect with Hive, and Spark can write. So here you can write a SQL. Okay, Spark has a Spark SQL library. It can read tables from Hive and run on top of that, right? So Spark will start talking to Hive. So Hive is not really obsolete. Hive will be there for some time, we can say. No, HDFS. Storage is HDFS only.
So any replacement Pig like MR is Spark?
MR there is. Pig is gone. No, there is nothing. Pig is almost. Pig is a scripting tool. So Pig also will convert your query to MapReduce.
But Pig is obsolete, right?
Obsolete.
So like what is the new version?
Spark only. Not new version. Spark has practically replaced Pig actually. So this is your batch processing frameworks, right? Now, Some other guys came and they said that, so that was a typical question that asked during the training. So if I want to run, okay, again there is a confusion. If I want to run a very big group by query, let's say I want to read the full table, scan and run a query, Hive is great. Even Spark SQL with Hive is great because they will read the whole data and process it. But if I have minute queries, let's say select something from the table where name equal to Raghuraman, only one row it needs to process. For that, why should I load the full data and process? It is useless. But Hadoop says load everything in sequentially and then process. That is only possible. That is where you have this MPP engines. Impala. There is a one guy called Impala. There is another guy called Hawk. Hawk and LLAP. There is something called Presto. There is also something called, what is that? Forgot the name. Drill. Phoenix. These are all MPP engines. Just be aware of the name. You don't have to be an expert on, like there is no chance where your manager will ask, okay, name the top 5 MPP engines or you're fired. Nothing is going to happen like that. Any one of them will be used actually. Impala is Cloudera specific. Cloudera created Impala. So it will be mostly available only on Cloudera. What Impala does is very simple. It has its own execution engine. You fire a SQL query, it will run it for you, no MapReduce. Right? So what is going to happen for these queries like where name equal to Raghuraman, you can fire an Impala query. It will scan only that data. Right? So it can connect with HDFS and pick only the data because it remembers the metadata. Where is what data available? It can, columnar, it can pick that data and query. But then you will be wondering, why can't we use this instead of Hive? And these guys are very fast. So if these guys are too fast, then why don't I use them instead of Hive? They don't have reliability. They are all in-memory queries. If an Impala query is running in my Hadoop cluster, if any one of the machine crashes, my query will be gone. If a Hive query is running, even 10 machine crash, query will complete. It is MapReduce. Built-in redundancy is there. MapReduce will never fail. Or Spark will never fail.
But even Spark also the lazy evaluation is there. Right?
Yeah.
Suppose where name equals something, it takes
Correct.
that record only, right?
No. It is loading the whole data into memory. Then only analysis happens, right?
In the record came, suppose in Spark, I am going to find that particular select star from some table, where name equals something.
Correct.
If that find its name, it is going to read that record only, right?
No. Before, so when you say select star from this table, first that table data will be loaded into the RAM. Then only it reads from there, right? So initially the whole data is loaded.
Irrespective of whether the record is one or not.
Exactly. That's the problem. But if I'm using Impala, okay, it has its own metadata. It knows where is the data. It loads only that and queries will be faster. So if I run an Impala query, considering a Hive query, Impala queries are much faster, but no fault tolerance. So for this very fast queries, like your queries can take like 2 minutes, 3 minutes time, you can afford to lose a query, use Impala. But if I'm having a ETL job where I don't want the job to fail, run it using Hive or Spark SQL because these guys will never fail.
It runs only one machine, Impala.
It is distributed. It can run on n number of machines.
Even one system gets down, it can't able to.
Query will be gone because there is no, I will show you tomorrow in MapReduce, we will persist the data, intermediate results. That is how it is fault tolerant. Impala is all in memory. So if a machine crashes, that data is gone. What was in the RAM? Query will abort. So all MPP engines are like this, I think, in the traditional world also. In this, the difference is Impala is on Cloudera. Hawk and LLAP are Hortonworks. So there is a competition. Impala was originally created by Cloudera. So they promote it. If you are in a Cloudera platform, you will see Impala. If you are on a Hortonworks platform, you will never see Impala. They will promote Hawk. They will say Hawk is the best engine. Okay, and LLAP is the new version of Hawk. Presto, Drill and all are similar ones, but not by default available. This guy is very interesting. So there is something called HBase. I will add it here. Somebody was asking me what is HBase. HBase is your database of Hadoop. NoSQL database. Real-time database. Real-time. Because HBase will get installed on HDFS. There is your storage, right? But it can do random reads and writes. not like entire block. So normally when you are reading the data from HDFS, you have to read the whole block, right? But HBase has an API. So if you install HBase on top of Hadoop, it can do random reads and writes. Individual records it can read and write and process, because it is a NoSQL database of Hadoop, the default NoSQL database. But the drawback is HBase has its own language. So if somebody has to work with HBase, you have to learn the language. It will not allow SQL queries. Phoenix is SQL on HBase. Phoenix and HBase is like roti and paneer butter masala, deadly combination. I mean, very deadly combination because you are writing SQL on top of NoSQL, right? Very deadly. So they say that in another 2 years, it will not be slow. It is really fast because HBase itself is fast. SQL, there is a conversion, okay, but that's already built in. Any SQL query, there are some limitations, but most of the SQL, no, it will not fail. So Phoenix will get all the metadata, and already all the queries are converted. Whatever query SQL you are writing, it knows what is equivalent HBase query. It has just push the query. So you just write a SQL, it will run on HBase and give you the result. And it can do things like secondary indexes and all. It can index your data apart from HBase. It's very fast actually. Now the real news is that in another 2 years, what is predicted is that this combination, the drawback is Phoenix is still in alpha beta. Phoenix is not production ready. Once Phoenix becomes production ready, this is OLTP. It's OLTP. That means Hadoop will provide you OLAP and OLTP.
So this supports ACID also.
Huh? It will support in future, not now. So they are trying to make it ACID support so that this entire combination will become an OLTP system like that, right? So then what will happen? You will get transaction management in Hadoop. So far it is not there. Another 2 years down the line, they say that, so Phoenix is getting integrated with HBase. Originally HBase was only there. The drawback is it doesn't understand SQL. So Phoenix started, Phoenix is a layer on top of that. You can write SQL. So in another 2 years, they are developing this as a system for transactional management. So you'll get true transactional management in Hadoop. So if you talk about these Cloudera and all, if I'm going to Cloudera and say that I want your product, they will give you all this in one package. But if you go to Apache and download, you get only HDFS, MapReduce and Yarn, only Hadoop. All this you have to separately install. So commercial distributions will package it and you will not get everything, okay. For example, Hawk will not be there. This Presto, Drill, Phoenix, you will get HBase, Hive, Pig, MapReduce, Spark, Impala. So these things you will get. You have a doubt, I'll show you that in the Cloudera page.
So that Spark runs SQL query.
Yes, there is something called Spark SQL where it runs SQL query. It is really fast, actually.
We need Hive then. We can.
That's what. The tables you will be creating in Hive. Spark doesn't have storage, right? So whatever tables you create there, it can connect and run. So I'll say Cloudera CDH. The HBase has its own processing engine. Its own processing engine. So this is Cloudera's product. Why I'm showing you this to tell you that I'm not blabbering. Okay, you may be thinking that this guy is talking about a lot of tools. Do they really exist in the world? Look at here. Look at here. Spark, Hive, Pig, MapReduce, Spark, Impala, Yarn, right? What you have? HDFS, HBase, Kafka, Flume, Scoop. This is a real product from Cloudera. You go to Cloudera, this is what you get. Some of them I have not even explained because I don't know. Kite, I don't know what it is, to be very honest. Kudu is a new file system, relational. Even I am not aware of Kudu. I don't know what it is. But these are like new entries. Even if you don't know them, you will work without any problem. And for security, you have something called Sentry. So a lot of people are worried about security on Hadoop, right? So there is a service called Sentry, which will handle like access management, authorization, authentication. All this will be handled by Sentry. We covered these things, right? These things we covered, this we covered, this we covered. Something extra I have wrote, I mean, that is okay. I mean, here this part, right? This Presto, Drill, Phoenix and all is not there, but I just wrote them. One thing which is not present there, but it comes is Uzi. This I told you, right? This is the workflow scheduler. Like if you want to schedule a workflow and all, you can do that. I think we can do one thing. We have half an hour left and you are like almost tortured. I'll show you a Cloudera cluster. How about that? That will be better than talking a lot. So I keep on talking all this, right? So I'll show you a Cloudera cluster. We will not do the hands-on today. In the cluster we are using for the lab, we have only read-only access from the admin side, which means you cannot change the replication factor or block size or anything. These are all done by admins. We can upload the data and then say that run the program, that will work. But that we will do tomorrow. But let's look at the cluster, right? So far we are talking cluster, and we are not seeing any cluster so far. So I think Cloudera, Hortonworks and Mapr, these three are getting used actually. All the three companies are sort of famous, I can say. Right? Okay. So do you have this in your LMS, like your lab and all? Just check once. Yeah. So because some of the things are a bit confusing, so I have to tell you, we have to use web console. Web console will connect with the Linux file system where Hadoop is installed. We will do that later. Cloudera manager is the admin interface of the cluster. So I will connect with it, but we will not be able to modify, but we can see stuff. So if I go to Cloudera, no, Cloudera manager is a utility that comes with Cloudera to administer the cluster. Like you want to add a service, remove a service, add a machine, remove a machine. So the administrator, if you are a Hadoop administrator, you have to do all these things, add users, remove users, permissions, everything can be done by Cloudera manager. And why I did not speak about this, because we will not be doing anything using this, an admin utility. But to look at the cluster, this guy is good. So let me show you that. Cloudera manager. Now you have to install it. So if I am running in a company, I have to purchase, let's say 20 machines. Physically, yeah. And then I have to, there is a process of installing Hadoop. This cluster already has installed. It is a running cluster. If you're creating from scratch, you have to purchase, let's say 20 machines and download something called Cloudera manager and run it. And it will help you to set up the cluster. It will tell that which is your master, which is your slave, what is your block size, what is your...
Service like, I mean, if I don't have space, I want to use virtual systems. It is a company which is providing on cloud.
Cloud is also, this is physical, this is not even physical. This cluster is actually running on AWS, Amazon Web Services.
We wanted to practice.
Practice.
Site which offers this kind of setup.
You will have access to this, right? I mean, if you want to practice, this setup is already available to you, right?
It's giving some bad requests if you try to log in.
Let me try to log in. Okay, just probably you don't have access. I don't. Yeah. So just pay attention. So this is your Cloudera cluster. Okay, this is just an admin GUI. Okay, to the cluster, and once you log in, this is your dashboard. So you are looking at a Hadoop cluster. First point you have to understand. Second point, what is there in the Hadoop cluster? These are all the services installed. See, HDFS. Why am I talking like this? I can see it here, right? Okay, HDFS, Hive, Hue, I will talk about it. Impala, Kafka, Uzi, Solar, Spark, Yarn, Zookeeper. All these services are running in the cluster. You see a green, right? This is just to get a quick overview of the cluster, like what is running in the cluster. Fine. How many machines are there in the cluster? You click on this host menu. Can you see? Can you see these machines? These are all machines, 111, right? So how many machines are there? I think there are 9 machines. See, good health 9. 9 machines are there in the cluster. And you can also see their configuration. If I scroll here, can you see their RAM and hard disk? What is the physical memory? That is the RAM. The first 4 machines are 8 GB RAM. Next one is 16 GB RAM. These are their hard disk. Can you see? And you can see how much storage is full and all, everything, right? See here. So this guy is having 32 GB RAM and 18.8 is currently used. Some process will be running. This guy also had a 249 GB hard disk, 600 GB hard disk, 50 GB hard disk. You can all see from a single window. It's very easy. So it is not as complicated as you thought, by the way, right? So this is just the host menu, right? You can just, from Cloudera Manager, this is the home page. Click on host. Host, you will see this, right? Now, if you look at HDFS, this is HDFS. Click on HDFS, okay? You will see this HDFS menu. This is all related to HDFS. In HDFS, what we learned, replication, block size. So where do you configure this? There is something called configuration. And do you want to change the, see, it is saying read only. I cannot change it. But do you want to see the replication factor of this cluster? DFS dot, what is the replication factor? 3. Click there, you can change it to 2 or 10 or whatever you want. If you are an admin, you are not an admin. Do you want to see the block size? DFS dot block size. Can you see? So I can click here and change if I am a Hadoop admin, and it will be applicable to everybody immediately and all. Somebody was asking about balancer, right? Where is balancer? I can say actions. Okay. The problem is that some of these things I will not be able to run. Where? Instances. This is balancer where it is running, but I can run a command. Sorry? It's not green. It is not running. If it is running, this process will come as green actually. Then chart commands, configuration. So there is a lot of configuration. Okay, so that is one thing we saw, and host menu we saw already, right? So far we discussed only HDFS, and here is Kafka. If I go to Kafka, just go to Kafka, okay? Kafka says Kafka broker 3. That means 3 machines are running Kafka. I told you Kafka will be running in a cluster. Since this is a lab setup, we are running Kafka inside Hadoop only. Ideally, we run it separately because it needs storage spaces to hold your data. But here Kafka brokers are 3. We are running inside here only. Because this is only a cluster we have. I mean, these machines, if I go to these machines, I will show you. If you go to this host menu, you can expand a host and see what it is doing. For example, if I expand this guy, see, what is it? It is your name node, right? So, and also I can go to HDFS and see that. For example, I go to HDFS and instances. What do you see here? Active standby, 2 machines, 2 name nodes. I told you, right? Active and standby, they are running, right? So the same machines are running Kafka here. It's not a separate cluster, by the way. That's what I meant by that. I don't have really admin access, otherwise something could have been done. I don't want to mess up the cluster also, by the way. So some of the menus are actually disabled. We can't run them. See. Exactly. Ideally, that should not be the case, because then it is not utilizing the proper space, right? So ideally, you will set up a separate broker, and that will download the data actually. They are all running on AWS actually. I don't know. I mean, I don't have access to that. Can be anywhere, doesn't matter. AWS, you can create a cluster anywhere. I don't have any idea as to who created this cluster and all. It's a third party. They just give access to us. Even I have only read-only access like you guys have. Now, this is to just brush up for tomorrow. Tomorrow we'll be actually doing it. But I want to clarify one more thing. If you go to this Big Data Cloud Lab, this Cloudera Manager you don't really need, because that's the admin interface. You are not going to do any admin activity. The important thing that you need is Web Console. So if you click on Web Console, I just clicked on that. For some reason it is not opening up. Let me just see. Do you guys see anything?
Yes. You're getting login.
Why am I not getting login? You can log in, but if I have to show, I have to log in, right? So where is Mohini? She is not here. Yeah, you can log in. That will connect you to one of the machines in the cluster, and you will see Linux. You can just log on to one of the machine. That is what you see there.
Yep.
and I am not able to log on. You are getting the Linux shell. Take some time. No, I am taking long time. And there is a product called Hive. This is very important. There is a product called Hive. This Hive is a third-party application. Okay, but it is very, very popular. Why do you need Hive? Is that if you are a developer and you want to upload your files to Hadoop, you can use Hive, one of the use cases. For example, I can click this, I'll click Hive and last the username and password. If I sign in, okay, I'll just sign in. If I click on this HDFS browser, see there, this is my Hadoop. These are all the files in my Hadoop. So Hive is like a web UI to your Hadoop, HDFS file system. So these are all the files and folders. If you connect, you will not see anything here because you are having a fresh account. One more very important point I want to tell you is that in Hadoop, you will have a home directory, user/something. I have GL faculty. You will have your own directory. Can you try this Hive thing on your PC? Just click on this Hive, type username, password, see whether you can see this thing. Are you able to see? Another point is that sometimes the cluster will become very slow because it is not designed to accept requests from 36 people, right? If all of us try to log in, it will say timed out and other things. No? What username and password you're typing? Empty. That's fine because in your Hadoop home directory, there are no files. I have already ran something, so that is why these files are there. So we will create it tomorrow, don't worry. We will create it using
We are using the same data nodes individually for our own file management.
The same cluster. So different users are created in the Hadoop cluster. So if you log in, you will get a home directory, like in Linux. In Linux, what happens if you log on, you will get a home directory. So this is my home directory in HDFS. And since I already created some files, I can see them. You may not be able to see because it is a fresh home directory for you. Tomorrow, I will show you how to upload the file, run a sample MapReduce program, explain the program and all. We will do that tomorrow, don't worry. So there were some unanswered questions. I said I will pick it up later. I forgot also. Anybody had any questions I pushed? Did I tell you I will show something and I forgot also some of the things? Correct. No, it will be in a non-commodity hardware, like a real server. The problem is I am not able to connect with the web console. See, it is not giving me option to connect. I need to connect to that to show you something. Hive, Kafka. Impala is running here. Okay, I missed a concept. I wanted to talk about it. It's a very important concept, right? Do you know what is a rack? You know what is a rack? Server rack? A rack is like a rack, right? How do you explain what is a rack? Even I don't know how to explain.
Used to fit in the storage devices.
Servers and all. Because from the point of view of Hadoop, this might be important. Sorry. I will explain this one and then pick up your questions. Images.google.com. So this is for people who do not know server rack. Do you know what is a rack now? This is a rack. It's a housing where you push all the servers. In all the hi-fi movies, you will say somebody sitting something, typing something in a very big data center and all, right? So that's a rack. Why racks are important? They are important for one reason, because can I erase this diagram? This one? Even I don't know what I wrote. Anyway, that's fine. So why racks are important is because of one particular reason. See, let's say you have 3 racks. You are having 3 racks, okay? And each rack has a data node. Not one, there are many. So let's say 2 data nodes are there. So in reality, when you are installing Hadoop in a cluster, this is how you do, right? Because in a data center, you will have racks and you will have servers. These servers are called your data nodes, right? So I have 6 data nodes in 3 racks. Now there is something called rack awareness in Hadoop, meaning if let's say you are copying a block, what you can do, this first copy will go here, the second copy will go here, imagine, and the third copy will go here. Meaning, if you enable this feature called rack awareness, Hadoop will ensure that the blocks are spread across multiple racks. Why? Yeah, a rack can fail. A rack is a point of failure because normally you will supply this power and network, everything through rack. So if a rack fails, if I'm keeping all the 3 blocks in the same rack, if that rack fails, then my blocks are gone. So Hadoop can, if you enable rack awareness, you have to tell Hadoop which data node is in which rack. If you do that, it can place them like this. But why don't it keep like all 3 in 3 different racks? Why the rest of the 2 copies are in the same rack? Yeah, but same location means these are all in the same data center, right? So this inter-rack bandwidth is very important. Rack to rack, the bandwidth is very important. So this is just replication, right? You will be running a lot of programs which will use this bandwidth. So to save that bandwidth, what it does is that the next replication will happen within the rack, server to server. But this is enough. Now even if one rack and all the 3 racks going down is very remote possibility, right? And my point was, I can show you that here. So when I saw that, if you go to all host, can you see this? So in the rack 1, 4 are there, rack 2, 2 are there, rack 3, 2 are there, and default rack 2 are there. Default means, I don't know, they have kept something here, but 4, 2, 2. So this is actually the distribution. It is actually available in your Cloudera manager. No. Each rack is not a system.
What you are going to do is just plugging just like one data node into the rack.
Not one, many will be in one rack, right? See here. All the masters will be in a separate rack. See, if you look at this picture, right? In this machine, some 30 data nodes will be there. Each slot you'll have one server. They are all rack server. So server is not like this, it is like this. Like a pizza. You get a pizza. How does the pizza looks like? That is how a server will look like. Not like this. There is also that kind of server. Tower servers are there. But these servers typically we use are these kind of servers. I had a picture actually. Yahoo, Hadoop cluster at Yahoo. Hadoop cluster at Yahoo. So the biggest Hadoop cluster on earth is with Yahoo, actually. Yahoo holds the record for that. They have 42,000 machines. And still they went bankrupt, sold it to some useless company. So the picture is not visible actually. But you got the idea. This is... No, that's a good question. So, can I have multiple name nodes? Yes. The concept is called federation. Meaning, ideally, if you cross more than 5,000 data nodes, you need one more name node. Like 42,000 machines, I cannot have a single name node to handle because the amount of metadata, it will become slow. That is a problem. So ideally, Yahoo has done some R&D. They said that if you cross more than 5,000 data nodes, you need one more data node. That's called name node. That's called federation. Federation means multiple active name nodes. Like you can have 10 name nodes, all will be working. They'll share the load actually, right? So like that. Federation is called it. Yeah, sorry. All in one rack actually you can put. Inside the same data center only you need all of them, right? Because all the data nodes are in one LAN, so the name node also should be inside that only. But they will handle the load actually. So some data nodes will be to this name node and all. They can handle the load.
Can you have multiple?
Sorry, just a moment. File server can store, but it cannot process, right? That's the use case. Hadoop is not only for storing. Whatever data you store, the data can be processed then and there by the machine. Correct. Correct. So there we are not using Hadoop, right? We discussed it in the beginning of the class, NoSQL databases. If you don't want processing, if your use case is such that I just want to dump a bunch of images, let's say 1 million images, I just want to process and display in an e-commerce website, I don't use Hadoop. Hadoop is not used for that. There you have NoSQL databases like DynamoDB or MongoDB, right? SharePoint. If it is a smaller setup, SharePoint you can use. Right? Which one? Haystack. Haystack is built on top of this. Or top of this. Yeah. Facebook's, right? Correct. Correct. So it is all business use case. The question is that what do I want to do with the data? There are other companies who generate terabytes of data, they just archive the data. I just generate data, I don't want to analyze, I just archive the data, who cares? So it is up to me to decide what should I do with the data, right? I was working with GE, very interesting use case. GE, right? The company called GE. I have a training next week there. So they have an aviation department. GE is building this aircraft engine, you know that? Flight engine. 80% of the commercial aircraft engines are from GE. And what they do, so most of the planes are flying with GE engine. There is also Rolls-Royce and one more company. So all these aircraft engines are having sensors. So when the flight is flying, they capture the sensor data like pressure and blah, blah, blah. And they analyze it to predict when the flight will crash or turbulence will hit or something like that, whether you're going to die or something. So the idea is that, so I said, okay, good deal, you're doing this. They said, no, it's not a good deal. The problem is, if a flight is flying from, let's say, Dubai to Bangalore, there will be 2 engines. It takes 6 hours. Each engine will generate 1 TB data. How many flights are there in total and how many flights fly every day? Can you imagine the amount of data? They don't analyze. How can you analyze? I mean, if I'm giving you, let's say, 1000 terabyte every hour or every minute, you can't analyze it. So they take a subset of that. They have an algorithm which takes a subset of the data and analyze. Rest they delete and dump. Because it is not humanly possible. Also, you don't need that much amount. Every sensor data need not be analyzed. This is very interesting because they also have locomotive engines, train. All the Europe and US, they run trains. And these trains are having sensors. So they get also that. It's very difficult to work with GE because huge amount of data, they also don't know what to do with the data, right? And they have no clue how to make sense of the data. Locomotive data is huge actually. So the trains will generate a lot of data actually. So they get it and then they take it and clean it and just get only a part of the data and they analyze it. In Hadoop, you also have certain file formats. For example, Avro. You may not have heard about it. Avro is a file format we use only in Hadoop. Parquet, ORC. These are all used to compress and store your data in Hadoop. You can also have compression techniques, because sometimes storing the data as it is not good. Why don't you compress it? But what is the drawback of compression? You have to decompress. You need a lot of processing power if you want to decompress it. So Avro is a serialization format. It doesn't compress the data. Parquet and all will compress the data columnly and push the data. So I will show you in Hive, when we discuss Hive, when you create a Hive table, you can say that the data has to be compressed. It will compress and store the data actually. And that is possible. So my point is, not everybody want to analyze all the data in the world. That is also humanly not. Think about Facebook, how much data they'll be getting. Probably they are not analyzing the whole data, a subset of interesting data. That is all they will be doing. So any questions? We'll wind up at 6:30, I think. But before that, we can pick up questions. Yes, Spark is memory intensive. Ideally, Spark requires RAM. So if you give RAM, it will perform better. If you don't give RAM, it will use hard disk. I mean, rest of the space will use hard disk. Performance will be slightly degraded. So for streaming and all, we need a lot of RAM. The problem is, Football World Cup is going to happen, right? Yes. Right? When? This year only, right? So let's say you want to write a program which will download all the tweets and find out the most favorite player for Football World Cup. Possible, right? So I can easily stream the data from Twitter. The problem is, I want to find out, the most popular player every 5 minutes. Imagine. Probably not 5 minutes you want to do. So I want to get 5 minutes worth data, hold it in my memory and process. What if 5 minute data is so huge I cannot hold it in memory? Then it will be slow. Yes, I'm just giving an imaginary situation where if 5 minutes worth data is in terabytes, you can't hold it actually. Not only Twitter, any data that you have, then you might want to persist into disk some of the data. Then processing will become slow. It is not real time then. So when you are running Spark streaming and all, your RAM should be available. Otherwise, it will become very slow. Today's match you will predict tomorrow, right? So things like that can happen. So that's not really good actually. So a lot of considerations are there where you have to use all these things. So I think we will wind up. What do you think? Yeah. So it's almost 6:30, and also.
That you taught today is included in the slide pack?
Yes. So I will be sharing slides, also books. So there are a couple of good books written on Hadoop, which will give you a lot of idea about basics like how HDFS is working or all these things actually.
How much in depth do we need to understand it to basically complete successfully?
So I would say whatever I am training here is enough, but go through the book also. Say for example, HDFS, you don't have to be an expert on high availability. See, there is an active name node and standby name node. If the active fails, standby will take over. How that happens, there is a process. So probably that topic, even if you don't know, it is not a big deal because that's an admin topic. If you are a Hadoop admin, you should know how that should work. But since you are a developer, you don't have to go in depth into those topics actually. So MapReduce and Hive should be more than enough, I think. And you are building this awareness to learn Spark. The basic idea is that you are building this so you can look at Spark. So I will say concentrate on Spark. So let's talk about Hive, right? Which you people might be mostly interested. And usually I'm not a slides person, but for Hive I need some slides. This has around 60 slides. I will not run in all of them, don't worry. I'll share it with you, you can go through that. I'll run a couple of them to get an idea, right? And so that otherwise everything I have to draw and explain, it will be difficult for Hive, right? So Hive is actually very simple. In 2005, when Hadoop came, most of the major vendors started using Hadoop like Facebook, Yahoo and all. But they all faced one common problem. The problem was that Yahoo started using Hadoop, but Yahoo had a lot of developers who did not know Java. So the problem was that they had to write MapReduce programs, and skill set was the problem. You can't say that everybody should learn Java and start writing code. So Yahoo found it very troubling. Same time Facebook also started using Hadoop, and they also had the same problem. Facebook had mostly SQL developers, and they were not comfortable with Java. And way back in 2005 and 6, we had only MapReduce. There was nothing else on Hadoop. Okay, plain MapReduce, nothing else. So the Hadoop ecosystem we saw in the last class, none of that was available. So everybody was confused. So Yahoo and Facebook started two projects same time. So Yahoo created something called a pig, the creature pig, animal pig. Seriously, it's called pig. pig.apache.org. See, that's a pig, real pig creature. So Yahoo created this tool called pig. It's a scripting language. I teach a course called a pig on Hadoop, only on pig. It's a very interesting language, scripting language. Advantage is very simple. You learn this language and then you, whatever analysis you want, you write in that language. It's a script. So very small, like 4 or 5 lines max or 10 lines. And once you write your pig script, you say run, it will convert your pig script into MapReduce program. So you don't have to learn MapReduce, you learn pig. And somewhere in 2010 and 11, there was a heavy job inflow for pig developers. 80% of Hadoop job was handled by pig in 2010. 80%. It was such a successful language that everybody was dying for pig. I have taken only pig trainings. People don't, because that was the effect of pig actually, right? Because it's a very easy language, scripting language. You just learn it and everything will happen behind the scenes. You want to do a join operation, you say join A comma B, that's it. Even SQL queries are more complicated in join. You have to say A dot, B dot. Here nothing. Take A, B, join A comma B. Done. Joining done. Simple inner join I am saying. So people started using pig extensively. But at the same time, yeah, Facebook developed Hive. Hive's idea is different. You write SQL. Okay, you create your databases, your tables and all the blah blah blah. You write SQL and Hive will convert your SQL query into MapReduce. Same concept. So two companies developed, one pig and one Hive. They didn't know that they were doing the same thing ultimately. But then what happened, somewhere around 2010-11, pig started losing the attraction because Spark came. So when Spark came and became predominantly useful, Spark is also very short and like a script you can write in Python and all, very easy to write. So Spark and pig are almost similar. So people thought like, if I am learning something very short and interesting and very fast, why should I learn pig? I can learn Spark itself, right? So pig is no longer used by anybody, very rarely. Pig is gone almost. Hive is not gone because it is SQL. SQL will be there till the world exists. Right? No questions asked. Right? No questions. SQL is SQL. So you can't get rid of SQL, right? How do you get rid of SQL? What if all the ETL developers and there's a huge community to back SQL, not like pig. I actually like pig more, but there is nobody to back pig, right? There is a lot of people who back SQL, right? And that is not the only reason. Hive is a beautiful data warehouse. It is treated as a data warehouse of Hadoop. Meaning you can create tables and you can query the data. So most of the visualization tools and all, can use Hive in the backend to fetch the results and all. So Hive became very popular. And now what is happening? Hive is there, plus Spark is using Hive. In Spark you have a module called Spark SQL that uses SQL language. Now that guy can process itself. It can also talk to Hive. So whatever data you have in Hive, Spark can also read. So Hive is predominantly used these days, and Hive will always be very popular. It may be, I think, one of the most popular ecosystem tool is Hive so far in the industry, because it's been 10 years, 12 years, and still community is very much. So the command wise it is very simple because it is SQL, and I don't think I have to teach you SQL. That's not the idea behind the session. You will already know SQL, but we will just see what is happening behind the scenes if you write a SQL query and some of the advanced concepts in Hive like partitioning, bucketing, indexing, these kind of things. And from the industry experience, there is one major thing. There are two major vendors, Hortonworks and Cloudera, right? Now Hortonworks uses original Apache Hadoop. That is their propaganda. So whatever, Hive is also Apache product. It's open source, right? And whatever major changes are there in Hive are predominant in Hortonworks, not in Cloudera. Cloudera is actually not so good at Hive. We are using a Cloudera lab. That's bad actually. I mean, I'm not blaming the lab, but Cloudera is actually a bit bad in Hive side. I'll tell you the reason, because I teach at Hortonworks. That is the reason I'm able to tell. In Hortonworks, they have a project called Tez. Some weird people from Delhi created this project. Tez is a Hindi word. There is a weird movie by that name also, right? Have you heard Tez? Tez, speed in Hindi. So Tez is a, how do you say, it's not a replacement. Tez is a project created by Indians. Then they gave it to Apache. It became open source. Tez is faster MapReduce. So what these guys did, normally in MapReduce what happens, you read the data, right? And then you do mapping and then you store the output in hard disk. Again in Shuffle you read the data, do the shuffle, store the output back in hard disk. Again reducer will read from hard disk. So some weird guys thought, why don't we do all this in memory? We don't want to use hard disk, read the data once, do all the map, reduce, shuffle and then push the result. So your map reduce becomes 10 times faster. That is Tez. So it's a DAG, a directed acyclic graph concept, and Tez was given to Apache. What Hortonworks does, if you write a Hive query, they will convert it into a Tez job, not MapReduce job. So Hive queries are very faster on Hortonworks. In a Cloudera cluster, Cloudera doesn't support Tez because Tez is contributed by Hortonworks. They are competitors, right? So if you are working on a Cloudera cluster, you will never see Tez in your life. They won't allow. So the problem is that if I am writing a Hive query on Cloudera, it's very slow because it will convert to MapReduce, run as a MapReduce program, takes a lot of time. If I am writing the same Hive query on Hortonworks, it's at least 5 times faster because it converts to Tez job. By default it is Tez, and Tez is superb, you can't compare, right? So that is one drawback. I mean, so when you start working in the industry, so these days mostly people are moving to Hortonworks for majority of reasons, but the stake is at Cloudera only. Number of users are more for Cloudera, but over a period of time probably people will shift to Hortonworks. So these are good to know information. So then you will be thinking that from Cloudera there is no answer to this. No, they have Impala. There is a product called Impala, Apache Impala. Impala's contribution is mostly from Cloudera. Impala does the same thing what Tez does, in memory, fast, real-time queries. So I'll show you Impala. We have Impala in the cloud cluster. I'll show you Hortonworks cluster also if you want. So Tez itself as a project is not really, how do I say, important right now. Since Spark came, most of these things are gone, including Tez. Because Spark is also in memory, Tez is also in memory. So when Spark came, Tez relevance is not there. But the only relevance is that if you are running a Hive query, it converts it into a Tez job, so it's faster actually on Hortonworks platforms. So I will show you a Hortonworks cluster probably tomorrow. Okay, I have an access. I'll show you the Tez job running. You'll see the difference actually. So but there are a lot of companies who run traditional Hive, only Hive. Like they don't want to use Spark, they just want to use Hive. For them, going to a Cloudera may be a bit challenging because Hortonworks by default give you free Tez, right? So Tez is fast. Also, Tez is fault tolerant. Impala is not. I'll discuss probably tomorrow, probably too early to discuss, but there are SQL engines are too many actually in this category, and there is a tight competition between all of them. And it's all marketing gimmick. You go to Cloudera, they will say that Impala is the best in the world. Never listen to Hortonworks. Hortonworks will say that. And Hortonworks recently, Hive recently announced something called LLAP, Apache Hive. LLAP is real-time queries using Hive. Hive is normally batch processing because it is converting into MapReduce, right? But recently Apache announced that Hive can support real-time queries. That's called LLAP. Real abbreviation I don't know. Long live and process. That is not the real one, but we used to say long live and process. It is still in beta, not so. But the problem, LLAP is available only on Hortonworks, no Cloudera. Open source, right? Because it is a contribution of open source Hive, which is available only on Hortonworks. Cloudera cannot get it. So they are still with Impala. Impala is the only solution they have. So when you talk about Hive, there are a lot of things, but you should be aware of the industry, what's happening, right? So these are the reasons why people are shifting towards Hortonworks. Some of the major things I see compared to that doesn't mean Cloudera is bad. Okay, it's not like they are also having great support. Their technical support is excellent, and even with this Impala, they do a lot of tricks actually too. So if you have a problem, they'll give a solution. But a lot of people are preferring this open source initiatives. Hortonworks and all are open source. But the problem is, I told you, right, I was with GE, they use LLAP, none of the queries work most of the time. It is open source, right? If it doesn't work, you can't blame. Cloudera will fix it because it is proprietary, like iPhone and Android, right? So open source, you get a lot of features, but it will work or not work, you cannot guarantee. That's one thing. But they will blame internally on Apache. They say that we'll give you technical support within the limits. So originally the product is by Apache. So Hortonworks cannot fix directly because it's an open source community. Most of the things work. I mean, I'm not saying that everything doesn't work, but open source has its own drawbacks sometimes, right? But I'm seeing a lot of people migrating to Hortonworks actually these days, right? So in Hive, what you need to understand is these things. It provides SQL-like interface on Hadoop. Now, very important point, Hive does not have storage. It uses the data in Hadoop. For example, you copy a CSV file into HDFS, and what I can do, I can go to Hive, say create a table and give the schema. Then I say load this CSV to the table. What is going to happen? The CSV will be in Hadoop. It is on HDFS. It is as blocks and replicas and all, but in Hive you will just project a structure. So you get a table. Once you get a table, you can do any SQL. Most of the SQL, right? So the idea is to project a structure to the data that is already available in Hadoop, and Hive can create tables from a variety of formats, structured data, even log files, unstructured data, JSON files. Different types of files can be read by Hive and put it in a table format, right? So that's the importance of Hive. So it's treated as the Hadoop data warehouse system. So the data is in HDFS, and this is just giving a table-like structure on top of the data. Hive will just maintain the schema only because the data is already in Hadoop, right? So you don't have to load the data. Even though you say load the data will just become in Hadoop. I'll show you how to load the data. I mean, how to create a tables and all. Yeah. So if you want to run a query, you can directly say write your SQL. Say select count star from the table. But the problem is that it will hit Hive. Hive will read the query, and it will convert it into a MapReduce program, Java based, create a jar file. So that will take some time. Then when it runs, it's a MapReduce job. And the funniest part is Hadoop never understands what is Hive. For Hadoop, it's a MapReduce program. You're getting the point, right? From the Hadoop's point of view, there is nothing called Hive. It understands only MapReduce. So whether you write a MapReduce or Hive write a MapReduce, it's the same thing, right? If you want, you can write a MapReduce program to query structured data. It's very difficult, that's why we're using Hive. It will translate and create a jar file, push it to the cluster, and the cluster will run the MapReduce regular program, show you the output. You can save it in a table or anything you can do. So you can use all regular SQL statements. You can say insert into a table from this table. So the result will be, if it is matching with the schema, it will insert the same way. The only thing it is projecting a structure. Hadoop only, HDFS only. Everything is on HDFS. It is slow. Hive is expected to be slow. So that is one thing. Hive is considered to be a batch processing engine. So it is not a database. Another common problem is that people may not be able to differentiate between a database and a data warehouse. They are different, right? A database is OLTP, you call transactional, real time, right? Where you want millisecond speed, right? Sub-second speed. That's a database. and you always have insert, update, all these kind of operations. A data warehouse is different. A data warehouse is a place where all the cleaned data comes and lands, right? From there your reporting tools can connect and visualize the data, right? So Hive is a data warehouse where you store your final data. So let's say you have a lot of tables, you ran queries and you got the final output, you store it in Hive so that your visualization tools can store it in HDFS, but we say store it in Hive, but it's in HDFS only. Meaning if I open Hive and say select star, I will see a table. If I go to the location, open the file, I will see a text file. Same thing. So the text file will be there. If I open and say select star, same text file, it will show me in a nice row column format. And another thing is that Hive's language is actually called HQL, Hive query language. It's not SQL, but it is based on SQL 92 syntax. Most of your queries will work, okay, but it's technically called HQL, Hive query language, right? It's up to us to decide. I mean, so the idea is to familiarize with Hive. Then depending on our business use case, we can write any SQL queries. You can write complex queries, simple queries. You need to have some idea about SQL queries, like what is a join operation, what is a group by query, to understand what is happening. Even a person without knowing SQL can learn Hive. I mean, by looking at a query, you can understand what is the intention of the query, right? Hive is not a DB. Hive queries take minutes even for small data sets and can't be compared to databases like Oracle. Hive does not provide real-time queries. So that is what the original Hive which came was converting into MapReduce. So it was very, very slow. Then came Thais. So what Hortonworks did, they started using Hive plus Thais, which is a bit more faster, right? Cloudera cannot use Thais, so Cloudera still runs Hive into MapReduce. And their answer to that is Impala. Impala is an in-memory execution engine. But Impala will work only on Cloudera. So I will show you Impala, and same query will be very, very fast. There is no difference apart from that. I mean, syntax and everything is same actually. So data warehousing in the sense like usually it is used as a storage engine, rather than. So what is a data warehouse? A data warehouse is where you store all your massive data, right, structured data, and the intention of Hive is also same, and all the BI tools can connect with Hive. So if you are having something like Tableau, for example, Tableau is a visualization tool. So I want to visualize terabytes of data from Hadoop. I can connect Tableau with Hadoop, and Tableau will be firing SQL queries using Hive, and the data can be visualized. So that's a typical application of a OLAP system. So it's an OLAP system, online analytical processing. It's not an OLTP system. So you can't compare it like Oracle, because that's like real time. But again, Hive cannot replace a proper data warehouse, okay. So if you're talking about something like Teradata, for example, so they are like, how do I say, the expensive and fast, reliable data warehouses. Understand, Hive is built on top of Hadoop only. So it has all the drawbacks of Hadoop, right. So most of the organizations, what they do these days is that they will categorize their data, hot data, cold data. The hot data will go to something like Teradata, where they need to immediately fetch the data, run faster queries, and the cold data, which it's okay, you can take some 10 minutes to query, will go to Hive. Hive supports insert statements now. It was not there before. Insert statements are already there, but the problem is that each insert statement will fire a MapReduce job. So you do a bulk load, that's better. So in Hive, normally when you load the data, you do a bulk load, you don't insert it. And the latest editions of Hive support all the CRUD operations, create, read, update, delete, everything is supported. But again, if you want to get the speed, you should use LLAP. That's what I'm saying, real-time queries, LLAP. And LLAP as of now, Cloudera doesn't support. So I can say, if you are on a Cloudera platform, inserts and updates will be very slow. Not like Teradata. Teradata and all inserts are very fast. But the question is that in a data warehouse, usually you don't have to do an insert. Very rare, right? Because you will do bulk loading of the data, or your ETL tools will be dumping the data there. They will collect data from the RDBMS and then dump it into there. So very rarely you modify the data in a data warehouse. So the use case is like that for Hive. Yes, all the CRUD operations are supported, even insert, update, delete, but it will be slow. On Hortonworks platform, you have ACID support enabled, transaction management, but it is not as reliable as a database, okay, because you can never replace an RDBMS system with something like Hive, but you have transaction management supported. That is all with LLAP. LLAP is the feature which gives Hive real-time performance, but LLAP also requires resources. It can also, it requires more resources to execute, but you get all the ACID properties, transaction management, everything. And this is very important to understand. So there is a command line interface for Hive. It's called Hive shell. You can open the Hive shell and start typing your query. Say create database, create table, and then type the query. So that is one way to work with Hive. But people may or may not use it, because if you are in the production and all, you might have some client, right? So what type of clients you use, like to connect with DBs and data warehouses, so SQL Server or Todd or something, no, something like that. You might either you can use that. So one thing is that you can use a CLI, and Hive is very vast actually, so I am getting confused when I talk. This CLI, there is two CLIs. The original CLI is called Hive, and you simply type Hive, it will open, you do all the blah blah blah. The new CLI is called Beeline. It's called Beeline, okay, and Beeline is a proper JDBC client. So through Beeline also you can open the CLI, or you can simply say Hive, it will open the command line for you. You can do all the create table statements and all. There is a web GUI, but it is very rarely used. Hive is just a client. It's not a JDBC client. So when I open the CLI and say Hive, JDBC, you have drivers, right, to connect. So when you want to connect from an application, right, to a database, you need a driver. That's called a JDBC or ODBC drivers are there. That's one way to connect. So the CLI, original Hive CLI is called Hive client. That's not a JDBC client. You just open it, it will directly hit Hive, and it will directly hit the Hive, and you can type all the queries and all. The Beeline is a proper JDBC client, which means you can install it in some other machine. From there you can connect. You can give the server address, port number, and it will hit, right? And it is not written here. There is something called Hive server. This whole part is called Hive server, this part. For some reason in the diagram it is not written, but this whole part is called Hive server, because if you are connecting with a data warehouse, there should be a server component which will accept your queries, whatever you are typing, right? So that is this whole part. So whether you come through CLI and there is a web GUI or JDBC, you all hit the Hive server, right? And Hive server is the component which will accept your query. So once you write a query, there is a planner, parser, optimizer. It will optimize your query and convert a MapReduce program and push it into the Hadoop cluster. In Hive server itself, you have Hive server 1 and Hive server 2. Okay. So the old one is called Hive server 1, which nobody is using now. You don't have to bother. The latest one is called Hive server 2. Okay, that is everybody is using. So Hive server 2 is responsible for managing all your connection. So if you open a connection with Hive, it will directly hit this Hive server 2. And from there, whatever query you write, this guy has a compiler, optimizer, executor. It will get the query, compile it, optimize it, push it as a MapReduce program. Right? I think I can show you that from here. If you go to Cloudera Manager, it should be here. It is very difficult to talk about Hive rather than showing something, because talking is fine, but if I show something, probably people will understand more. So if I go to Hive configuration, where is Hive server? See, Hive server 2. So this is called Hive server 2. The default Hive server is Hive server 2, because there was an old Hive server 1 which nobody is using now. because of performance issues and all. So right now, whether it is Hortonworks or Cloudera or any platform, the server component of Hive is called Hive Server 2. Okay. So either you come through a JDBC client or the command line, you are all hitting Hive Server 2. Okay. From there, it will compile your query and optimize your query and push it. And there are tons of optimization techniques in Hive to read your query and better it and all. Probably we will discuss that tomorrow, some of the optimization techniques. Another very important point in this slide is this metastore, this thing. Meaning, if I open a Hive session and I say create a table, if I exit, it should not go, right? Because the table should persist, whatever you are creating. So that is where the metastore comes into picture. That is where all the metadata will be stored. And in production setup, what we do is that we will create a MySQL server, and in the MySQL server, metastore will be configured. So all the metadata of your table, like the schema, access rights, everything will be in the metastore, right? So you have to ensure that the metastore service is running, otherwise Hive will not start, because it needs to talk to metastore. This metastore is very important because even in Spark will talk to this metastore. So if I create a Hive table, I can read it in Spark because it can talk to the same metastore and get the data from there. All the metadata will be there in the metastore. Okay. Metastore is the metadata. Metastore is a service and that will push the metadata. So you have to give a destination so here it will be there. I'll show you where the metastore is. I don't know where they have configured. If I go here to Hive configuration, right? Hive metastore server thread. Database type is MySQL, right? Yes, this is where it is. See, on this machine they have configured MySQL, and that is where the metadata will be pushed. And we don't have any use of the metadata. Hive will read and write it, that's fine, okay, and it uses it to persist all the table information and DB you create and everything, right? We don't have much of a use for that, but it is there. And in Hive you have something called a cost based optimizer, CBO. I don't know why it is disabled. Enable cost based optimizer, disabled. It is disabled for some reason, I don't know. So this is called CBO, cost based optimizer. You are aware of RDBMS, right? If you write a very complicated query, it will generate multiple query plans, how to execute this query, this optimizer. So what Hive does, if you enable it, if you write a very complicated query, it will generate multiple plans, and based on the cost of each plan, it will select the best plan. So that is the cost based optimizer. It is disabled. I don't know why it is disabled. So usually you can enable this, and this is how optimization can be done in Hive, right? So this is one thing, CBO. We will look into other things also. Okay, all the configurations are here. To start Hive, you simply say Hive, that's it. If you simply type Hive, it will start the Hive shell. May I get some warning, that's fine. And you will easily see a warning saying that Hive CLI is deprecated and migration to Beeline is recommended. That's okay. So what it actually means is that this is the original Hive CLI, and I told you that Beeline is the new client, so they are saying that use Beeline whenever possible. So that's fine. I mean, to learn Hive, I think the best way is this CLI. They have added some more commands in the Beeline section actually, because the old Hive CLI support is getting lower every day. But for learning purpose and all, it's all the same, whether you use the CLI or Beeline. I'll show you how to use the Beeline also. So this is the Hive shell what you open, right? And it's very easy to get started with Hive. All you can do is that you can start by creating a database. You say create database. So first thing is that we create something called a database, right? That is the highest level of abstraction. So I say create database, I don't know, something May 19th. So I just created a database. So the command is create database and the database name. So I'm just calling it as May 19th. And if I do a show databases, you can see a lot of DBs are there. People have created, right? See here. So these are all the databases that got created inside Hive, and mine is May 19, right? You could have created something else, right? Whatever, I mean, you remember. And you have to say use to switch the DB. You have to say use May 19. These are regular commands if you are aware of SQL, right? There is a way to show that. It will display the DB name. Set Hive. There is a property where we can enable it to see the DB. I'll search for it. You can even print the column headers. So normally when you say select star or something, it won't show the column headers. The column name. You have columns and the names, right? It won't show. But you can make it show. There is a command to print that. So first we'll make sure everybody is on the same page. Hive print current DB. Set Hive CLI print current DB. So this is how you can print your DB. You simply say set Hive CLI print current DB equal to true, and then it will display the DB there. Can you try this? Everybody is able to log on to Hive and start and all. Anybody having problem? In Python you don't have, right? No, you have indentation. Indentation is very complicated actually. You miss one indentation, nothing will work in Python. I know that a lot. Very difficult. People who are coming from the Java world and you are familiar with curly braces. Here everything is, you start a control structure, there is an indentation, right? But the editor will take care of it, I think. If you are using some editor. That will be in the metastore. Only the definition, right? Metastore will have it. All is the same. That's what. When you normally start Hive, I said the use May 19, right? That the DB. It won't show me in which DB I am in. So now it is displaying it here, right? See this. It will show in bracket what is your current DB. So it will display whichever database you are in. If you change, it will show, right? And another important point is that probably towards a little bit towards admin side, there is a file called a Hive site XML. Hive-site.xml, and that file has around 1000 properties, and the whole Hive is controlled by that file. So these properties are actually from that file. Meaning either you can do like this, you can open a session and say set Hive blah 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 true, but if you exit and re-log in, it will not print the DB. Again you have to type this. Or you can ask your admin, change in Hive site XML this property, so that for everybody who log in, the DB will be visible. So that file has lot of properties actually. I'll try to find that for you. Problem is that I was with Hortonworks for the past 10-15 days. I'm finding it bit difficult to read Cloudera, but it will be here. configuration. Or do one thing, no, it's easy. What you can do, all of you can do, open one more command prompt, web console, and just copy. If you go to cd etc hive conf, yes. If you navigate to this location, this is common for Cloudera, Hortonworks, everybody. etc hive conf folder, you will have a file called hive-site.xml. This file controls end to end of Hive, all the properties, right? And if I open it, you can see all the properties. See, Hive Metastore URI. This is the Metastore URI, remember? So where the connection is there. Then some other things are there. Auto convert, join. How do you search in VI editor? This one, right? Then I can type, right? What did we set now? Hive CLI. Oh no, Hive dot. It says pattern not found. It should be there, right? I mean, I'm just wondering. Or what if I search DB? Saying pattern not found DB. Should be there. Let me just search for Hive. Probably, I don't know. See, all this, what you say, properties are there in this file. Probably some of them are, so another thing is that you are accessing this file locally. I mean from this machine. If I go to Cloudera Manager, configuration, I'll say DB. Should be there somewhere. I think some of them are actually not visible to us, but all these properties are read from Hive-site.xml. All these things will be in Hive-site.xml actually. So that is how you can print the current DB you are in. Well, that's not our intention. What is our intention? So let me show you the data that we have. So if you go to this folder, right, you will have two files. Now, once you start loading data to Hive, it is very complicated. Even though the queries are very simple, people try to get, it is like watching a Christopher Nolan movie, you know, you won't understand what happened after, once you finish the movie also you won't understand what happened. So the point is, I will write first, then probably we will do it, okay. So you will create a table that everybody knows. This you will do in Hive, you will say create table blah blah blah, it will create a table, fine. Then next step is that you want to load the data into the table. The data can be loaded from local file system or HDFS. It's a bit tricky. So if you create a table and you want to put some data, right, the data can be loaded from Hadoop or from your Linux file system, right, okay, and I will show you what will happen, how to do both this and what is going to happen if you do both this, what will happen to your data and all these things, right. So we'll do step by step, otherwise people get confused a lot in this stage. It's actually very easy, but end of the day people get confused a lot. Where is my data? What happened to my data? Sometimes you will get local also. So what happens, these ETL tools and all, sometimes they dump it into some local machine. You can load. You can say Hive, take it from my Linux, dump it into. So it is actually copying from Linux to Hadoop. But there is a way to do it. That's what I wanted to show. So let's look at the data, right? We'll also do some small analysis. Can you open this file? but I need a better editor actually. WordPad will do, right? That file is already available in your dataset. Let me download this, okay, real quick. Can you see this file, transaction.txt, txns1? It will be here. You will have a code and data folder. Inside that, Hive, inside that. I think it is a .txt file, right? Because for me the extension is not visible. Just give me one moment, I'll just install this Notepad++. So last class you are watching Narcos or what? The ads are coming, right? What happened in the morning? So what we will do is that first we will copy the file to the local file system, that is Linux, and then we'll create a Hive table. We say load the data to the Hive table and we will see what is happening in that process. Then, so there are two files actually. Another file I'll copy to HDFS. From there I'll load to another table and show you what is happening. It's okay, we'll try without this. I mean, you have Notepad anyway, right? So that's fine. I just wanted to show you this. Yeah, so this is the transaction data, what we have here. And if you look at this data, right, I'll just take one line and explain what it is so you can understand, right? So if you take this line, so the first column is the transaction ID, that's nothing but 18. Then you have the transaction date, then you have the customer ID. So 4002444 is customer ID, okay? And then you have the amount spent, $88. Then you have the category of items he bought, team sports, and what actually he bought, baseball, city of Salt Lake, state of Utah, and credit. So it's a typical sports store transaction. What category, what item, what amount, credit, debit, you know, and you have n number of lines like that. That's okay. That's okay. No problem. So this is one data that we have. It's a transactional data, and we want to create a Hive table, load this data. So that's one thing. Second data that you have, there is a file called a cust. Can you see this? And I want to open this with WordPad. Yeah. So this is the customer data. So first column will be customer ID, first name, last name, age and profession. Christina Chung, age 55, is a pilot, like that, right? So you have a store customer data, you have a transaction data, right? And what we want to figure out is that we want to figure out the total amount spent age wise by the customers. For example, I want to know in my store what is the total amount spent by people aged between 20 to 30 and 30 to 40 and 40 to 50. So that is the analysis we want to do. So in one data set we have all the transaction, like how much amount they're spending and all. Second data set we have the person's name and age and all. So we'll do a join and then we will do a case statement and figure out. That's what we are going to do. So the SQL analysis is not the intention. The intention is to show you what is happening behind the scene and how Hive is dealing this, right? Okay, so now what I want you to do is, first we will do only the local. So we will copy the data to the local file system. From there we will analyze it. So I want you to copy these two to our local system. So how do you do it? You have to open the FTP stuff, right? So I will just say FTP login and hopefully it might work for me. Upload files. So upload these two files. One is called cust, C-U-S-T. Another one is called txns1. Open. Yeah, so it works here. Okay, I need to open one more. Okay. Luckily for me, it is available. You have to figure out. So use FTP and copy the files to Linux, not to Hadoop. Don't upload to Hadoop. I'll just wait if you need some time. Yeah, but we don't have to change the extension. Yeah, so if it is a text file format, it can access any text file. Only thing you have to mention the delimiter, comma or whatever it is. So Hive can handle text, CSV, JSON, XML, variety Parquet. So there are multiple file formats it can handle. So by default it will read all the text, but if you are having JSON and all, there is. So are you guys familiar with something called SERD? Have you heard about SERD? No, SERD stands for serializer deserializer. Okay, it's a very common practice. So what will happen is that, let's say you have a JSON file. You know what is JSON, right? Key and value, like key value pair. So if I have a JSON file, I can ask Hive to create a table from that. But the problem is that JSON is semi-structured data. It's not proper comma separated or something. And Hive will say, I don't know what you're talking about. I can't find a schema. So to do that, we can use something called a JSON SERD. You have to download it. It's a jar file. I don't know whether the latest Hive has it. If not, you have to download a jar file which is called a JSON SERD. Okay, add it into Hive, and then you say create a table using the SERD. So using this SERD, it will parse the JSON, and key will become the column, value will become the data. Like that. So SERDs are used to read semi-structured, unstructured data. I will show you an example of unstructured data where you can use something called a regex SERD, regular expressions you can use to parse the data. So Hive supports a number of SERDs actually to read different types of data. JSON I will see, if I have a data I'll show. So that is again an open source projects, most of them. So internally nothing happens. They will read the key and the value if it is a JSON SERD, and it will give that structure like a table to Hive. So if Hive looks at it, Hive will not see as key value pair. Hive will say a column header and a value. It will just apply the same thing. So it is reading the semi-structured data and giving a structure to that. It is a parser. So we have parsers, right? It's a parser actually. So this thing, are you able to do? Are you able to upload, everybody? And find this file. You have a file called commands. Can you see whether it is there? Just commands. In the Hive folder, you will have a file called commands. No. This is not. This is the commands we have to type or copy paste. So we don't have to upload it. So this is in the for me. This data is in the folder called Raghu. Okay, that is where the data resides. Let me close this. Now we can actually create a table. So let me just copy paste this. You can, so don't do a create database, because the first two steps we have already done. We created a database and then we said use it. Okay, and the first thing you need to do is this command. I'll explain it. So just copy this, create a table, just go here and paste it, and add a semicolon at the end and hit enter. You have to add a semicolon, otherwise it will not work, and hit enter. Yeah, so this is the typical create table command in SQL. It says create a table and then the table name is transaction records or whatever name you want you can give, and within the brackets you are mentioning the schema of the data. So Hive supports simple and complex data types. So those who are aware of data types, so you have simple data types like integer, string and all. It also supports complex data types like maps, structs and all, right? So they are all supported. But here we are just starting with a very simple. So I am just saying even there is a date data type, and the important point here is not the schema. Schema I am mentioning. You even have a data type for date. I am not using it. I am saying string. But Hive supports date handling and all. So after that, the most important point here is row format delimited fields terminated by comma. What that means, Hive is expecting the data in row by row and the delimiter is comma, which means you can load only comma separated files ideally, right? I will tell you what will happen if I do something else. Let's say I am not using comma, what will happen? I will show you. But right now we are simply creating a table. There is a record reader for Hive. So that will read, no, we don't have to define, okay. So now this table is created, right? So all of you have created. Hive can be accessed through Hue. You have a Hue, right? That I'll show you that. There you have autocomplete mostly. But the hard way, if you are working with Hive, there is no autocomplete. You have to type everything manually. Now is the important thing. How do you load the data, right? And there are a lot of things I want to talk about loading the data. First of all, identify where is your data, right? So in my case, the data is in this location. So just make sure you understand the location of the data. In my case, this is the location. I'll just copy this and the data is txns1.txt and I will say load data local in path into table. So this is the command. The path I found here, I went to this location, I did a pwd. See, this is where I have the data, right? It is on Linux. It is on Linux. And it is very easy. If you make any mistake, it will say path cannot be found, it will not load. If there is a correct path, it will say loading the data, right? It's very easy to identify whether the command is correct or not. In my case, see, it says loading the data. So that means it is working fine for me. Are you also getting the same thing? So make sure it's a local path, okay? So people get confused. It is a local path. Yeah, because here we have not done the analysis, we just loaded the data. And here you can write SQL query. You don't have to, we'll be writing SQL query. You don't have to write the Java program and not at all. You don't have to know Java, jar file. It will create a jar file actually. If you mention a folder, it will load all the files in the folder. So just mention the exact file. He mentioned the folder name. So there were 2 files. It loaded everything. So here, since it is a data warehouse, it just appends 2 files. But from where to truncate, there will be another problem, right? Even I don't know. This should be the file size in bytes, I think. Roughly it is 4 MB, right? Should be 4 MB, the size of the file actually. Now this part is fine actually. I mean, you are just loading the data, and if you want to check, you can simply do a select star from txn records. You can do a limit 5. Can you try this? Do a select star from the table, do a limit 5. Don't simply run a select star. There is around 50,000 records, I think. So do a limit. I want to see the top 5 rows, right? So that's the command. This is to make sure the data is loaded. Now you can upload the data from local as well as Hadoop. So I'm just showing how to do this. I'll show you from Hadoop also. Both possible. No, select star means select everything from the table. I want to see the full table, right? Limit 5 means top 5 rows I want to see. Now, if you actually want to see the query, right, you can write any query, doesn't matter, but I can simply say select count star from. So this select count star is a query, and as you can see, the moment I run the query, it is firing a MapReduce job. See, so the query will fire a MapReduce job because it is converting it into and see map 0, reduce 0, and this cluster is really good. What I'm telling you is that we have around 10 nodes here in the cluster, and only I think around 20 people are using it. Very less data. That's why it is very fast. Actually, it is very slow. This is unexpected. If Hive is fast, there is some problem. You have to troubleshoot. So this means select star. Select star means show me the full table. Limit 5. I want to see the top 5 rows. You are just verifying the data is loaded. No, the top 5 rows. Because it has 50,000 rows. If I simply do select star, it will display 50,000. I don't want. I just want to see. No. Select will not fire a MapReduce job because it's a simple read. It doesn't need to do any calculation. So when you do a select star, it won't fire a MapReduce job. It will simply show you the output. So just let me know, are you able to do till this? You have to do a select count star. It should fire a MapReduce job, and you should see the output. One more thing I want you to do in that file I have given to you, right? This commands file. It might be slightly wrong. Not wrong. Don't copy paste. That's what I am saying that I'll write it here because I use it for a different session also. So there, if I open this, here it will say load data in path. See, it is saying load data in path. It is actually load data local in path, right? So don't follow the same thing, and you can correct it also. Whatever you are running here, just correct it there so that it is reflected, right? Otherwise, tomorrow you try and it may not work the way you expect. Because it's the MapReduce output. I mean, it is firing a MapReduce job, right? So MapReduce logs are just being displayed. That's what. You can suppress it. There is a way to suppress it, but normally if you submit a jar file, MapReduce, it displays the same thing, mapper, reducer. That's what. Finally, you will see the result also. It is a default nature actually in Hive, because even though it is a Hive query, it is not a Hive query. It's a MapReduce program. That's why it shows map, and this is good for troubleshooting. Sometimes it will show you errors and warnings and all when it is running. I'll show you how to enable column. But right now, you are doing a select star, right? If you want column names, set hive.cli.print.header equal to true. Okay, now if I do this is count star, right? It will call. Definitely, because it is some analysis, it has to call for it. Only the select star will not call because it is just reading the data. So are you able to load the data, at least run the basic query? Then that's okay. I mean, he is asking, can you see the Java code Hive is writing? No, I have not found it so far how to do that. No, that is internal to Hive. I mean, how it is converting that into a Java pro. Actually, we have all this in MapReduce. For example, how to write a join in MapReduce is there. A select statement doesn't, normal select star is simply showing, right? It doesn't convert to MapReduce. Where condition. Internally, there should be some logic again to, everything is key value pair, end of the day. Everything is, so another drawback is that Hive is good, but you will not know what is happening behind the scene. Like, end of the day, how the code is written, you will not know. You will see the result, but that's enough. If you know SQL, you can just fire the query, right? Hadoop into Hive, in Hadoop, to Hive and Hadoop, because it is in Hadoop and it is visible in Hive anyway. So that now the important point is, I don't actually want to show you running the query. That's so once you now you have this table and you can write all the SQL query. That is not my intention. The real question is, where is the data? First question, right? So you loaded the data and from local you said, that means from Linux. So First thing you have to understand is that data must be in Hadoop. So when you did a load data, it could have gone to Hadoop, that's for sure. But where in Hadoop, right? So to understand this, what you need to do, you have a describe command. So let's say describe and txn records. So this is a very common command. If you do a describe on the table name, it will show you the columns and data types and all. And if you want, you can also say describe formatted and the table name. So describe formatted will give you more details about your table that you created. And if I hit enter, there is a very interesting thing that you can see. The thing is, it says table type is managed table. So any table that you create in Hive, either it can be a managed table or something called external table. By default, everything is managed table. I'll tell you what you mean by managed table. Okay, but you can clearly say, see, it says it's a managed table. Point number one. Point number two, it displays something called location, right? It says location and it says user Hive warehouse. So I want you to do one thing. Just go to your Hive file browser. Can you go to this thing? If you go to this Hive, just go to this user folder. There is a folder called user. Can you go here? Oh, I think there are a lot of users actually. So n number of users are there. Okay. So do one thing, user / Hive. So if you simply type it here, user / Hive, you will land on this page. So what will happen is that when you install Hive, there is something called warehouse folder. Hive will ask you where to create it, and normally in all Hadoop clusters, it will be user Hive. Inside that, there will be a folder called warehouse. Okay, and if you open this folder, you can see all the DBs people have created, and you can open your DB. My database was May 19, so this is my database, May 19. Open that, and there is a folder called txn records. This is nothing but your table. You open this, you have the data. So try to find out your data by yourself. So my point is, what is going to happen whenever you are creating a DB in Hadoop, this folder is there, user Hive warehouse. Inside that, it will create a folder with your DB name. When you create a table, a folder with a table name. And when you say load the data, it is simply copying the data here. Are you able to reach this point? I mean, this place. You can also do something interesting. I can simply go here and delete the data. I deleted the data from here, right? And if I do a select star now, sorry, it fired the query because the table is there. It will say 0 because the data is not there, right? So let it run. Yeah, so or if I do a select star, there is nothing. So I did a select star from the table and there is no data because I deleted it from here, right? And you can manually copy the data here. If you don't want to type load data local in path, I can just copy this transaction here to this location. That is a schema, but you don't have a data. So now I manually uploaded the data here, and if I go back here, I should be able to see the table. So this is where your data goes if you are copying. If you are saying load data local in path, the data goes into this user Hive warehouse DB folder, table folder. That is where it dumps. Okay. So are you able to see this folder? I think yes. And now now I am going to confuse you. Okay. So if you understood this much, I am going to confuse you. So now what you did, you loaded the data from local file system. And I have one more data, right? So there is one more file called customer, right? I want to upload this from Hadoop. So what I'm going to do, you can also do along with me. I'll go to Hive, okay, and in my home folder, Raghu, okay, I'll just upload the data here. Step number 1. So where is the file, customer file? Copy that into Hadoop in your home folder, wherever you want. This is a bit confusing. I mean, so remember the location where you have copied that in Hadoop. Fine. Uploaded. And now I want to copy that into customer table. But first we have to create a customer table, right? We don't have a customer table. So I can go here and there is a command here, create table customer. See, find sales based on age group. Below that there is a command. Just copy this command. Come back here and just say paste it. And it should create a customer table. Fine. So now you can load the data from Linux. You already know how to do that, okay? But I don't want to do that. I want to load from Hadoop. How do I do it? I'll say load data in path. I don't say local, I say in path. I'll say Raghu / cusps into table customer. Try this. Only difference is that you are not using local. You say load data in path and give the Hadoop location. Now I want you to do one thing. Where did you upload your data in HDFS? This cust file. Can you check the data there? It will not be there. If you can see, there is a problem. It will move from there. Just see once. See, in my case, it was in Raghu. If I refresh here, it will be gone. Because the tables we are creating is called managed table. So when we did a describe, it showed it is a managed table. What is a managed table? A managed table is a table where Hive will manage your data. You don't have any control. So in Hadoop, it has already selected a location where it will dump all the file. So even though you say load the data from this Hadoop location, it will cut it from there and dump it into that. So you can go back to that user Hive warehouse folder. There your data will be there for sure. You don't have any control as to where the data will be. Hive will control it. Try whether you can see the data there. In user Hive warehouse, this location. No, never. It's just a projection. It's just a pointer. That's all. It's just a projection. The metadata will get updated. That's what is happening. Because when I say move from this folder to that folder, rather than moving that, name node will update the metadata. It will point from here to here. That's all it is happening. It is there. I mean, other place it will be gone. Where you have already uploaded, the data will be gone. This will not happen if you are loading from local. It will not delete from local. Okay. So that's a bit confusing, but that is how it works. I mean, people will think, hey, where is the data? What happened? Where was my file? Right? Because it is managing the data. So it will not allow you to keep the data. It has to be in the user Hive warehouse directly. So that's one thing, and that's called a managed table. What we are creating is called a managed table. And now ideally, if you have done everything correct, like I am doing, if you do a show tables, you should see 2 tables, and you should also have data in both the tables. Can you verify? Do show tables, and if you do a select star, you should have data in both the tables. Because then only you can do further any analysis what you want, right? Once you have the data. But here we can use SQL. You are not familiar with SQL, I guess. SQL is the most powerful language in the world for analysis. There is nothing which can beat SQL. Even though I don't know much of SQL, I'm not a SQL guy. So you might have to write complex queries, but end of the day, that is not the idea. You should know what's happening. Queries anybody can write. Maybe you don't know how, even I don't know how to write some queries. So I'll take help, or somebody will write the query. But if you fire a query, what is happening, where it is running, that is. I'll tell you a very interesting story. I have a friend of mine, he is working in Cape Gemini. So I went to train in Cape Gemini. So he was in my training team. He is my friend, he was also sitting in the class. I knew that, okay. So I was asking the participants, how many of you are using Hadoop or Hive, and most of them said no. They are all ETL guys. The point is, they were running Hortonworks, and Hortonworks has a tool called Hawk, H-A-W-Q, Hawk. Hawk is like Hive only, but with some modification. Like Hawk has become LLAP now, to be fair. Previously they used to call it as Hawk. Okay, so Hawk is actually a connection to Hive only, end of the day. So these people were using Hawk for past 2 years, but they didn't know that they were using Hadoop. Because for a SQL developer, it doesn't really matter. You write a SQL query, and do you really care where it is hitting or who is processing your query? You don't really care. Your idea is to run the query, right? Hawk as such is LLAP. So Hawk is an improvement on Hive, and now the project is discontinued. It has become that LLAP, real-time ACID queries on Hive. Previously it was known as Hawk. So I went like 3 years back. That time they were running Hawk, and they didn't know that it was Hadoop. So most of their queries were on Hadoop. But that's what I'm saying. If you are a SQL developer, mostly you don't really care where the query is running. You care where the query is actually running or not. There's a problem or there's a performance issue. That is what you look into. So that's what I'm saying. So I was asking them, do you actually use Hadoop? They said, no, we have never used Hadoop. They were actually running queries for 2 years almost. Okay, so once you have the data, what we want to do is, see, I want to do it in a different way. You can do it in many ways. First thing I'm going to do is that I'm going to create a table. So you can get the commands from here. It's called out1. So I'm creating a table called out1. If you look at the schema of this table, you will understand what I'm doing. It's a join table, meaning I want to do a join and I want to store the result in this, right? So usually you don't want to ideally push it into a table, but you can do it also. So I'm creating this empty table to store my join results. So I'll be doing a join operation, and this table will hold the result. And how do you do a join query? It's very, very simple. So if you know SQL, I think this will be very easy for you. You will do a insert overwrite statement, table, and it's a typical inner join, right? You will say a dot customer number, first name, age and profession, that is from one table. B dot amount and product, that's from another table. From customer A, join transaction records B. On the joining column is customer number. So for those who do not understand this, we are merging two tables. So this will produce a result, but we want to store it somewhere, right? So we created an empty table called out1. So there it will push it. So this is a typical syntax of a join. So that A means 1. From A here is customer table, B here is transaction records table. So from A table I want columns customer number, first name, age and profession. B I want amount and product. And whenever you want to do a join, there should be a common column. Then only join makes sense. So the common column here is customer number. This one is the common column, customer number. And this is called a simple inner join. You have outer joins, left outer, right outer, full outer, all this, everything will work. Now it is insert over, right? Now the table has no data. It will simply dump it. If you already had some data, it will delete everything and load it. You also have an append where you can simply append. Okay, for SQL guys, I have a question. Just I thought I'll bug you with questions. What do you mean by schema on write? sorry, schema on, right. Do you know what this is? If yes, what it is? Your RDBMS and typical systems are called schema on write, meaning if you create a table, let's say the table has 6 columns, if you try to insert 7 column data, what will happen? It will say violated. You cannot insert 7 columns to 6 column table. That is because it is called schema on write. It will validate the schema while you are writing the data. Hive is schema on read, not write, meaning I can create a Hive table and upload an MP3 file. It will properly upload, no complaints. I can upload a movie, properly uploaded, no complaints, because it will not validate what you are uploading, right? You will say load the data, it will simply copy that and dump it in the folder. But when you query the data, it will validate. There it will show an error saying that, okay, and why it is, because why Hive is schema on read is for faster uploads. Because otherwise if it is validating everything, it will take time to load the data. It's a data warehouse, right? I think most of the data warehouses are schema on read. I don't know much about other things, but Hive is definitely schema on read, right? So schema on write is typically on your traditional systems. So run your join query, see whether the join happens. It's faster. So Impala will be more faster, I think. If this is like this, now if Hive is faster, there is some problem actually. We have to troubleshoot. Ideally we do it. Select. So now verify the data actuals. You do a select star from out1 limit 5. So you should see the join output here, and as you can see, you are having these details from the customer data like Cameron 59 actor, and these details from the other table, right? Like the amount and the product, these things are from the transaction table, right? You should see the join result. So now you have joined the table. Join 2 tables actually. And now what I will do, logically speaking, what I will do is that I will use something called a case statement in SQL. So those who are aware, it's easy. For others, what is a case statement? Very simple. I will say that look at the age column, okay? If age is between 20 and 30, categorize the customer into something. 30, 40, do something. So because you want to group them, right? Then only you can sum the transactions. So in SQL, you can easily do that using something called a case statement. Okay, that's what I'm going to do. So, but to store the output, probably I'll create a table. I'm just creating intermediate tables. So create this table called out2. So this table is called out2, and if you look at the schema of this table, there is a last column called level. This column does not exist before because that is the place where the case will push the result, right? So that level column will have low, medium based on the age of the customer. I'll push the data there, okay? And how do you write a case statement? This is one way to do it. So I will say that select everything and I will open a case here. When age is less than 30, I will mark the customer low. Age is 30 to 50, middle. More than 50, old. Else, others. So this is how the classification will happen, and that will add to the last column of our table. Now by default, simple case tense, it will go to the last column only. If you are writing a simple case, it will have the last column added where the conditions will be added, whatever condition you are mentioning. So here I am just saying that only low, medium, high, right? Three categories I am mentioning. So see, this is the case statement, right? And Hive is full of SQL. I can't really help it. I mean, there is no other way to write in Hive, right? Without using SQL, I cannot write anything in Hive, right? So don't worry if you don't understand SQL, but get an idea like this is what will happen if I do it, because Hive is extensively used. I mean, most popular tool I can say. So that means we are in the last part. Now we have created this table called out2, and if I do a select star from out2 limit 5, see, now if you look at the last column, every customer is classified old, middle, right? And now we will do something called a group by query. We'll just group them based on low, middle, sum all this thing, and you will get the final output. This is just to show you how Hive is running, okay? No other and to do that I will create a table called out3, and I want you to tell me the query. Let's see how many of you can tell. So this is the third table I created, okay? Group by you know, this, what is that column? Level. Yeah, so I mean, I'm just asking. So what we are doing here is we are simply selecting the data, grouping it and counting it. And now the final table, if you do a select star, you will see the final result. Select star from out3. So now you can see low, middle, old and total amount spent. So who is spending more? Not low. I think this is bigger, right? Older. I think older people are spending more, actually. I don't know. Maybe, right? Huh? Based on what you are selling. Retail store, right? Sports items. Probably older people are actually selling, buying more these things. Now quite interestingly, if you don't want to open a shell and type all this stuff, you can go to Hue, there is a query editor and there is Hive. Same thing, but you can go to this Hive and in here you can select your DB. Yeah, so it is a default database. Go back. Oops, cancel. My database is May 17th, sorry, May 19th. So I am in May time, and here you can do the same thing. Select. So now it will do autocomplete and other kind of things a little bit, right? Just say play. See, it'll, if you just hit play, it'll do that. So this tool called Hue is very you know, useful actually, because that is one thing. Apart from that, let's say I take a query. So we have a table, right? Out2, right? Select star from out to, let's say, limit 50, something like this, right? And if I run this, the query runs and it gives you options to visualize. See, you can visualize the data. I mean, right, this is Hugh's property. No, in my knowledge, no. There is a website called gethue.com, but they are available on all the Cloudera. By default has Hue. If you buy Cloudera, you get Hue. Hortonworks doesn't have Hue. You have to separately install if you want. Hortonworks has this Ambari UI, which is very good. Ambari is their admin tool that has a file manager, same like this. You can click and upload the file. That's very good actually. Hue is third party in my knowledge. Ambari is from Apache. Hortonworks is just using it. Even on Apache Hadoop, you can install Ambari. So if you are having a plain Apache Hadoop, you want to administer it, you can install Ambari. But popularly on Hortonworks. Because nobody uses much of Apache Hadoop. You are either Hortonworks or Cloudera, right? Mapr has the worst UI. It's called Mapr Control Center. Worst. I mean, I'll show you the UI of Mapr. I had a Mapr cluster. I lost it. Mapr control system. I don't know, maybe they have improved. No, they have not improved. Mapr's UI is called Mapr control system, MCS. Okay. Yeah. This is how it looks like. See how weird. I mean, this is their, like Cloudera manager you see, this is their UI. Very dreadful fonts and you can't find anything in this. I mean, the worst UI ever created probably. I mean, comparing it to the Cloudera manager and all, Cloudera is way better. The UI, fonts, everything. This is Mapr's control system, their UI. Anyway, I wanted to discuss one more thing. So far we have done managed tables. I want to talk about external table, and that is again a bit confusing. Okay, we'll finish external tables and wind up probably. Okay, you had been through a tough session actually. So just do one thing. I want you to do one small thing. I want you to create a table. Okay, so I am copying the command from here and I want to change it. So just open one more notepad. Open, sorry, new, right? So this command is for creating the transactional table, regular command. I just want to change it. I will say create external table and I will say transaction records underscore ext. Okay, and then I will say location. I'll explain what I'm doing. Okay, first let me try this. Control C, my data. So I'll just copy this and see whether the command is working. Then you can also try. Yes, it works. So you want me to increase the font. Let me just increase font. Amount double is there, just only one thing. So what is the difference here? You are creating something called external table. First thing you can note down is that you say create external table. So there is a keyword called external you are using. Point number one. Point number two, after all the schema and all, I say location. In location, I say user, GL faculty, that's my home folder, my data. What is going to happen if you run this command? It will create a table, that's for sure. It will also create that folder for you, my data, in Hadoop. I don't have that folder, but it will create that folder for me. Let me show you. I'll tell you why it is required. If I go to my home directory, Where is it? Yeah, here it is, my data. Can you see? So this table is, this folder is created by my table creation command. I didn't create it. Okay. Now what is the idea of an external table? When you create an external table, you have the control as to where is the data. So right now there is a folder called my data, right? And all I need to do is open this folder, okay, and copy my transaction files here. Sorry. Just copy this file here. I'm just uploading the file. And if I say select star from txn records underscore ext limit file, I have the data. So the difference here is that, what is the difference between managed table and external table? In managed table, you don't have any control as to where is the data. You just say load the data and Hive will always keep it in user, Hive, warehouse, blah blah blah. In external table, you say I want a location where I will keep my data. So here I mentioned a folder and I can upload all my data here and that will appear in my table. More than this, so this is one example where we actually use external table, is that customer will say that they will have some data and we will ask where is your data. They will say my data is in S3, Amazon S3. You can simply say create an external table, point to Amazon S3 location. All the data will appear in the table. The data will be there. I'm saying you can see that in your table. So any external location you can keep your data and you can access in the table. That's called an external table. Try this if you want. Create an external table and upload the data, see whether you can find it. Because all the times you may not have control on the data. You cannot say that all the time I will copy the data to my place. Sometimes you might want to create a table and point the data, point your table to a folder. Actually, that is possible. From my local system, I uploaded to that folder. So once you upload the data to this folder, it will appear in the table, my data folder. The data has to be in this folder, then only you can see in the table, because you are saying the location is there. See, the business use case is different. I'll show you. I'll show you the business use case, okay? So what is going to happen is that, let's say you are having some DBs. So here I have an Oracle, okay, here I have some MySQL, etc., right? And what you do is that, so you have some databases, right? And you, let's say, run Scoop. You know what is Scoop, right? Scoop is your ETL tool. You say, hey Scoop, do one thing, connect with these DBs every day at 12 p.m., 12 a.m., midnight. So I can schedule a job every day midnight. What Scoop will do? Scoop will connect with these two DBs and it will run the ETL job. It will pull the data from here, and once Scoop gets the data, Scoop has to send it somewhere. So I have my Hadoop cluster here, right? There is my Hadoop cluster, right? What will do? Scoop will dump this data into a folder. So there is a folder called, I don't know, Raghu. So Scoop will keep on pushing the data to this folder called Raghu. Now I can create an external table, okay, and point that location to Raghu, right? So what will happen? When I do a select star, automatically the data that Scoop is dumping here will appear in my table. Are you able to understand what I'm saying? So typically in an ETL leg, what is happening is that every day you will be running ETL jobs to bring data from multiple places, and all this data will get dumped into some folder. Now somebody cannot go there and say load data local in path. Rather than doing that, you create an external table, point to that folder. So the moment the file lands, it is appearing in your table. Very simple. That is actual use case of external table. Yeah, Scoop cannot do scheduling, Uzi has to do. Now, if you are asking, Scoop can directly dump it into Hive tables also. It is possible. Scoop can take the data from Oracle, dump it into a Hive table. That's possible. But many jobs are there where you get data from multiple sources. Say your a Flume job. If you are running Flume agent, it may be collecting log files. All these log files will dump it into some folder. Now I can create a simple external table where I can use some serde to read the log, and I simply do select star, all the data will appear in my table. Otherwise I have to say load data local in path every time to dump it into this table, right? So the actual use of external table is that you can simply point to any folder and all the files will appear in your table. So Hive doesn't care what is inside that. You have to make sure that the schema matches everything. And some people ask this, what if I have a 20 column data in the folder and you have a 10 column Hive table? The first 10 columns will come. It will truncate from there, ideally, okay, because it just fits wherever it is possible and then it will remove it. So all the files will be appended in the table and shown, like 5 files. Wherever your records it cannot match or cannot understand, will say null values, I don't know what it is, or data types mismatch. Only 5 columns will come. It will try to fit, but there is no guarantee, right? So ideally that is not a use case, because in a data warehouse you are not supposed to do it actually. You are not supposed to experiment in a data warehouse. The data should be clean. That is why you have this cleaning, pre-processing, data factory operations and all, right? Then only you take the data to a data warehouse finally. And another important point about external table is this. So if I do a show tables now, I have this table called transaction records, and this is a managed table. This is my original table. I say drop table txn records. I drop the managed table. Can you tell me what will happen to the data? Will it retain the data or data will be gone? Data will be gone. Sure. No. Data will retain. Data will remain. Okay, I am just asking. So I just dropped a managed table. You know what is a managed table? I am asking, table is gone for sure. The file I manually uploaded, right? Will it be there? Yes, no. 50-50. We'll check. User, where is it? Hive, warehouse, May 19. Do you see a folder called transaction records? The data is gone. So managed table has this drawback. I won't call it as a drawback. So this is very common. It happened once in a project where I was working, and that is how I came to know. I mean, normally when you work, you don't learn these things. You learn by mistake, somebody does. So we had a table, very huge table, which was shared among our project. 2-3 projects were sharing this table, and they had full rights that point in time. One of the engineer, he said drop the table, and then it's gone. So he said drop the table accidentally. He didn't intentionally do it, but the problem is the table is gone. But they had some recovery mechanism at that point in time in Hadoop. In Hive there is no way to recover. So, but ultimately it's a delete from Hadoop. So they had some recovery trash mechanism, recycle mechanism, and based on that they recovered somehow. Okay, that is why when you create a table which you want to share, always create an external table, drop table. I can just use the up arrow, right? What is the table name? Transaction records underscore ext. So I am dropping the external table. Table is gone, and I will go to user. I can just go to home folder, right? I'll go here, and we had a folder called, what was the folder? My data. The data remains. Because Hive does not have any control on your external data. You have control. You upload it. It will not delete. So this is easy. You can recreate the table. Data will not be lost, right? So if you want to share the data, expose the table, always create external tables. Managed tables are very rare actually. For learning purpose, we say it's easy to do managed table. And in the operation side, they are all the same. The queries and everything is same, managed table. There is no difference. But always remember, create external tables if you want to share this. Okay. This PPT has more data. I request you to go through that. Also, the official website of Hive, very, very important, hive.apache.org. And it has tons of information. Okay, like I don't know how much it has, lot of things actually. You can start with getting started guide on Hive to understand what is Hive. Yeah. I forgot how to connect using Beeline. So I'll show you tomorrow how to run Beeline, because I just want to see. By default, Hive server 2 runs in port number 10,000. So when you're starting Beeline, you have to say JDBC connect to 10,000 port number, and then it will connect with the Hive server 2. I will show you how to do that tomorrow anyway. I forgot. So please go through this Hive official website. It has tons and tons of information. Lot of things are there. There is a Hive wiki page which we just saw, right? And just look at these points we already discussed. Query execution via Apache Thais, Apache Spark or MapReduce. Oh, probably last bit I can show you Thais, but I forgot my username and password. It is not here, right? I'll show you tomorrow Thais. Anyway, query execution via Thais, MapReduce or Spark. Hive can use Spark as an execution engine, but people don't prefer it because from Spark they fire queries the other way. That's more easy. You can start Spark SQL and say fire it, but Hive can actually use Spark as an execution engine. It is possible, right? And this is sub-second query retrieval via Hive LLAP. Only Hortonworks, LLAP. This is what I was talking about, LLAP. LLAP enables ACID transactions, faster queries, everything that you can think about a normal RDBMS. I mean, within few. But that again requires resources. I mean, even though it says very fast, it will take a lot of resources actually. So when you are running Thais itself is in memory. So anything which is in memory requires resources. In memory means RAM. It will use only RAM. So Thais itself is fast because of in memory. So your cluster needs to have a lot of RAM for LLAP and all. Otherwise, it will be very slow. Procedure. So that is HPL, SQL is nothing. That is a combination. That's called Hive query language, HQL only. You can write your own custom functions and all inside Hive. Hive supports something called UDF, user defined function. You can write. So that is, they say it as HPL SQL, as a fancy way of saying that only, right? I would feel vice versa. In the sense, yeah, see, if you are good in Java, MapReduce is your choice, but MapReduce is extinct, right? Then you go to Spark. Spark uses Java, but that is Java 8, functional Java, not Java 7. So a lot of people have trouble there. But even in Spark community, the most trusted, preferred is Python and Scala. Then only Java comes. So Java is supported in Spark 100%, but developers are very less. People want either Python or Scala because it's easy to write actually, right? I would say some knowledge on SQL is, or Hive is very important, whatever you are doing, right? I will tell you this in Spark. In Spark, if you write your code using Python and SQL, the SQL is much more optimized, because if I am writing anything using SQL, I have something called schema, right? Which means I can understand my data. What is schema? If I have schema, I can understand my data. So if I write a join and filter, I can push the filter first, then do a join. Are you able to understand? In SQL, I write a query. By default, it does, right? By default in SQL, if you write a group by, join, then filter, what will happen? Filter will come first. Because why should you load all the data, then finally you do a filter? First you filter, then do it. That's called optimization. That is not possible if you write a language. In Spark, we will see when we write Spark code, it is not optimized because Spark is not having a very tight schema. But Spark SQL has. So that's what I'm saying. SQL always has a preference because of its optimization. That is not possible in other languages. Like even in MapReduce you write, you have no idea how is the data underlying, right? You are not mentioning any schema. It has to load the full data to do analysis. Any MapReduce program you write, the whole file need to be loaded. You cannot say that select only this column and analyze. Not possible, right? First everything has to be loaded. So always the structured languages are having a preference on this. Java is good. I am not saying Java is bad, but I won't consider it in the further. Scala, probably you can relate with Scala. Scala is very similar to Java. If you know Java, Scala you can very easily learn. Scala with Spark is a good combination. Very good combination. What else you have? Questions? We'll wind up in 5 minutes after your questions. So tomorrow I'll be covering something called partitioning, bucketing, indexing in Hive, which are a bit advanced topics actually, okay, but very much needed actually to understand what is Hive, because they are the highlights of Hive. If somebody want to learn Hive, these are the points, or if somebody asks you about Hive, these are what they ask. Nobody will ask how do you do a select star query, right? That nobody is going to ask. They will ask how do you partition your data. So at least if you can understand the logic of it, that will be more than sufficient, right? And we will look at this NASA data. You have a NASA data, see, NASA. So tomorrow we will analyze NASA data using Hive. So I can show you the SERDI there, regex and SERDIs and all I can explain in this NASA data. So make sure these data sets are there with you. Anything else? Let me know. If you look at this case study that we have prepared. So this is about the NASA data, analyzing the NASA web server logs with Apache Hive. And this will be helpful because we will see the same data in Spark. In the Spark class also this data will be there, same data. So if you understand the data now, we can analyze it using Spark as well. So I guess you are aware of this. Server logs contain lots of information from web servers, right? And this case study will show you how to derive insights from web server logs. So you are going to look at some log files which are generated by web server, and if you have ever worked with web servers, so let's say you type google.com and then download something, all these requests will be hitting the web server. So you will get request, put request, then HTTP status code. So that is how your log files will look like. Okay, I will show you the log file, and you can actually download the data for free from this URL. We have already downloaded and uploaded the data. You don't have to worry, but you can, it's public data from NASA. And if I scroll down, look at here. Before moving to the activity, please go through the HTTP response codes at this link, right? So are you aware of something called HTTP response codes? Yeah. If not, you can just go through this URL. So for every request there will be a code associated, right? So if you are browsing and hitting a web server, the server will respond with a code. So if it is 200, it is okay. Anything starting with 2 is success. 201 is created, 202 is accepted, 204 is no content and all. 30 is redirection. That website will redirect you to some other place, right? And client errors are 400 and 500 is server error. So sometimes you try to open a website and you will say 501 server not found or like that. So anything starting with 5 is internal server error, right? So gateway timeout, service unavailable, something like that you can see. So if you want, you can just go through this list, right? And understanding the data. So the data set contains 2 months worth of all HTTP requests to the NASA Kennedy Space Center server in Florida. So this data is collected from the NASA web server, and 2 months worth all the requests are there, and I think around 1 million lines are there in the data. It's pretty huge data actually, somewhere around 1 million lines. The log files are stored in the Apache common log format. So that's what a lot of people ask me, when you say text file, it is not with a .txt extension. Normally you say text file, that is something with .txt, but there are a lot of other data which is called text file. It is always not mandatory that you will have a .txt extension, right? So this Apache common log format, it is a text file, but you cannot open it in Notepad, right? You can open it in WordPad or any other thing, and it will show you properly like text data. I'll show you the data, and now let's look at the data. So if I go here, there is NASA access logs, and this is the data. I'll say open with, I'll say WordPad, say OK. So this is how the data looks like, and it's not really pretty. I mean, in the sense like it's not really nice, it's not structured. And what are the fields we are interested in this, right? So this is a log file, and if you look at here, the PDF, right? We have the host, identity, user identity, time, request, status, size. If I scroll down, the first field is the host making the request. Okay, so where is the host making the request? This is the host, this guy, in24.inet something. So this is the fully qualified domain name or the host name, host making the request. Then what we have, next two are the user identity from remote and local machine. These are unavailable. So next two fields are not used, they are dashes, that's fine. And then we have the timestamp in day, month, hour, so year, this format. So here you can see this. So this is your timestamp, right? The time when it is making the request. Time zone. So this is this -400 is your time zone. What you see here is the time zone. Okay. And then there is the request sent to the server. So here you can see get, it's a get request. Okay. And somebody is trying to get shuttle mission status news, some news, something. Okay. So that's a get request we have. And then there is an HTTP reply code. HTTP reply code is 200. It's a success. Okay. And then you have the size of the file received. So probably in bytes 1839. So this is the data. So you can see that a lot of people are sending requests to the NASA web server, and that's how the data looks like. Now what we want to do, we want to create a Hive table to load this data, and then we want to write some queries. And the size of this file is 167 megabytes. So it's a big file actually, not very small. And we will test now how the cluster will behave, because if you start writing the query, all of us write the query, we'll see how efficient the cluster is anyway, right? And so the next question is that how do I actually load this data into Hive, because this data does not have any structure. To do that, we are using the SERD or the serializer, deserializer. Now a little bit information to you. I also want you to give you an assignment. So if you simply go to Hive and say SERD, yeah, you can see here. This is called a SERD. So what is a SERD? SERD is a short for serializer, deserializer. Like I said, if you are having data which is not really structured, like this log file or JSON files or anything, you want to read and write, you can use this parser called SERD, right? And Hive supports a lot of built-in SERDs. So these are the built-in SERDs we have, and we are going to use this guy, regex. You are aware of regex? Regular expression, right? So that means you can write a regular expression. Hive will parse it, and using this SERD it will read it. There is an ORC, SERD, Avro, these things we'll look at later. And then custom SERDs. You can write your own SERDs if you want, that's also possible, right? We will look at this later. Let's open this regex SERD. Yeah, so it says if you want to create a table and use the SERD, you have to say row format SERD. Remember previously we used to say row format delimited fields. Now I say row format SERD, and then I will say this is the SERD. Okay, and then you say with SERD properties, and you will say input regular expression. Whatever regular expression you have to put there, and that should actually be able to get the data, whatever regex you are writing, and then it should give the structure to the data. This is the idea, right? And this is very important, stored as text file. I think yesterday I didn't discuss it. When you create a Hive table, by default this option is there called stored as text file, which means whatever data you are loading into the Hive table, it will store it as a text file, regular text file, be it a CSV file or any file. So yesterday we loaded some customer data, transaction data, and they were getting loaded as it is. Okay. Now you have other options. You can say stored as ORC, Parquet and all. That is where the improvement comes, and I will talk about it. What is the difference in when you say text file or when you say ORC file? Where is the difference? But as of now we will say it is stored as text file. We are not bothered. It is by default text file. So that is why yesterday we were not mentioning it. It is by default text file. Now the data set is available in this location. Can you see here? /GL data and one moment, what was the name? Access, right? Yeah, so this is the file. It's called access. There is no extension, and it is available in a common folder called GL data. So first let's do one thing. Let's start Hive. Anyway, we need to start Hive. So start Hive. And let's create a table. So we will use the DB yesterday we created. I'll say use May 19, that was the DB, right? So you can switch to whichever DB you created. And this is the command to create the table. You can copy paste this from the PDF. Okay, say copy, and I'll explain what it is. So you will say create a table, if not exist, NASA log, and the fields we are interested are host, identity, user identity, time, request, status, size, and then you will say row format SERD. We want to use the regex SERD. With SERD properties, you can input the regular expression. So this is the regular expression we are using, and in the output we will just say that. So that's part of SERD. You will say that store it with equal spaces, right? And then you say stored as text file. So this is where you're saying that store it as text file. So this is your regular expression. You can go to the PDF, and if you cannot copy like this, right click, say select tool. There is a select tool. Once you select it, you can left click and copy like this. So you have to have some idea about regular expressions if you want to write it from scratch, but that's okay. Yeah, sure. I'll show you from console. Yeah, this is the command. I just said Hive, then use the database, and then just copy pasted the table creation command. Right now we have not loaded the data. You don't have to load the data. That output format string, it is simply saying that there are 8 columns, right, and with space, each column with space. It's a bit difficult to explain. It actually reads and separates all the data with how many spaces you have, and it is looking at digits and strings and then extracting the interesting fields. It's a bit difficult to explain the regex actually. So if you are writing a regex from scratch, you have to validate it. So this was validated. Even I don't remember how I validated. I wrote it long back actually. Yeah, so it's a create table. Yeah, normal table. Only difference here is that in the table properties, you are saying that whatever data that comes to this table, apply the SERD, the regular expression. Otherwise, it cannot recognize the data inside, right? So right now this is the Apache common log format, right? And Apache common log format has a fixed schema, not schema, the way the log files are generated. So you can write it in multiple ways. This is one way of writing it. So in Hive, if you look, they will simply say that this is the regex we want. Here I'll show you. So here it is a input regex. See, the output regex is not stored. So here you can see the input regex, right? Are you looking here? I mean, this was written like if you avoid the output string also it will work. But we are just ensuring that everything looks string. I mean, just we are manually saying that it is string, that's all. I think it is not updated. Hive's documentation is not updated. No, it is not updated. Let me see. So where is it? More about regex SERD can be found here. So they have given 2 links actually. Probably it is here. Let me just check. So what happens is, let me just see if I can find it first. See, in open source communities, what happens is that, let's say you are looking at Hive or Spark or anything, somebody will create the product. So let's say I created Hive and I will give it to everybody. Everybody will start working, and then what will happen? Somebody will say that something is broken. So I may not add it in my documentation. I'll add it in a Jira. Jira is your issue tracking, right? It's a Jira link. In Jira link, it clearly says that there is input regex and output format string you should use. So somebody added yes, I will work on adding a SERD how to and some examples in new directory. So somebody said that this is not properly formatted. So in the Jira it is added actually. It is not an official documentation. Originally when they created, probably that property is not there. I'm saying then somebody could have complained, but they have mentioned the link here, right? You can see that it is here. If you look at here, it says more about can be found here. I don't know why they are not updating the documentation, but it is there anyway. So one problem is this: if you want to search documentation, you may not find everything in the official documentation sometimes. So I always look at Jira, because any issues they fix will be in Jira. And also not everything, not every time things will not work the way you are expecting. So you have to Google saying that Hive plus Jira not able to read this file, some issue you are coming across, and there will be a Jira ticket for that always, right? So once now you have to load the data. So let's continue with that. And where is the location? The location is here, GL data, right? So how do you load? You say load data. Wait. If I do a load data in path, what will happen? I say load data in path, what is going to happen? We can create an external table, right? That's better. I didn't think about it, because normally the participants will have the data in other classes and they will upload themselves. So what do you want? You want to create an external table, everybody, and point to the data. That will do. Okay, so then you have to modify this. So how do you modify this? If you want an external table, you will say create external table. Let's drop the original table, okay? Do a drop. First do a drop. Drop table. What is the name? NASA log. So drop it. And now we say create external table, NASA log. These are all fine. And the only difference is location / GL data. Wait. External table, if you are creating, it should point to a folder. This will load everything from GL data. We don't want that, right? In GL data, you have lot of folders, right? So I will move it. I'll see if I can create a folder in GL data. Let's see. New directory. I call it as NASA. Yeah, and I'll move it inside here, right? That should make sense. See, you have to take care of everything. Not this, right? This one, right? Access, action, move to GL data, NASA, right? There is no NASA folder. Yeah, there is. Move. Fine. So ideally, now if I check NASA, it should be here. Now it should work. Otherwise, it will load every file from the GL data folder. We don't want that, right? So what should be your location? This should be the location, right? And let me see if it works. No, you can use small letter or capital letter. So the table creation will work, I know that. My question is, what about the query? Select star from works. So you have to try this and let me know. It works. But all of us are accessing the same data, okay? All of us are in the same data. So make sure you can see properly structured. Now I already created a table first, right? And I dropped it because how do you load data to that table? We have a shared location. So it is better to create an external table to point there. So I dropped it and recreated the table. So here it is location. And also here is a location. This also should be there. This external you can type small letter or capital letter. Folder name should be case sensitive, I think. And do a select star and let me know whether you are able to see the data. So there are two approaches. Not every data can be made structured also. There is one problem. So Hive is a structured tool. That means somehow you should give structure, then only it will work. There are some type of data, like for example, there is a format called Avro, AVRO. So previously when you get Avro data, because that's like unstructured, you are not able to do anything. But now there is an Avro reader they have created. So there are still some type of data where you cannot give a structure. One point. Second point, how this works in organizations is that, like I said, there will be a data ingestion team, right? So I'm just giving you the example of GE. In GE what happens, see, GE's business is so enormous that nobody has any clue what is happening there. GE is one of the biggest firms in the world actually, right? And their size of data is enormous, what they are getting. So they have financial applications, okay? These financial applications will generate data, okay? And how do you get the data? They will have APIs. They will pull the data in JSON format. So it comes in JSON format. And sensor data they get, sensor data. So they have this locomotive engines, train engines in Europe, GE has created. So these train engines, whenever they are running, will produce sensor data. They collect it and that data will come through Kafka. It will come in a Avro format through Kafka to Hadoop. Ultimately land on Hadoop, but the data is sensor data. So it's like events. Sensor data will come in events format. Like whenever there is an event, it will generate a data. It's text file only, but the format that they get is called Avro. So the point is that data, when it lands on Hadoop, nobody can give any structure to that data. Nobody on earth can give. So GE has a data ingestion team. Their job is to take the data, give some structure and give to the big data team. You're getting my point, right? Because if you directly give it to big data team, they have no clue what to do with the data. So there will be a staging area where all this data lands, okay? And they had written some Java code, custom Java code. What that Java code will do, it will read the arrow, remove some unwanted fields, give some structure, send it to next side. So that is how they are injecting the data, I am saying. So raw data, most of the times you may not be able to directly handle it. And second use case is, if you are a big data developer or like us, we don't want data in the original format. But if you are a machine learning guy, you want the data in original format. Are you getting the difference? Like if I am a data scientist, I don't want anybody to touch my data. I want the original data with all the nonsense. Then only I can build my machine learning models, because they want all the features. They don't want to modify the data. But if I am a big data guy like this, I am happy with structure. I can lose some data. I just need the structured format. I will work. So these two teams will be there. So the machine learning teams will be original data they will be collecting, and then they will have their own algorithms to crunch the data. Kafka is used because their data is coming from Europe. Streaming data. They don't stream live, they stream once in a day or something. I mean, they collect all the sensor data. It's in Amazon. The entire setup is in Amazon. So there is some sensor which in Amazon you have a solution, right? Who is working on Amazon? Sensor data, you have a solution in Amazon. What do you call it? Kinesis, right? Kinesis is your sensor platform in Amazon. So Kinesis will collect all this data, and from Kinesis it will push to Kafka. Because somewhere it has to store, right, the data. There are very less real-time decisions they want to do on that data, because there is trained data. And only time when they are analyzing that data is if the train is not working, like it crashed. The train engine got crashed. Otherwise, they don't want to analyze it in real time. 99% of the time the trains are running. So this data is useless for them. So when the train engine got crashed or something happened, that time they want to look at the data last 24 hours. What caused the crash? So they are not doing, because the size of the data is in petabytes. So analyzing it is also not possible for them. So they collect it real time and batch it and send it once in a day or something. And it will go through Amazon, it will land in Kafka. Why Kafka? Because from Kafka 2-3 teams will collect it. One team is using the data for something else, distribute it, and then one copy will be stored in Hadoop, like original data copy. Anybody want, they can get it. That is how their architecture is right now. GE's is an evolving architecture. They are just moving to Hadoop now. It's not a stable architecture. So probably after a couple of years they'll find another way to better this things and all. Right now they are not doing real time on the this train data. They also have flight data. This aircraft engines are all GE, right? Commercial aircraft, all are GE, 80%. And all these engines generate same sensor data, they collect it. But again, that's all not real time. It's very rare you get a problem, and that time only they want to analyze. So I hope you are able to reach here, right, till this point. So this is the place where your data is there, right? If you go to this location, I have copied the data there. Now if you look at the PDF, what it says, load the data, select star. Now these are some of the use cases I wrote. I mean, you can also write your own use cases. So find the top endpoints that received server side error, meaning which are the how many endpoints have received server side error, right? I'm just asking, like, there is 501, 500, these are all server side error, and how many times it has occurred. So how do you figure it out? There are multiple ways to do it, but one of the ways is this. You can say select status count of requests from the what you say NASA log table, group by status, and you can say having status regular expression extract. So here I am saying that anything starting with 50 in the status column, because 50 is server side error. Order by status descending limit 5. So that's the query. So I just want to know all the errors starting with 50 and count them, how many are there. Right? That's what I'm writing. Now when you are using having, it has to be double operator assignment. In having clause, in Hive, when you are using having clause, it has to be assignment something. If you say equal to something, it will become a equal to 1, it will become a become 1. So here I am just saying, just comparing, that comparison operator is double equal. No, in having only I am saying. Where clause and all, it will be normal. In having you will say, so somewhere there was a documentation on this, I will share it with you. Okay. Can you try this query and see, now it is taking time, 24 seconds only for the first. Anyway, this will take some time. Can you guys try the query? It will be slow. So when you mention the commands, it has to be either full small letters or full capital letters. He said capital L location, and it's a bug. I know this because otherwise it should throw an error. It won't throw an error, and this is a very common thing. If you create external tables, you mention location, even if that location does not exist, it may not throw error. And you will try querying, nothing will come up, you will think what is the problem. Now space is fine, but ideally this location keyword, sometimes it has a problem. So that is what I did, it started working, but you are getting. Or maybe that itself is not a problem, I dropped it and recreated, probably it started working, not sure. So how much time it is taking for you to run the query? 75 seconds. There is also one more point which I forgot. Yeah, so anyway, so somebody was asking about this reference on regular expression. Here you have a Hive language manual, it is in the PDF. And which resource is requested most frequently by the host? This is a good question, right? Because which page is requested the most? And I don't think it's a very difficult query, but still we'll run it just to see. So now if you look at here, it says select request comma count as request count from NASA log, group by request, order by descending limit 30. You are looking at the top 30 requests actually, right? You can skip header and all, but I don't think you can skip the data part. I don't think you can skip columns, no. I don't think you can filter, because ultimately it's on Hadoop. So the data remains on Hadoop, right? So that's one problem, because if it is an HDFS, then there is no way you can filter anyway. Locally I have to see whether he is asking, while loading the data, can I filter the data? Like I don't want all the 10 columns, I want only, you have skip header, that option is there, table properties. By the way, there is something called table properties. If you just go to Google, say Hive create table PBL properties. So in creation of the table, there is something called table properties. Where is it? So table properties, right? So here you can mention the skip header and all. Let me just check. no auto compaction, mapper memory, auto purge, external true. You have skip header is there, that's for sure. But I don't think you can skip other columns. That is not possible, I think. Anyway, I will just see if I can get back to you on that. Okay. And there are some more queries I have written. You can try that, like display the top 10 hosts who made maximum request and all. You can try that. Find the total count of different response codes returned by the server. So just try these queries. Let me know if they are not working. I have not actually tried everything. It should work. Okay. So now talking about Impala a little bit, right? Probably not in depth, but you should know a little bit of Impala because it is heavily used in industry. Impala. If it is in the Cloudera side, we are on Cloudera side. If it is Hortonworks side, everything is Hive, but in the Cloudera side, we have something called Impala, right? So a small intro, not much, but and I will show you an Impala query also. So what is going to happen? If you are having data nodes, right? So this is a data node, this is another one, and this is another one. You can install something called Impala, right? And if you are using a Cloudera distribution, Impala will be by default installed. You don't have to worry. And Impala is its own SQL engine. It does not depend on Hive or anything, right? So when you install Impala, what will happen? There is a daemon called Impala D. Impala D. It's called Impala daemon. It will start running on every data node. Like something like Oracle. I mean, I'm just saying, right? So this Impala D will be running on all the nodes, first of all, right? And Impala has a shell from where you can fire the query. It does not depend on Hive. And if you fire a query, what is going to happen is that, let's say it hits this machine. So the query will be accepted by one of the machine. So let's say this guy, right? And this guy will look at the query. Now Impala can talk to Hive's metastore, which means whatever tables you are creating in Hive, Impala can see. So all the tables you create, you can query using Impala. So, and whatever tables you create in Impala, Hive can also see because they share the same metastore. So that is one advantage. So, and on top of that, another thing is that when you write a Hive query, it will convert that into MapReduce. So Hive is not bothered about how the query is running because it is the responsibility of MapReduce to run the query. Impala will not convert to MapReduce. Impala has this Impala daemon which will run the query for you. It is like a RDBMS, I can say, not an RDBMS. I am saying, like if you are firing a Oracle query, who will run the query? Oracle will run the query. Same like that, if I fire the query, this Impala will get the query, and it is the responsibility of this Impala daemons to execute the query. So they will have the Hive metadata, okay. They will also have the block metadata, meaning if you create an Impala table like a Hive table and you say load the data, right? Now the data is actually in Hadoop and the data is in blocks and replicas. Now who has the metadata about this? Name node. These guys will copy that to themselves because they should know where is the data. Impala is not going to depend on anything to fire the query, it will run itself, right? So that is why the queries are very fast, and when the query hits Impala, it runs in memory. So there is a drawback. So let's say the data was here, you have a block here, you have a block here. What will happen? You will have RAM, this block data will come here and this block data will come here, RAM, and this guy will simply coordinate the query because the data is here and here, right? So this guy will coordinate the query and it will run the query in memory. The drawback is, if let's say this machine crashes, the entire query will be aborted. It is not fault tolerant. But Hive queries are fault tolerant because MapReduce is fault tolerant. There is no way MapReduce can fail, right? But Impala queries are not fault tolerant. So if the one of the machine, because it is a distributed query, not one machine is running the query, probably 10 machines are running the query, and if any one of the machine crashes, the query will be aborted. But it will not convert to MapReduce or do anything, so your queries are super fast actually. Directly hit HDFS, query the data and give you the output, whatever you want. So it's faster, but this reliability issue is there with Impala. So what we do, if you are having a Cloudera cluster, if you are having ETL jobs, we never use Impala, because in ETL jobs, behind the scenes it will be running Hive query, and probably the query will take 3 hours to run, 4 hours to run, probably 5 hours. That's fine. Even if during that ETL job a machine crashes, I'm safe because it's a Hive query, my MapReduce will take care of it. But if I run that ETL query using Impala, let's say the query will be faster, 2 hours probably it will take, but after 1 hour if one of the machine crashes, my Impala has to restart the whole query. It will throw error, but again your ETL job has to start from beginning. You lost 1 hour, right? So actually it needs Hive's metastore. For the metadata, Impala must use Hive's metastore. So Hive should be installed. So that is another advantage. Hive will remain because lot of tools requires Hive, even Spark SQL. Spark SQL, normally when you configure Spark, you will tell Spark SQL use Hive's metastore, so that Hive's metastore is used by everybody. So all the tables you create, all will be in one place, right? And if the table is there, you can either query using Hive, query using Impala, that's up to you to decide. But Impala also has some drawbacks. This NASA table we created, you can't query using Impala. This regex is not supported. So this table is created using regex srd, that is only for Hive. I can see this table in Impala, but I won't be able to query, I think, if my memory serves me well. But most of the regular tables you can query without any problem. Both of them can access at the same time because metastore is a shared place. What is metastore? It is your MySQL. It's a shared place. Anybody can access. Not only Hive and Impala, hundreds of other people access. It need not run. You have to install Hive and set up a metastore. I am saying whatever table you create in Impala, it stores in Hive's metastore. So each data node will have an Impala daemon, and each daemon will have a copy of Hive's metastore block data. So, and what happens if you fire a query, any daemon can pick it up. That's called a coordinator. Meaning, if I write a Impala query, there are hundreds of data nodes. So any data node running Impala can get the query, and that node is called a coordinator for that query. So in this example, this is the coordinator because this guy accepted the query. But this does not have the data, that's fine, okay? And once it gets the query, it does a local lookup. So it's very fast. It has the metadata, it understands immediately here is the data, here is the data. It just splits the query and streams to here and here. These guys run the query, collect the result, display to you. So ideally, a lot of machines will be there where you are having data, but the metadata lookup is very, very fast. There is no frequency, you have to manually refresh it. It will not automatically copy, meaning if I create a Hive table, it will not appear in Impala. I have to refresh the metadata. There is an option in Impala where you can say refresh. So if you feel that there is some new table, you say refresh, then only the metadata will come. Block metadata, so that will come once your table metadata is created. Say I am creating a table. Once I create a table, I load the data. Then only the metadata of that data will come. It will not store the whole Hadoop metadata. Your Hadoop cluster has, let's say, 1000 terabyte file. Okay, Impala will not store 1000 terabyte metadata. That is useless, right? You are saying this Hadoop cluster has, let's say, 1000 files. Okay, in which you created an Impala table. Okay, you say Impala table. You loaded file 1, it will have the metadata of only this file. Why should it need all the metadata? The query will hit only this file, right? Only related to that table I am saying. When you create a table, you will say load the data. What data? So in our example, we loaded the NASA data. So the block information of that NASA file it will remember. From Hive, or if you are directly loading into it, it will remember itself. It won't remember the block information of other files. In Hadoop you have a lot of files, right? Not all the files are in table. Are you getting my point what I am saying? It will remember only the metadata of the files associated with the table. Otherwise, why it should remember all the files? Manual refreshment is required. I mean, block it may remember. I am saying the table properties, it will not automatically refresh. So you have to manually refresh every time. So usually we won't do like that. Usually, even though Impala and Hive can communicate, we don't do it. Because Hive has its functionality, Impala has its functionality. Meaning, whatever tables you have in Hive normally, they will be used for reliability like ETL jobs and all, and that Hive will handle. Impala will, you will create separate tables, you will say do the same thing, load data, local in path, blah blah blah, and that will be handled by Impala only, like separate tables. They can talk to each other, but what I am saying, if you want up to date information, you should say refresh, then only you can get it. And there are 2-3 types of refresh, I don't remember completely. There is a complete refresh which will redo and load the total metadata from Hive's metastore, blocks, everything. There is a partial refresh. You can do it in Hive. So these things are available in Hive. I am not just saying that. I mean, you will be wondering. So if you go to query editors, you can see Impala, right? So here is Impala. So probably the table you created right now should come in Impala. That's the logic, right? So if you go back, where is the May 17, May 19? This is my table, my DB, right? See, customer, NASA log, these are in Impala. And if I do a select star from NASA log, I don't think you can see it. I doubt. 5, I doubt you will be able to see it. Maybe, I don't remember exactly. No. Failed to load metadata. Failed to load metadata, invalid storage description. Impala does not support this table type. Reason, SERD library not supported. It won't support that SERD. That's why you are not able to see that. No, it won't. That's what I'm saying. Impala tables, if Impala is querying your data, it's not fault tolerant. So what the ETL will do, it will query and get the data. Who will query? That's the question. If Hive is querying, it is fault tolerant. So here you can see the NASA log thing is not supported, but if I look at any other table, so let's say select count star from, let's say out 1, right? If I do this, ideally it should work. For some reason Impala is a bit slow in this, Hive is faster in this case. It is not really like this actually, it's very fast. There is no MapReduce, it directly hits and gives a result. If the same query if you run, you will see MapReduce job starting, MapReduce, nothing. So we will, and there is one more thing, this refresh manually has to do, normally we do it manually. You can write a batch job to refresh. So I don't know whether the refresh is actually configured here or not for the Impala, because this NASA log table is available. We just created it right now, but it is available in Impala. So probably, and this is the option to refresh. Can you see this refresh? 3 options will come: clear cache, perform incremental metadata update. This will sync missing tables in Hive, which means if you have a new table in Hive that is not here, it will do it. And then there is invalidate all metadata and rebuild it. This can be both resource and time intensive. When you say invalidate, it will delete the whole metadata and from scratch it will build. That will take a lot of time. So these are the refresh options in Impala that you have. So try to create a table, see whether you can find it in Impala. I don't know. So we'll create some simple table, right? Which table you want to create? Maybe I'll just change this and run it as it is, right? So I just created, and if I go to Impala, May 19th, where is it? No, I don't have it. So if I say refresh, let's say perform incremental refresh. Now it came transaction record. So ideally we do this manually, because Impala cannot automatically identify you created a table in Hive. If you do it, it will come ideally. So Impala also stores a lot of metadata and actual data. Recent queries are all in the cache. So if you want to clear it, you can say clear cache. The recent queries you ran, it will store it in the cache. It will store. So sometimes the cache will become big, like you're running a lot of queries. So that will affect the performance. So you can simply say clear the cache. Yeah, ideally it should keep it in the cache. Hive does not use Impala. Hive uses only MapReduce. No, I don't think that is possible. Probably admin or somebody can do it. From a developer side, I have never. I mean, what is the use case? I don't know. I mean, masking, table masking is there. I don't know if it is possible. I have never tried. So table masking you can do. So that has to be done by the admins. So you can say that mask the table. It will not be visible to any other process like Impala or Spark or anything if you want. But usually we won't do like that. Usually we restrict the access based on user. So the user, so if I am a guy, okay, so all the Hive tables will be there in Impala, let's say. But if I am a guy who is a developer, and my access will be that I can see only these tables in Hive or these tables in Impala. So behind the scenes everywhere you will have tables, but user level access you can control, who can see what tables. Otherwise everybody will be able to see all the tables, right? I don't think directly there is an option to stop them communicating. Hortonworks Hadoop does not have Impala. They have this thing. Hive is there, and by default Hive plus Thais is the execution engine. Then LLAP. LLAP is their highlight actually. LLAP is much reliable, much faster than Impala, to be honest, right? So I'll show you LLAP, maybe not now, I'll see a session. So this part is clear, right? Hive and Hive plus Impala, I mean at least basics. Hue has an automatic way of identifying the data, but that will work only if you have a proper delimiter like comma or space. In Hue you can create a table. There it will identify if you have space or comma or something. I don't think geospatial data means what is the structure. So Impala, I mean this much only you need to know as of now. I mean I'm just giving it as an option. Normally in Hive classes we don't teach Impala at all. The sense why Hive is Hive, Impala is Impala. Not subject, like it has become like, so people don't learn it separately in the projects because the queries and all are same. The SQL you write, everything is same, there is no difference at all. Only thing is the use case is slightly different. No, only it has its own, and it is contributed by Cloudera. Impala is an open source project, but mostly the contribution is from Cloudera. So it is like a proprietary product. So if any issues comes, Cloudera will support a lot in Impala, point number one. And so another problem is that if you go to other platforms, you won't see Impala. Probably that is the reason people don't care much about Impala, right? So if I go to Hortonworks, I will not see Impala at all, right? If you want security, there is something called Sentry service. Sentry, you have to set up Sentry. I don't think we have Sentry here. So in Cloudera, I'm saying in Cloudera you have something called Sentry. Sentry Cloudera. So this is called Sentry. Here you can set up all the user level access, service level access, everything. Sentry, again Sentry is open source, but so here you have users, groups, and access. See, authorization privileges model for Hive and Impala. So the problem is Sentry is again Apache, but only Cloudera uses. You go to Hortonworks, you have Nox and Ranger, two tools. One is called Ranger and Nox. Again they are open source, but only on Hortonworks. So one problem is that platform wise there are some slight differences. I mean, it happens. So there are slight differences. Cloudera uses this Sentry, and in Sentry you can configure who should access which table and all the authorizations the admin has to set. I don't think Sentry is installed in our cluster, which means anybody can see anything. Even Hive, for Hive you have authentication. Username, password you will create. Here that is not there. I mean, as of now we are just saying Hive, it will enter, right? Kerberos is by default. I am saying right now what you are doing, you are logging into one of the machine in the cluster. It doesn't work like that. Are you getting my point? So I think we discussed this in the first class. So this is your cloud lab, right? This is your cloud lab, and you have an edge node. So you log on here, from here you connect to the lab, and any security, any service you need, you have to enable here. And as of now nothing is enabled, so when you just start Hive, you just hit the cluster and anybody can see anybody's table or anything that you create. Sentry is not enabled, I think, and that even when you are working you want to have access to Sentry and all. It's totally the admin side, they only can decide who should. You can request them, you may be not able to see who has access. Yes. So they will be in the cluster, but once you hit the edge node, that will be applied to you, like all the policies, whatever you are having. Otherwise you can't restrict the users, right, from coming in. Hortonworks has Ranger. Hortonworks. Ranger is similar. I also like the Hortonworks documentation a lot. It is much more precise and clear. You read, you will understand what they are talking. Cloudera documentation is very weird. Nobody will understand what they mean. Look at Hortonworks documentation. It's very easy to read and understand. See, comprehensive security for enterprise Hadoop. What Ranger does, how Ranger works, right? Everything you have here. So Apache Ranger offers centralized security for all these things, Hive, HBase. So if you go to Hive, they will show you what Hive does. See, there is even a YouTube presentation. Very nice documentation they have. The best documentation actually Hortonworks. See, LLAP, live long and process, is what I said. I think there is another explanation. It's not actually live long and process. Something else is there. Hortonworks just say it is live long and process. I don't think it is live long and process. So Hive details are here and some optimization techniques are here. Okay. Hortonworks document is the best if you want to learn. Only thing, if you are in a Cloudera production cluster, some of the things may not be applicable since it is totally open source. Like they have their own ways, right? So if you are using a Cloudera cluster in production, you should always refer Cloudera documentation, because not everything will be same. Some difference will be there, right? I hope that clarifies Impala. So we are talking about Impala. Now I have to talk about something called partitioning in Hive. Okay. So how many of you are actually aware of partitioning? Some of you might be aware of this concept. Yeah, for those who are already know this, probably it's a refresher, right? See, the idea is very simple. So can you tell me, so your manager asked you to create a sales table, okay, and you are creating a DB called retail and a table called sales. So where will be the location? Let's say manage table. It will be user, Hive, then what? Warehouse, and the DB is what? Retail, and the table is what? Sales. This is the location, right, for the manage table. And let's imagine every month you are getting the data, month end. So in January you got the data, so it became what? jan.csv. You said load data local, blah blah blah. This is where the data will go. You know this already. And the data got uploaded here. Everybody is happy, no problem. The problem is, as the next month and next month happens, right? What is going to happen in your sales folder in February? What will happen? February data will get uploaded. It's in the same folder, by the way. And again, what will happen? March, right? And April and May and so on. So the problem is, if this is the model you are following, after let's say a couple of years, if you look at the folder, you will have 10-20 files inside the same folder. Now the real problem is, let's say you are writing a query, something like this. Select star from sales, right? Where let's say month equal to Feb. Let's say you are writing this query. The problem is, Hive has no clue where is your data. It has to scan all the files in this folder to give you the result. The result is here, that you know. Hive doesn't know. When you write a query, it will scan all the folders in the sales folder. So if you are having, let's say, 100 files, Hive has to scan all the 100 files before producing the result. The drawback of this is that your queries will be very slow. So in order to avoid this problem, if this is the problem you are facing, you can do something called partitioning of table. Okay, and in partitioning you have two things. There is something called static partitioning and dynamic partitioning. Static and dynamic, you have two type of partitioning you can do. Okay, and I will show you that with the help of an example. That will be better. But what is the idea? In partitioning, first you have to identify the column or columns. Based on that you want to do partitioning. So I am assuming that this is my table structure and most of my queries are based on month equal to something, right? So what I can do in Hive, I can say that, okay, create a partition table where the partition column is month. And what Hive will do, if you provide the data, it will automatically identify and create folders like this and will place the data like this. So when you partition based on month, okay, there are multiple ways to do this. I will show you. Technically what is happening behind the scenes is that it will identify the month column, and as many months you have, those many subfolders will be created and it will move the data. Now we know that there are only 12 months in a year. So if this is the data model, you will first partition based on year, then month. So that it will create a folder called 2016, within that 12 subfolders, then 2017, within that 12. So but if this is the model, if you write this query, it will only hit here. It will skip all these other subfolders. So your queries will be naturally faster. This depends on what is the columns you are having. So let's say I am saying here the column name is Jan. So what is the next column? You have a week 1, week 2, like that you have. I mean, this depends on the data. Now in this data I don't have date. I have a month column, I have a day column, I have a year column. Now partitioning is not a must. It's not like everybody should do partitioning. There are many conditions where you cannot do partitioning. So like you said, if you are having date, you can't partition directly, because if I have a date column and let's say you are looking at last 10-year data, how many dates will be there? 3650. If I say partition by date, it will create 3650 folders. That's useless. There is another way to tackle it, I'll tell you, but you don't do that. So partitioning is applicable if the cardinality is very less. Something called cardinality, right? How many unique values you have in the column. Like in this case, or let's say you are getting data from different countries in the world. Fine, maximum you have 150, I don't know. Country wise you can say partition. But yeah, like you said, or another case is that you are having transactions and I want to divide the data based on transaction ID. That's not possible because every transaction has a unique transaction ID. It starts creating those many partitions. That's not possible. So partitioning should be used only when your cardinality is within control, like this. Right now you are partitioning only on the Jan column. I am giving him a different use case. Let's say you are getting the data from different countries. It also depends on what query you are running. For example, let's say this is the partition data. I write a query, select star from sales where country equal to India. It is a worst query I can write because my data is partitioned on month and I write a query based on country, it will have no impact. It is actually worse. So if you know that most of your queries are based on country and month, you partition by country and month. I mean, whichever way it is possible, probably first partition by month, then country, or country, then month. You have to figure out the cardinality. So that, and also if you are ending up creating lot of partitions, that's not a good idea for Hadoop, because Hadoop does not like a lot of subfolders and subfiles, right? So, and another drawback, I think I discussed this in the first class. This partitioning, if you do in traditional databases, it is sometimes not effective. Why? Because we had a use case where we had a Oracle cluster like this. 4 machines are there. Okay, and then you are saying, let's say you are looking at the iPhone sales data. You are selling iPhone sales data, and you want to partition the data based on country, number of sales in which country, right? So I will say that partition by country, but that's a logical partitioning. You are not physically dividing the data. The problem is it will create countries like India, China, US and all, right? So probably US partition will be here, this much will be there, and probably what, this will be what, I don't know, give me some weird country, Congo. You are getting the problem? You are logically partitioning, you are saying that divide the data based on country. Since in US lot of people buy iPhone, what is going to happen? US partition will be very big. This will be your US partition, right? I am talking about Oracle, okay? And this will be your Congo partition. And in Oracle, if you fire a query, what will happen? The machine is responsible for, they won't work together. So the US partition queries will be very slow because this guy has to churn. The Congo partition will be very fast, right? In Hadoop also what happens, you will do the same partitioning, okay? You will say that you have US data, India data and all, it will create subfolders, but the advantage is that even though this file will be 3 TB, it will be on 100 machines, blocks. In Oracle, this will be one machine. Are you able to understand what I am saying? So if you are storing the data in Oracle, Oracle has no idea of blocks and replicas. So US partition data will be 3 TB, 3 TB will be one machine. It won't divide this. If this is in Hadoop, 3 TB will never be in one machine. Blocks will get divided, right? So my query will be faster actually. So the partitioning is much more effective in Hadoop, I am saying, right? So which means partitioning in traditional databases and all are not so effective. It is effective up to an extent, but you have to ensure all the partitions are having equal amount of data. So partitioning is logical in every case. Even in Hadoop it is logical, in Oracle it is logical. In Oracle, I am saying that all the partitions of US should be in one machine. There is no way I can further divide this data. You are getting my point, right? Because it is not Hadoop or something, it's just a DB. So all the US data will be in one machine. So that machine will have lot of data related to US. But in Hadoop, if these are 4 data nodes, you will never have 3 terabyte on one data node. It will always divide and spread. Distributed. So my performance is better in partitioning, right? So these are some of the things we understand when we work, right? So that is why some of the companies will say don't do partitioning much. Sharding is there. Sharding is dividing a table, existing table. Sharding mostly we do in NoSQL. Oracle after 11G supports sharding, but it is not extensively useful actually. In NoSQL databases, you can do something called table sharding. Table sharding is like physical division. You take a table and say take 10,000 rows, just divide like 3 or 4 and then dump it. Okay. But that is not highly possible in RDBMS, because in RDBMS you have normalization. It is physically, any partition will physically divide the data, but can you say that I want to divide this table into 2 GB, 2 GB, 2 GB? That's not possible, right? That is logical. Physical division means, like he is saying, sharding. I take a table, the table has say 1000 rows. I can say divide it into 5, 200, 200, 200 rows, keep in 5 machines. That's not possible, right? In normal RDBMS. That's called physical division. You are not giving any condition. You are saying take the full table, split it into 5, 100 rows, keep it in 5 machines. That's not possible, impossible in RDBMS. In NoSQL it is possible, because it is denormalized. In NoSQL everything is denormalized. So I can divide my data and push it in whichever way I want. Nobody cares. It's already distributed. In Hive or traditional RDBMS, physical division is not possible. You logically divide. You say, look at this column, and if you have 100 values, divide into 100. 200, divide into 200. You don't have any control. You can't say this much division I want or this size I want. There is no physical control. Logically you are dividing the data, right? There is no way for you to understand. After March again there is a Feb. Hive has no clue, right? It keeps on searching all data. So creating this, either you can manually create these folders, or you can, so normally we don't do like that. We run a command and create it actually. So it is better to do this rather than talking about. This is just a basic idea. I want you to find out the data set and then start working on it. So there is partitioning. Can you see this folder? Partitioning. And there is a Word file if you want. I mean, this has the commands. But I have been facing one issue with this Word file, which is when you copy paste, sometimes the commands will not work. We will see whether it will work here. Okay, that quote, right? What you call single quote, it will not identify. So we will see whether it works or not. So we have not discussed what is static partitioning or dynamic partitioning, and I will talk about this. First thing, let's create a table and then we can start talking about it. So do you have the DB? Yes, right? Okay, the DB is here, and I will say create table. Just copy this command, okay? Now static partitioning is a bit confusing, but we can understand. So I am creating a table called user1, as you can see. If you look at the schema, it has first name, last name and ID, only 3 columns. And then I will say partitioned by country, region. This means these are my partition columns. I want to divide first by country, then by region. Fine. But there is a catch here. What is the catch? What is the data you are going to load? If you look at the data, this is the data, user info 1. And if you open this data, can you tell me how many fields are there in this data? 3, which are first name, last name and ID, right? And if you look at the table I created, it is matching here, right? Then I am saying partition by country, region, right? But there is no country or region here, right? This is static partitioning. So static partitioning means you are getting the data, you know from where the data is coming, but the data will not have that columns. Meaning I know that probably this data is coming from country equal to US, state equal to California, right? And while uploading this data, I should mention it. The data does not have any columns for country or region or anything, right? If I upload the data, you will understand. So do one thing, copy this to Hadoop, this user info 1. Can you do it? Go to HDFS. There is, I'll just copy to Raghu. User info 1. In fact, copy all so that we can save time, right? I mean, these are also required. Yeah, so then you have to use FTP. If you are copying to local, you have to use FTP. Better copy to Hive, it's faster, right? Anything. And I have a question to you. So right now in Hadoop, will it be already created the country and the region folders? What do you think? So partitioning means it is creating subfolders, right? I am saying create a partition table, country and region. Will it actually create a subfolder? Yeah, so no, nothing will be created as of now. And then what you need to do is, where is the WordPad? So I will copy this because I don't want to type a lot, but you have to change it, okay? Don't type it as it is, because what is the location? Raghu for me. File name is different, I think. Userinfo1.txt, right? Is there a txt extension? Yeah. So now what I'm saying that load the data, and this is my data, into the table, and while loading the data I'm mentioning the details. I'm saying there is a country New Zealand and region Quebec. So what will happen? It will create a folder called country New Zealand, another folder called region Quebec. Within that this file will go. Can you verify that in the warehouse folder? If you have loaded it, it should be available in the warehouse folder. So I'll go to Hive, I'll go to HDFS, and where is your data? User Hive, right? User Hive warehouse minus May. So many DBs are there. People started May 19 DB. Here is the user one. Can you see country equal to New Zealand? There is a folder in Hadoop called country equal to New Zealand. Within that there is region equal to Quebec. Within that you have your data. Try yourself and see whether you can see it. This will be there in your project and assignments. So partitioning is very important. It's in the Word file, right? Oh, okay. So it's wrong, right? Sorry. I'll just show here. So remember this point, static partitioning should be used like we had a use case, okay, where we were getting user data from multiple countries, okay. One of our clients application, the user data was coming from multiple countries, but the data will not have a country column. So we used to manually create, that's called static. You will say that put this data in US. Now we have to do something called dynamic partitioning, and I will show you that. So make sure you are able to log into Hive, and always do use your DB. Some of you are using default DB and when you type the command it will say already the table exists because a lot of you are actually using default DB. So if you meanwhile if you look at this data, right, Hive partitioning, can you tell me what is the difference between this data and the previous one you loaded? Exactly, it has the city and state or whatever. By the way, what is Togo and West Bengal doing together? Whatever, okay, so you have some city or region. Yeah, so this data has the country and city column. So the best way to do partitioning here is you create a partition table. You say there is a partition by country and state or whatever column, and then you tell Hive, I'll give you the data, you decide yourself. I'm not going to divide the data. You look at the column, I understand how many countries are there or how many states are there, accordingly create them and put them. That is called dynamic. But it's only like 20 lines of data, 20 or 20. Those many will be created ideally. And I think the first part, it starts with Christmas Island. There is no repetition, right? But there is one thing you have to understand in dynamic partitioning. Dynamic partitioning is by default disabled in Hive, because somebody can come and say that, okay, create a dynamic partition table, use transaction ID column. Then what will happen, millions of partitions will get created and it will screw everything. So by default, even in production clusters, dynamic partitioning will be disabled. So first you have to enable it, first thing. Second thing is that you cannot upload the data directly to dynamic partition table. What you need to do, first you upload the data to a temporary table or some table, okay. From that table you insert to partition table. Meaning, previously what we used to do, we created a static partition table, then we said load data in path, it went. We are able to do that because we know which partition where it is going. Right now we don't know, Hive has to decide. So what I will be doing, I will create a table first, normal table, I will upload this data, no partitioning, nothing. Then I will create a partition table, and from the original table I will say insert to the other table. So while doing that, it will divide and send. That is the only way to do dynamic partitioning in Hive. Okay, we will do that practically, so you will understand. You can't directly load. It has to be in a table. From there you have to do insert. But in this example, it's not really useful because you are having all unique values. Like normally you should have like 5 records for one country or something like that. But here everything is unique values we are having. But that's the idea. Let me see if I have another file, okay, because partitions in Hive, just this LAN property case study. One moment, okay. Load list. I will do one thing. Once we finish this particular example on dynamic partitioning, we will do something called bucketing also. And once we finish that, I will give you this assignment, this landed property analysis. You can do it by yourself. I mean, now it's easy. Commands are already there. And that will help you to reinforce the idea on partitioning. This has partitioning also. Just try that once I finish. Okay. So for the time being, for dynamic partitioning, what we will do, we will create a table called user2. You can see what I'm doing from here. Same thing. I copy paste. And this is the partitioning table, right? Look at here. I'm saying that partitioned by country and region. So this table is the one which will have my data partitioned. Okay. Then what I do, I'll create a table called user3. That's a regular table. First name, last name, country, region. First name, last name, country, region, right? So do we have only 4 columns? Where is the data? User info 3, right? No, we have first name, last name, ID. So your schema should have 5 columns, right? Then only it will work. I mean the original table. So this table called user3 will hold your original data. So what you will do, first you will load the data here. How do you load? Load data in path, because already it is in Hadoop. Where is in Hadoop? Raghu slash, what's the file name? User info 3.txt, right? Is that the name? Into table user 3. Yeah. So do till this, load the data to user 3 table. Yeah, so this user3 table will hold your original data, no partitioning, nothing. Will just have your data. From there, I will insert to the partition table. I cannot directly upload the data to partition table in dynamic partitioning. So I should copy the data to one original table. From there, I have to insert. In static, you are mentioning which country, which state and all manually. So you can upload the data, say create a folder like and then dump the file as it is. Here the file has to be divided based on column values dynamically. Hive has to decide. So you have to load the data to one table. From there you say insert to the partition table and Hive will dynamically partition it. Based on these two columns, country and region. Here I have created, right, country and region. Yes, first all the countries, within country regions. So right now we have around 20-25 lines of data, only that much will be there. Partition columns should be outside the schema when you define a partition table. So these are the partition columns, whether they exist in the data or not exist in the data, they have to be outside the schema. You say partition by, there you mention the schema. So it will not be here, it will be here. No, it's not required, only here, because the total schema will be including the partition columns. So it will understand. Okay, now I want you to do one thing. If you look at the Word file, right, you see these things, can you see this? Right? So these are the properties you need to enable for dynamic partitioning. So the first one is very easy. If you read, you will understand. You are saying that, hey Hive, enable dynamic partitioning. Set Hive exec dynamic partition true, which means by default it is false. By default dynamic partitions are not supported. So you are saying that yes, I want dynamic partitions. But what about this? Let me copy that. So even if you enable dynamic partitioning, by default in Hive what happens? If you create a partition table, at least one static partition should be there. So it's a bit complicated to understand. So there are a lot of layers of security, but everything you can override also. So in Hive, first they say, I will not allow you to create dynamic partition at all. Only static is allowed. So you say set Hive exec dynamic partition true, which means now I can create dynamic partition. But then they are thinking, if you are allowing you to create dynamic partition, what if again you try creating 1000 partition, 10,000 partition? So there is a strict mode. Now we are in non-strict. What will the strict mode tell you is that even if you are in dynamic partitioning, okay, you have to first create one static partition in the table, rest can be dynamic. One column you static you do, rest everything has to be dynamic. You can again turn it off. So many people have a confusion. Each partition table. So right now our partition is based on what? Country, what is that? Country and region, right? So what they are saying, country you manually mention while uploading, country partition you manually mention, region Hive will decide in strict mode. It will not add, it will manage internally, but it is saying that manually you mention at least one static partition need to be created. It is just a safety measure. Even in production setups we disable it, because who want to do it? You have 3 columns and one column you have to statically mention, means nobody is able to allow you to do that, right? But sometimes it is very useful, I'll tell you, because you are getting the data where there is no country column. Okay, so you want to add a country partition, that will be static. You have some other data, let's say I don't know, state or something, that already is there, so that can be dynamic. So in that case you don't have to turn it off, because you will mention country statically, there is no other way. Rest of them it will be dynamically creating it. So we are turning it off because it's a developer environment. It's fine, we will create as many partitions as we want. Normally these are all true. I mean like dynamic partition is false, which means you cannot create any dynamic partition. This will be strict by default. So what we do is that yesterday somebody asked me, even I forgot to discuss it, you can create scripts. Hive script, like SQL script. You create SQL script, right? .SQL file. Same way I can copy all these commands in a text file, save it as .HQL. I say run, it will run. as a script. That's, you won't type everything, right? Who does that? So in the script, while doing, you will first add these things, you know, set this, and just run it. That's how usually we do it. It can be SQL also. SQL or SQL, only two. Technically, I have not tried anything apart from that. Normally, we try either SQL or HQL. I don't think if you add any other, will it work if you have a SQL script? It will work. Hive I have not tried, because all the scripts we have is HQL. By default, people save as HQL only. I have not tried. It might work. But I am saying, so, and these are specific to your session. So, Hive's language is called HQL, Hive query language. Okay, and this is not a script. We are not writing scripts. This is the shell. This is the query. Script is different. What I am saying, all these commands you can write in a text file, notepad, and you can say run the notepad. It will execute one by one. You don't have to copy paste each time. HQL. It is Hive query language. So
Hive is mainly for converting SQL queries to
so that's what I said yesterday. The language of Hive is called HQL, which is derived from SQL. So 95% is similar. There are some very rare commands which only Hive has. SQL doesn't have. So I think it is SQL 2002 dialect. What it is using. SQL 2002. There are ANSI formats, right, for SQL. SQL 92, SQL 2002, SQL 2004. Hive is built on SQL 2002, if I remember. SQL format I am saying. This is syntax, right? Do you find any syntax different from your regular SQL syntax? Partitioning clause is different, right? That's what I am saying. So if you are doing partitioning in SQL, it's not this command. Slight difference is there. So these two properties, I think you understood. What is the enabling dynamic partitioning, and the mode is non-strict. Now again, for controlling, this is Hive exec maximum dynamic partition 100, which means you are restricting maximum number of dynamic partition is 100. Then this property is not actually correct. The property is correct, but you should find a different value. For example, let's write it as 100. What this means is that, so when, let's say you are creating dynamic partitioning, let's say you have a very large file, and let's say in the column you have 150 values, countries, imagine. So 150 partitions will be created. Each partition will be created by one reducer. It's MapReduce job end of the day. So this creation of partitioning table will fire a MapReduce job end of the day. So one reducer will work to create one partition. So if you have 150 partitions, 150 reducers will work. Here you can control it. This dynamic partition per node 100 means maximum number of reducers will be 100 used. So if you want, you can control the number of reducers. Okay, the advantage and disadvantage is different, meaning sometimes what is going to happen, you may not really need 150 reducers to do the job. Correct. So if you have 150 partitions, if your data is very less, you can achieve it using 50 reducers maybe. So you say limit it to 50, only 50 reducers will be launched. So this you are saying, so these values are wrong. I am saying wrong in the sense, you are saying maximum number of partition is 100, that's fine. Okay, maximum reducers are 100. So ideally here 100 reducers will run if you have 100 partition, but mappers will depend on your input split, right? Again, so like what data you are getting, so that you don't have any control anyway. Reducers only you have control. My point is, if you are having a very small file, okay, and probably 100 partitions are there, you don't need 100 reducers, probably 10 reducers can do the job. So you can control this property. And I didn't make up these properties, it's available in Hive. Okay, so people will be thinking that, okay, from where did you get all these properties? It's properly documented. I'll give you the document for this. You can copy any of these properties, go to Google, just paste it, and Hive language manual will come. Not the first one, okay. So this is Hortonworks. I mean the original Hive language manual will come. if you open this, just search for here you have all the properties. Where is it? Hive exec dynamic partition, default value false. Okay, whether or not to allow dynamic partition. Hive exec dynamic partition mode, default value strict. In strict mode, the user must specify at least one static partition, right? Hive exec maximum dynamic partition, default value 1000. Hive exec maximum dynamic partition per node, maximum number of to create an each mapper reducer node. That means how many reducers will be used total, right? And you also have other properties for Hive. We will look into that later anyway. So if you come here, so we have enabled all these features, right? And now what you should do is that, where is the Word file? Here. You have to simply say insert. So this command, you will say insert the data from the table to the partition table. This is how you do it. And this will fire a MapReduce job, you can see. And you can see on the screen, it will create partitions. Look at my screen, or you can look at your screen also, whichever. You can see the partitions loading. I'll show you. Because dynamic, right? So see, country null, region null right now. See? Can you see? Country Nigeria, region, Pomoski, whatever, Oman. See? All these partitions are loaded dynamically. And verify that in Hadoop. Verify whether this is created in Hadoop, right? If you go here, what is the table name? So if I go to user 2, see how Korea came. I think it didn't come. It says just Korea. North Korea we had, right, in quotes and all. Yeah, I disabled. We are in non-strict mode. And any country you take, there will be a region. Any region you take, there will be a part file. Because it is output of a reducer. That is why that 00 comes. Reducers will run. Right? I think I don't know how many reducers ran for this. That's another thing. So this is 0, right? And if I go to something else, yeah. So that means those many reducers ran, right? Because everything is 0. So otherwise 0, 1, 2, if it is same, I'll just check. We can actually see the statistics here. If you go to not workflow, job browser, there is a job browser and this is the job we ran. Did I show you this? No, I think I showed you first class. If I go here, there is a task. It's not displaying everything. It's showing stage 1. I'll see anyway. So are you able to run this? I said yes. I think yes, right? Can you see the partitions? I don't know how many reducers were called. We'll see that later. But are you able to create this? Just look at your HDFS and see whether you can find all the partitions. Yeah. Because of the input data, right? So our data need to be either changed. I think because all other data is like regular. So here if you give like this, or you have to clean this. I mean, so usually what we do is that, I mean, if there are only limited records, you can use either pig or spark to clean the data. You can easily clean it. You can say that find codes and then replace. So first column name that you give in the partition will be the top level partition. Within that, it will create those many sub partitions actually. But rest of the partitions are loading, right? There is no problem, I think. How do you search? So there is no way to search for rejections from here. You have to manually verify, because here it says country equal to Korea, region equal to North. That's all. It didn't reject it actually. It created Korea, then the region is North actually. That is incorrect. Okay, as per. So before loading, you have to validate the data. That is only way. So we do that. There are validators which can do field validation, and whether all the fields are like this, and exception handling. This you have to do before you do it. This data set has an exception, that's fine, but usually you have to validate. Now, so this is usually how you do dynamic partitioning. And one more thing is that when you are doing dynamic partitioning, there are performance problems sometimes, like creating too many dynamic partitions is not advised. Even Hadoop will not allow, because name node has to handle all the metadata for the subfolders and the files. Like you are having 150 countries and each country has states. So if you say divide by country and state, thousands of folders will be created. So that will increase the metadata on name node. So in one way it is good, your queries will be faster, but other way, so there is no limit as to how many you can create partitions, but we say that do it with caution. No, only thing is that your name node performance will be affected, right? Like thousands of partitions are not a big problem, but so many huge number of partitions are there, that will become a problem actually. It's not table size, so usually when you use partitioning is that if your queries are running slow, like, and the reason is that inside the same folder you are having multiple files and it has to scan all the files. And there are some cases where you cannot do partitioning. You may not be able to find out a logic to do partitioning. Probably there is no common column or something. Then I can't do partitioning. There is no other way. It's not like everybody must do partitioning. There is no rule like that, right? Now somebody asked a question, right? So this will lead us to bucketing. But what if I am having, let's say you are getting data from the country side. So you decided to partition. So it becomes country, your partition column, and there are 150 countries. Look at Amazon, look at Dell for example. Dell has presence in 150 countries, okay, and so customers are buying products of Dell and they have some data which is country wise, okay. So what they decided to partition based on country. Fine, no problem. Now after this, what happened is that, so every time when customer is purchasing a product, there is a transaction ID, right? And they want to write queries like this, select something, okay, where country equal to India, okay, comma, transaction ID equal to 1234. Now the problem is it's already partitioned based on the country, so that part is saved because it will look at only India, but within India you have millions of transactions. So this transaction file will be huge, it has to scan all, probably there are multiple transaction files, okay, and you cannot partition based on transaction ID because every transaction is unique, right? So what do you do? That's the question. And I don't know whether this is available in RDBMS and all. We do something called bucketing, bucket. You have something called hash partitioning, right? Can you tell me what is hash partitioning? In RDBMS I'm asking. RDBMS you have, who knows about hash partitioning? What is hash partitioning? Because this bucketing is very similar to hash partitioning in RDBMS side. I have not done hash partitioning. So what we do is that, see, there is a transaction ID column, right? This is your transaction ID column. And here what are the values you can have? Let's say 1, 2, 3, 4, right? Like this transaction ID. And let's say 1 million. This is the data you have. Now you want to divide this data based on transaction ID and you cannot do partitioning. You say bucket it. When you do bucketing, it can be done only on one column. You cannot say 2 column bucketing, not possible. and I say I want to create, let's say, 10 buckets. So you always mention the number of buckets you want. That is all you do. What is going to happen, within each country partition, it will create 10 files, not folders. It will divide this data based on an internal hashing logic, okay, and create 10 buckets, 10 files within each country folder. So when this query hits, it will calculate the hash of this, okay, and find out which file is having, it will hit only there. So to easily understand, this is not the actual idea, but 5, 6, 7, 8, 9, 10, 11, 12. These are the transaction IDs. Now I want to divide them into 10 files. So there is an internal logic which Hive uses. I am not going to tell the same logic, but when I say I want 10 buckets, 10 files will be created. Fine. So I say 1, 2, 3, 4, 5. These are the files, okay. And let's say we take a very simple logic. You want to find the modulo 10. You know modulo 10, right? What is the modulo 10 of 1? 1. So this will go to this bucket. This will also go where? Are you able to understand? This will go here. This will go here. Well, it is not doing like this. I am saying similar. So there is an internal hashing logic, and then when you write this query, it will look at 4. It will go to 4th bucket. That's the logic. Not this logic. It doesn't do modulo 10. Okay, it does some other complicated logic, but it will internally divide. We don't have to bother. It will internally divide. Now, many people have a misconception that you should always use partitioning and bucketing together. No. I mean, it's a misconception. People who are already working, I have seen a lot of people discussing. No. But in most of the examples, when you search, you want to learn partitioning, people will say that I will first create partition, then inside that bucketing. That's a practice, but you can independently create bucketing without partitioning. I can simply take a table, say I want to bucket it. That's all. I don't want any partitioning or anything. So what will happen, in the same folder, it will create those many files, 10 files. Physical files. We can see that. Bucketing we can see. Practically we can see. If you can do partitioning, don't do bucketing, because that's the most obvious thing. Where you cannot do partitioning, you enable bucketing. For example, India is there. Within that, you don't have any choice. And there is no ideal way to decide how many buckets are required. I mean, so next question is how many buckets? 10, 100. So ideally you should take care that the file size should be somewhere near to the block size. Don't create like 1 MB size bucket. So if you are having, let's say the data is 10 GB within a partition, okay, you say create 1000 buckets, you know, it will become very, very small. Don't do that, because that will create smaller files. So ideally take a block size calculation. How many buckets you need, you have to decide. Some logic you have to use for that actually. If data becomes big, that's not a problem. Data should not become small, that's a problem. Like bucket size should not be 1 MB. Then it will create too many small files in Hadoop, right? Hadoop doesn't like it. So if the bucket size is 500 MB, fine. It can become 1 GB, it will still divide into blocks. That's fine. We are okay with it. Not the block size. I am saying bigger than the block size. If it is smaller than the block size, Hadoop always doesn't prefer that, because smaller files are not very well handled in Hadoop. Okay. Join operations. These buckets are excellent for join operations. There is something called bucket join. So Hive has lot of advanced concepts. For the time being, you may not be aware of that. Okay. So what will happen is that I have a table here. Okay. And this is my column. And this is bucketed. So this means this is divided into let's say 5 files. 1, 2, 3, 4, 5. I have another table that also has the same column, that is also bucketed. Possible, right? And this is also having either same number of buckets or multiple. Then you can do a real fast bucket join. There is something called bucket join. Because since the data is divided into equal partitions, the joins will be really fast actually when you bucket it. So when you write a join query, you will say use bucketed join. There is a command you can use. I mean, there can be mismatch. When you do join operations, there should be a common column, join column, and usually they will have similar entries, right? That is the idea you are doing join. Otherwise, what is the use of a join? So, so this is like you are having two tables and you want to do a join operation. Normally you can do a join, no doubt, but if the join column, common column is bucketed, okay, then there is something called bucket join you can use, which will be faster. Hive will internally make it faster. Since it is bucketed, the join operation will become faster, hashing. So, and there is multiple types of bucket joins actually in Hive. So it's very interesting. It's a bit advanced concept, but these things are possible in Hive. No, that's anyway just an, so it's very rare that you may get a chance on this, but people are aware of these things like bucket joins you can do, right? So we can do bucketing practically, that will be better, right, rather than talking. So why don't you look at another data set? So can you open this bucketing data? How do you open with what? Excel, right? See, this is a very interesting case study because here you can appreciate more partitioning because we have similar things. See, you are having street, right? And the street is having almost unique values, some unique at least. City is Sacramento, zip code you have, state you have California, bedroom, bathroom, square feet. So this is this thing, real estate data, and type is residential, condo, blah blah blah, price, some price, right? So, and how many lines of data you have? 986 lines of data you have. Now our intention is to do bucketing, but we will do partitioning also, just to see. Anyway, we can do that. So what I want you to do is first upload this data to how do you upload? The file name is real_state.csv. That's the file name. Okay. And I want you to open this WordPad, which will be here, bucketing Hive. Yeah, so what we are going to do, first we will create a table, okay, and this is a normal table, okay. I'll say create table RE state, that's called real estate, and this has the schema, regular schema, no partitioning, no bucketing, terminated by comma, regular stuff, no changes. And we will load the data. How do you load the data? Load data in path. So I guess you will be able to load the data. So this, if you create, what you can do is load the data, and you have to enable bucketing. So again, bucketing is disabled. So just say set Hive enforce bucketing true. So the command hive.enforce.bucketing equal to true will enable bucketing, right? And look at this command. This is probably the most important command. Create table. You are calling the table bucket_table, and I have the schema partition by city, clustered by street into 4 buckets. What do you mean by this? Partition by city. So city you have common entries, right? I think Sacramento or something. So I'll say that partition column is city. Then I'll say clustered by street. So street column into 4 buckets. So it will create those many city partitions. Each partition will have 4 what do you call it, buckets, but it is not mandatory. Another thing is that if a city has only one line of data, only one bucket will be there. If it has more data, then only the 4 buckets will make sense. Some of the cities will have only one street, let's say, it will create only one bucket in that case. And now just load it and see whether you can see the buckets. I want you to try. Disabled, yeah, even bucketing is disabled. And now I want all of you to try yourself. I'm just doing an insert. Once the insert is complete, go back to your user Hive warehouse folder. You should be able to find partitions and buckets. So I will even show you my buckets. I mean, like, we just want to see the buckets. So if I go to user Hive, Hive warehouse, mine is May 19 DB. May 19 DB. What is the table we have? Bucket table. If I open bucket table, these are the city. If I open a city, there are 4 buckets. But again, bucketing also depends on distribution of data. See here, the last 2 buckets are not having any data. But if you are having only one line or just 2 lines, like, then only 1 or 2 buckets will be created. Hive is very intelligent, like very less data. It won't create 4 buckets. Here I think you are having more, like some 4-10 lines. I don't know how many you have. Based on that it will create. But the last 2 buckets are empty in this example. So ideally you should have more data. This is happening because we are having very less data, right? Some 1000 lines we have actually. But number of mappers will be there, right? Yeah. Either mapper or reducer. I said reducer, so I'll show you here. In that property it will be visible. It can be either a mapper or a reducer. Now when we created the partition, he is saying I am not able to see any reducer jobs, only mapper jobs ran. So see here, maximum number of dynamic partitions allowed to be created in each mapper/reducer node. So it can be a mapper job or a reducer job. If you are having less amount of data, it will be a mapper only will run. But sometimes what happens, you will have huge amount of data and the mappers will first move the data, then the reducers will aggregate into different buckets or partitions. Now he is saying he is not able to see reducers in the job. I am saying it can be either mapper or reducer in the when firing a partition query. It depends on resource allocation. If the cluster is having resources, it will allocate. I got only one mapper. Mine is actually only one mapper, no reducer at all. Yeah, it can be either a mapper or reducer. It doesn't matter actually, to be honest. What is going to happen is, when you created that partition table, right? When you do an insert, what is happening? Map reduce job. So, and what is that map reduce job doing? That is my question. It has to segregate the data. That is what it is doing, right? It is not doing any other logic. It is just segregating the data based on your partition or bucket, you know. So right now you did, so did you check this partitioning with bucketing? Is it also not firing any reducer? You are saying that the recent one, right? With bucketing. So you are getting reducer? 0. Mapper is there. How many? 1 mapper. Yeah, even I got 1 mapper. So sometimes what happens, if the cluster has enough resources, it will fire mappers and reducers so that it can complete really fast. So mappers will first probably segregate based on partition and reducer will just calculate the hash and dump it. But if the cluster is not having enough resources, this job will be very slow, only mappers will be launched. They have to complete the whole thing. But there is no intelligence in it, I am saying. It is just a way of the cluster managing your partitioning process. The logic is written, but you cannot really say that it has to be done by a reducer or a mapper, right? Sometimes it will be achieved only using a mapper, sometimes it will shuffle and fire a reducer also. Yes, in my case it was done, there was only one mapper in my map reducer. In his case I think 4 reducers were launched. So probably there was some shuffle operation, depends on where is your data also. Another thing is that when there is a reducer, there is shuffling of data. Data shuffles and then goes to a reducer. So I don't know, probably in his case some shuffle operation happened, that is why the reducer kicked in. Anyway, it is not really important, I am saying. I mean, while inserting into a partition table, it really doesn't matter whether a mapper is doing it or a reducer is doing it. It does not have any impact on the developer side, because it is just a finding by column and then moving the data, that is all you are doing. But in a query and all, it is very important, because if you write a proper query, how many mappers, reducers get involved, that is very important actually. Hive can also store the result as text file. So let's say you write a query and the output is normally shown on the screen. Like you write a query, it will show there. You can say save it on HDFS, the output, whatever query output. The command is insert overwrite directory. There is a command called insert overwrite directory. Then you write your query. What will happen is that whatever is the output of the query, it will save as a text file on Hadoop if you want to save it, right? So normally you want to see, but sometimes you want to save. If you want, you can do that also directly. It is insert overwrite directory, if I remember, because we rarely save it as text file. Okay, Hive insert overwrite directory. So this is the one, insert override directory. But I have to see. It is there. You can try this command, insert override directory, and then you give a path and then you say select star. So let's try that. I will say directory. What we will say? Where is the spelling? Oh, direct. Insert override directory. I will say Raghu /abc count star. Give me a table name that we created just now. NASA log, right? There is a NASA log, right? So this means it will create a folder in Hadoop in Raghu ABC. There the result will be stored. Query result. If you want to store it somewhere, you can do that. You can try this out. See, so when you are creating a Hive table, it store it as a text file. By default, whatever data you are loading into a Hive table, it is available in Hadoop, and that will be in a text format like CSV or any text format. And over the period of years, there has been lot of compression techniques to compress the data. So while creating a table, you can mention how to store the data. Now I have some very good Hortonworks links. I will share it with you. Is there a way? Okay, I can. Anyway, you are not going to see, right? I'll just open my mail because I just shared some links I wanted to show you. I think in your assignment this is there, ORC, right? Correct. And that is very easy. I mean, so storing the data as ORC is very, very easy. You just need to understand what is happening. Yeah, very rare customers are there in Hotmail, right? I never quit Hotmail. Yeah, so here is it. So there are some Hortonworks links which I found very interesting. Okay. So ORC is a format. So this is a Hortonworks link, but so ORC files in HDP, better compression, better performance. So when creating a Hive table, last line you can add store as ORC. Only one thing you need to do, just say store as ORC. And what is going to happen, whatever data you are loading into that table, Hive will compress it. ORC stands for optimized row column format. It's a compression technique. What is the advantage? First advantage, your data is compressed. Well, that's not a great advantage maybe. Second advantage and the most important advantage is that ORC has indexing. There is a technique called indexing, right? Now in Hive, you by default has indexing, but that is very poor. If you enable indexing, you will not get any performance. What ORC does, it will compress your data, and whatever data is in the compressed file, it will create an index inside that. So when you hit queries, columnar queries and all, your queries will be really fast if the table is having ORC property. Column indexing, regular column indexing you have, right, in RDBMS and all. What is indexing? In order to faster the queries, you will create sort of like a, how do I say, pointer to the original data. ORC will create an index on row and column as well. There is row indexing and column indexing. It will create on everything actually, and it is very, very efficient. Apart from ORC, if you want, you can create normal indexing in Hive. There is something called bitmap index and compact index, but they are very inefficient actually, because even if you create an index in Hive, you are not actually dealing with name node or HDFS. You don't know where is the data. But if in ORC, what is happening is that you are asking Hive to manage the data, compressed data. So it will create its own index for the whole data and store it. Now I'll share this link, but if you scroll down, one of the things that they say here is this. So these are, so if you have a 585 GB file in Hive, if you store it as text file, this is the size. There is a format called RC file, it will become 505. There is another format called Parquet, it will become 221. If it is ORC, it is 131 GB. That is the level of compression you are getting. So Parquet and RC are other compression formats. RC is not very common now, because ORC is optimization on RC. RC is row columnar, ORC is optimized row columnar. So RC nobody is using. Parquet some people use. So Parquet is also another compression technique, but Parquet does not have indexing or anything. It will simply compress your data. That's all. ORC has this advantage of indexing within that, right? So that's one advantage. Avro is a serialization format. How do I say? So let's say you are sending a lot of data. You can send the data along with the schema. Normally, where will you mention the schema in a table? Now Avro is a format which can apply schema even to text files without a table or anything. While sending the data, you can have a header on schema. So it is very common in Hadoop systems that you use Avro format. Okay, and if you scroll down, so this is how ORC will store the data. This is one thing you need to understand. So it will create index on, let's say, first 10,000 rows. You can mention how many rows you need to create index. It is a row and column index. So here I am saying that 10,000 rows I want index. So what it will do, first 10,000 rows, it will create an index and store here. Next 10,000 rows, it will create an index and store here. So if somebody is querying, it can understand which group of rows it has to push, and it can even skip these 10,000 rows in one shot. Let's say you are writing a filter condition. Since it knows what is inside here, it can simply skip this entire 10,000 row and scan here. So it's very fast if you do it in ORC. Other formats do not have this ability. And there is something called vectorization in Hive. It's an advanced property. Vectorization will allow you to read thousands of rows in one shot. Normally when you are reading the data, it reads one row, second row, third row. If you enable vectorization with ORC, ORC can read thousands of rows in one shot. So vectorization and all will work only on ORC. ORC is the only format which supports vectorization. Also this batch indexing, these properties are only available. And when you go to Hortonworks, I told you that you can have ACID properties in Hive. You can enable real-time queries. The condition is that the table should be ORC, then only ACID will work. So for all these reasons, people prefer ORC wherever possible. But what can be one drawback? These are all advantages, but what can be one drawback? Exactly, it has to decompress. Meaning your CPU cycles might be required. Anything which is compressed, you have to decompress. So compression is okay, you are storing it, and that's okay. But when you are querying, it has to uncompress the data, right? So CPU cycles are required, but still people are preferring it because they are okay to spend some money on CPUs, but still it is very faster and gives you all these properties. So just go through this link. One link is this, okay, and stride is this. This is one stride. This 10,000 rows is called one stride. That one block of rows is called one stride actually, okay. And this is the speed of queries of 1 terabyte data. So this is Hive 1.0, this is Hive 1.1, that's fine. And then Hive plus vectorized query, Hive plus PPD. PPD is predicate push down. You know what is predicate push down? Like sending your filter first, right? So if you write a query like this, so let's say you are saying that join the data and then filter the data. This is bad, right? You are saying join the data, then filter the data. First you should filter the data, then join. So by default in RDBMS and all, it will first bring the filter together. It will optimize. In Hive you have to manually do this. That is called PPD, predicate push down. So if you enable PPD along with ORC, this filter will come first, then join will come. So it will push the predicate basically, that's the idea. ORC, yeah. So and I can show you this. I mean, I'm not just blabbering. If you look at your Cloudera, this thing, Cloudera manager, right? So where is the Cloud Lab? You look at the Cloudera manager, you can see whether these properties are enabled. Probably not all of them are enabled. That's one thing. Let's check. I'll go here. I'll go to Hive and I will go to configuration, and I don't know if I say PPD. No, it is not showing. Enable vectorization optimization. Okay, it is enabled. So this vectorization is the property by which if you are storing the data as ORC, it can read thousands of rows in one shot. If you enable vectorization, it can read thousands of rows in one go and then give it to you. So it makes, so vectorization is enabled. PPD I have not seen. I don't know whether it is enabled or something. If I search for PPD, it is not. Predicate push down, I don't see anything. Predicate, no, it is not there. Probably that property itself might not be here. It is not available. No, ultimately when you are reading, it will not get bulk, it will get row by row. That is a default nature. It is very slow actually. In Hive, when you are reading the data, it's in the row format, right? So when you are creating the table, you are saying row format delimited, and let's say your query result requires, let's say output is 10,000 rows. It will not push 10,000 rows. It will say row 1, row 2, row 3, like that it will come. So it's actually very slow in original Hive. If you enable vectorization, it can read minimum 1000 is there in vectorization, minimum 1000 rows. You can mention whatever you want. Those many will come in one shot. So it's very fast actually while getting the result. And vectorization requires ORC. No other format will work with vectorization. There is a reader for vectorization which is available in ORC only. As of now, I don't think any other format supports vectorization, right? So now the question is that how do you enable this ORC, right? Optimized row column format. So, So these things are very, very important. Okay, let me see if I can show you from another one. So these are some of the things which you can go through. So when you create a table, all you need to do is that you say stored as ORC. Last line you add stored as ORC and it will become ORC, and it will take the default values. You can even disable compression. Some people do it. So what if you don't have enough CPU power? You want to use indexing and all, but I don't want to compress the data. You can say compression none. It will not compress the data. Possible. And so these are the properties you can mention. In ORC, you can mention the compression. The default algorithm is called zlib. It's very efficient. You can either say none, zlib or snappy. These are the three options. So zlib and snappy are compression algorithms. If you say none, ORC table will be created, no compression. And then you have ORC compression size, number of bytes in each compression chunk. So the more you put, the more compression will happen. In this case it is 256 KB by default. ORC stripe size, number of bytes in each stripe, 256 MB. So each, I told you right, 10,000 rows like that. So the size of that is 256 MB. You can say that in my table, probably your table has 1 TB data, divide that into 256 like that. And row index stripe 10,000. For every 10,000 row, an index will be created. So this you can increase or decrease. Compression size is the number of bytes in each compression chunk. So that means when it is compressing, it creates something called chunks inside. So what should be the size of each chunk? Minimum size actually. So here by default it is 256 KB. Depends on the data as well. So we leave these things to default. We don't change the compression size and all, because the algorithm zlib or snappy or none you can change, and the stripe size is how it is dividing the data. Like here the stripe size is 256 MB. 256 MB will be the size of your one stripe, right? And in each stripe it will get 10,000 rows and create an index. So probably in one stripe it will create like 5 or 6 indexes depending on how many rows you are having. One you are mentioning the size, and within that how many rows one index need to be created. It's okay. So sometimes I mean these are the properties, just read, you will understand anyway. Okay. And you don't have to mention this also. So normally when you create ORC table, you just say stored as ORC, because that is better. ORC will take care of the compression itself. These are the values you can adjust if you want to tune them. If you simply say store as ORC, that's also fine. Yes. So if you say compression none, it will not compress the data. It will index it. It will definitely index it. But no compression will be there. No, the default is text file, because for so long people are using text file. I don't know. ORC is an evolving standard. Okay. And ORC has different versions and all. With every Hive release, they will release a new standard for ORC and all. Text file is the standard format, and you don't want to force anybody to use a particular standard, right? This is better. So if you want, you can use it. That's the only thing. You can't read an ORC file. You can see that, you cannot read it because it is like compressed, and only Hive can read it. Hive can only create and read it. It will look like a zip file only, but you won't be able to open and see what is inside. Only Hive or ORC readers can read it actually. Like you want to set up a small setup, or like in a production you want to do it. Production. So obviously you need machines, and you may not be setting up only Hadoop and Hive. Because people will be having the complete package actually. When you say Hadoop and Hive, that's only 2 tools, right? So rather than setting only Hadoop and Hive, so it's very easy. You have to have machines, then you have to go to one of the vendor, either Cloudera or Hortonworks, get their distribution, install it. If you are using Apache Hadoop, you have to first download the original source, extract it. There are 4 files: core site XML, HDFS site XML, yarn site XML, mapred site XML. In each of these files, XML files, you have to manually type the properties. Probably take a year to complete almost, and you will not succeed. Even I will not succeed, because it's very difficult. Nobody does that. We used to do it. I used to set up Apache clusters, but very, very complicated it is because everything is manual. There is no automation, everything, and there is no use for that also. Only use is that probably you want open source Apache. That is Hortonworks. The Hortonworks edition and Apache edition are exactly same, no difference at all. Yeah, even Cloudera and Hortonworks, there is a free edition. Okay, so since all these companies are selling open source products, you can go to Hortonworks or Cloudera and download their product, install them on as many machines as you want. The problem is you will not get technical support. In Cloudera, you have an edition called Express Edition. Okay, what is our cluster? Our cluster should be Express Edition, right? You can check it. So this is Cloudera, right? Somewhere it will be there. I don't think maybe I'll be able to see the edition because you don't have access to everything, right? See Cloudera Express. This is free. So we are running on 8 nodes or 10 nodes, right? This cluster. It's absolutely free. You don't have to pay a single penny to Cloudera. But if something happens, they won't help you. Like technical support is not there. The commercial edition is called Cloudera Enterprise. So when you are installing the cluster, it will ask you, do you want Express? Do you want Enterprise? If you say Enterprise, they will ask, please browse and upload your license key. Then only the installation will proceed. Actually, yeah. So if you want to test or try something, any of this, there are people who run on hundreds of nodes in this edition, Express edition. No, the Hortonworks sandbox will not run in multiple nodes. It's only single machine setup. That manually you have to install. I'm not quite sure whether it will work because the sandbox is designed for one machine only. It is not designed for distributed. Like it is running only, it cannot be expanded. Even if you connect both of them, they won't work because they are working as independently. Sandbox is a virtual machine which you can download and install on your PC. If you start it, it will have everything, Hadoop, Hive, Spark, everything just to learn like a single machine setup. Production setup is totally different, installing and all. So that comes in the admin side. That is why I'm not talking much about it. You may not be able to understand even if I say, because there are a lot of other things apart from just Hadoop or something. You have to set up a lot of repositories, then machines and mirroring and racking, and then the setup is same. You will have, let's say, 100 machines, one will become master, and in every machine you will use either Cloudera Manager or any tool to download Hadoop and distribute. So then you have to first, what you need to do, you have to download this tool called Cloudera Manager. Download it on one machine. Then start Cloudera Manager. It will ask you how many machines you have. You say 4 machines. It will ask you which one you want master. You say this machine. It will download, install, do everything for you. So Cloudera Manager you have to install on one machine. And then you start it, it will immediately ask you how many machines you have. You give the IP, it will detect. Then it will ask which one is your name node, which one is the data node, which one is. So you select this. It will download Hadoop, distribute it, install it, set it up and give you the cluster. That is how this cluster is created actually. No, there is no limitation. You can have thousands of machines, but people don't do it actually. I mean, if it is a production setup, they go for enterprise licensing. But even the Express edition is pretty stable. And the Express edition does not have some features of the enterprise edition. Like you have something called rolling restarts and rolling upgrades. For example, let's say you want to restart a machine in a cluster. Now usually when you restart it, it will have tons of problems because your name node will detect this is down. So sometimes in the Hadoop cluster you might want to restart all the machines. You applied some patches or something. And sometimes you want to upgrade the Hadoop version. You are running 2.6, you want to go to 2.7. Upgrade will happen, but after that every machine should restart. So if I do this in a production cluster, it is very difficult. So in the Express edition, there is no way every machine will go down. In Enterprise edition, you have something called rolling restart, which means one by one it will restart machines without affecting the cluster. End of the day, every machine could have restarted, but your services will not be affected. And you also have mirroring backups, advanced backup mirroring solutions that are all available only in Enterprise. This edition will not have. All the features will be there like Spark or whatever tools you want, everything will be there. Commissioning, you can commission on the fly, you can add 2 machines, nothing will happen, 2 machines will get added, immediately they become part of your cluster. It's called commissioning. I don't know if I can show you here. I will not be able to add them, but you go to this host menu and there is something called commission state. It is commission 11 now. That means there are 11 machines running. No, I can't add because I don't have any permission, but there will be an option called add a machine here, commission. And so right now it says commissioned 11. So as of now everything is commissioned. I don't have any admin rights. Otherwise we can just say click add, it will add on the fly, no problem. And Spark requires some level of understanding before we actually go to the hands-on side. We can do the hands-on in Spark for sure. We'll be doing a lot of hands-on. But if I directly start with, okay, write a program, you'll not understand what we are doing, right? So that is why some slides are there. I'm not really a slides person, but still some topics we have to understand and only you can go to Spark, right? So first thing you need to understand is what is Spark and from where we got Spark, right? So why people are so excited about Spark. So your previous session trainer, right? What is his name? He was asking me that, can I learn Spark? I really want to learn Spark. That's the power of Spark. I'm not saying, I mean, even I want to learn machine learning. I'm not saying that way, but he want to leverage Spark. So he was asking me some doubts like, can I get started with Spark? I want to do machine learning on Spark because everybody is excited about Spark. So, and all my trainings these days are on Spark. Majority of trainings are on Spark. So there is a lot of excitement about this tool. And why is it? Why Spark is so popular? Or is it some magic or something what Spark is doing, right? So it's very easy to understand why it is so popular. Somewhere in 2009, okay, we had a project called AMP Lab. In the University of Berkeley, there is a research project called AMP Lab. So this AMP Lab project is even live today. It's a research project in University of Berkeley. So there people were trying to create a new cluster manager. Do you remember Yarn? Yeah. So Yarn is what your resource manager in Hadoop. And Hadoop version 2 came in 2012. What you're seeing today. So Yarn came in 2012. Right. Yarn came with Hadoop. We are talking about 2009. So in 2009, there is no Yarn. We were running Hadoop 1, old Hadoop version, and there was no good cluster managers. So some folks at the University of Berkeley, they were trying to create a cluster manager very similar to Yarn. Okay. At that time, there is no Yarn. Okay. And they call this project as Mesos. Mesos. Mesos is the project name they have given for this project. Okay. And these guys were doing some R&D and at last they created the cluster manager, like very similar to Yarn. Mesos is there even now. It's an Apache project, very similar to Yarn. So why Yarn became so popular? Because Yarn is coming by default with Hadoop. If you download Hadoop, you will get Yarn. If I want to use Mesos, I have to install it separately. But Hadoop will run on top of Mesos also. There the only difference will be that your Yarn layer will be handled by Mesos. Okay. So Mesos is a very famous project. Even today, some of the folks use it actually. Not everybody use it. And Mesos was created in 2009 in AMP Lab. So they created Mesos and they said that it's a great cluster manager. We're going to use it, blah, 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 right? Now, in order to test the power of Mesos, okay, first they ran some MapReduce programs. Of course, MapReduce was what we had originally and it was running fine. So then they thought, why don't we just use a different programming framework, and they created something called Spark. So Spark was created actually to test Mesos, meaning Mesos is your cluster manager and they created a new programming framework called Spark. So you can write a program using Spark, it will run on Mesos. And the only difference was that Spark was completely in-memory execution, like it will use most of your RAM. So if you have a cluster manager, and if there is a lot of RAM getting used, you can actually test, right, whether the cluster manager is good or bad. So they created this Spark programming framework, wherein if you write a Spark program, it will use majority of your RAM for faster processing. And they tested Mesos. And Mesos became a success. Everybody was happy. People never thought much about Spark. They just created as a sub project. Okay. But after an year, like 2010 or 11, people thought that, hey, this Spark is good, because if you write a program in Spark, first thing people noticed is that it is running faster compared with MapReduce. I'll tell you why it is running faster. So people thought that, why don't we develop Spark a bit more? If people can write a Spark program and if it is running faster, should be great, right? And the development started, and somewhere in 2012, I believe, Spark became an Apache project. So they contributed to Apache and said that, we have created a new product. It's make it open source. And this is a framework like MapReduce. If you write a Spark program instead of a MapReduce program, it will run faster than MapReduce. Apache thought, okay, let's try that. It became an Apache top level project. Okay. From there, everything changed. From 2012, so actually Spark is quite new, because it became widely popular somewhere around 2015 only. And I started using Spark from 2016 only. This is me. This is the world. Right? So I'm like good, right? Because it became popular somewhere in 15. In 16, I started using Spark. Okay. And even in 2016, there were very less trainings in Spark, because people were like excited, but nobody knew what is Spark. So we started using in 2016. All of a sudden, end of like December 2016, it became the most active Apache project in the history. And in 2018, 17, 18, now this is the biggest contributed Apache project. So in a span of 2-3 years, it gained a lot of popularity, right? And now Spark is, like I said, the most popular Apache project so far. So Apache has around 300 plus projects. In that, the number one is Spark as of now, right? Also, originally there was a Spark version 0. Then we got a Spark version 1. Now we are in Spark version 2.3. This is the latest version. And many companies run something called Spark 1.6. This is very stable. It's a very stable version. That is the reason they run it, probably. I don't know, right? After 1.6, you have 2.0. There is no 1.7. After 1.6, the next Spark version is major release 2.0. Okay. And we are on 2.3 right now. If you go to the Spark website, it will say we are on 2.3 currently. 2.3 is not pretty stable because it's the latest version, so not so stable. But 2.1, 2.2, they are very, very stable actually. And we are learning Spark 2. We are not learning Spark 1. You are not missing anything, because in Spark 2 you have some improvements and all the features of 1 are available in 2. So that part is covered. And in most of the trainings, they will request you please start with Spark 2. Don't start with Spark 1. Meaning it's not so old, but people want to start with Spark 2. So the major version right now is 2 or 2.3, I can say, and that we are using. And something else happened. So what actually made Spark more popular is that in 2012, these guys, the founders of Spark, there is 2 guys, they gave to Apache and said that take Spark and go. But they were not so happy. So what these guys did parallelly, they found a company called Databricks. So the founders of Spark, they gave it to Apache because it became open source, obviously. But they also want to make money, right? So it is open source, you can't make money. So if you give something to Apache, you are actually contributing to the world, probably like for the good scenario. If I don't give it to Apache, like Microsoft Windows is not available with Apache, right? So it's only money making. And so you are not getting any chance to modify anything or add your contributions or anything if it is not in Apache. The only contributions for commercial versions are done by the company. So the growth will be limited. Very simple. The growth will be limited. Like you will have your own developers who can modify and all, but others will not be allowed. So when it went to Apache, now what happened is that Apache has a Spark version, Apache Spark, that anybody can download. That is 100% free open source. Again, the Spark is available with Cloudera, Hortonworks, MapR. Sure, that we know. So we are using a Cloudera cluster that has Spark installed. So that is again same Spark only, we can use it. But these guys in 2012 found this Databricks, company, and their sole purpose is to sell Spark, nothing else. But this company is so special because it is created by the founders of Spark. The people who actually wrote the source code found this company. So if I want only Spark, I can probably go to these guys because they are the best. But people don't go here, people go to Cloudera or Hortonworks because chances are very rare you want only Spark. You want other tools also like Scoop you want, Flume you want. Now Databricks has nothing to do with Scoop or Flume. They have only Spark, right? Now, one of the participants asked this question. I'll get back to that in a moment, but still, Spark is an independent project, which means it does not require Hadoop. But mostly you will see it on top of Hadoop. Okay, Spark is actually an independent project, which means I can download Spark. I have Spark running on my Windows 10 laptop. Beautifully works. Doesn't require anything, right? NTFS file system. It will work. Okay. So, but people don't do it because the point is, like right now we have a migration happening in GE. So I was with GE last week before coming here. So there we have a migration happening. GE is migrating to Spark and Hadoop, right? So GE already has a Hadoop cluster. So why should they install Spark separately, right? So they are already having a Hadoop cluster. So they will install Spark on top of Hadoop as an ecosystem tool. So it will start leveraging HDFS for storage and then processing and all. So most of the times you will see Spark on top of Hadoop. But that does not mean it will run only on top of Hadoop. You can run it anywhere practically. And I will show you in the slides wherever you can run, however you can run, so on and so forth. So Databricks is popular in that case, and it is available almost everywhere, right? So I think we'll run some slides to get you an idea. And disclaimer, these slides are from Databricks. So some of them will be their marketing slides. The best resource to learn Spark. Okay, so a couple of things which I know I can teach you, right? A lot of people ask like, give me the best book to learn Spark. And I suggest one book, then they will never come back to me. So the best book to learn Spark is something called Spark, the Definitive Guide. Don't buy it, don't read it. Just make a note. Spark, the Definitive Guide. This is the best book. Don't even touch it. Why I'm saying this? Okay, you can probably buy, I don't mind. This is written by Zetay Maharia and the founder of Spark. The guy who wrote the source code wrote the book. And the book is pretty much like the source code. You won't understand anything. Even I don't understand half of the book. But very good. So buy it and keep it. So people ask, then you can show this is a Spark book, right? Very difficult to understand. But it has like accurate information because the guy who wrote Spark is writing this book, right? So if you read about it as RDD, he will go to any level to explain what it is. So it's a bit difficult to understand. Probably don't read it immediately. Once you complete the Spark class and do some assignments, then you start with this book, it will give you a very good idea to read. There are some other books related to Spark available. I forgot the name, but Learning Spark, right? That is good. Learning Spark is easy. This is very tough actually. Okay, this is version 2. These guys also wrote the same Spark Definitive Guide for Spark version 1, which was very easy actually. This is a bit tough. I don't know. So this is one place where you can. Second is the documentation from Apache and Databricks. This is where I learn actually. So you open Apache documentation, you open Databricks documentation, they will give you a lot of ideas. I mean, basics at least if you want to learn, right? Okay, so that's Learning Spark. So book you can keep. I think it is not available in India. Did anybody try buying it? Is there? It was not there before. It is there. Flipkart. Spark, the Definitive Guide. Amazon also. This is the Matej Zaharia and Bill Chambers. These are the people who wrote Spark. Okay. So it's good. I mean, I'm not against this, but try if you want. You can get how much it is in Flipkart? It is costly, right? PDF you can download. So this is Paperback 2018, actually, right? So it was latest edition it is, right? and basic operations, and a lot of things are there. Hadoop, there are two books actually. Maybe there are new books better. One is Hadoop, the Definitive Guide. Then there is one more book, right, for Hadoop. One is Hadoop, the Definitive Guide. This is Spark, the Definitive Guide. You also have for Hadoop, Hadoop, the Definitive Guide. Then there is one more good book for Hadoop. Hadoop in Action, I think. That's also a good book. Okay. Hadoop books are a bit more easy to understand in the sense like this Spark book is more oriented on the source code side, like how exactly stuff work. Hadoop books are a bit more easy. This is the slide which you need to understand if you want to learn Spark, right? And this slide is very important also if you really want to learn Spark. Why it is important? So somewhere in 2004, Hadoop came. That's what the year there. And with Hadoop, you got something called MapReduce. You know what is MapReduce. I don't have to teach, right? Till 2015, I can say, you can see 2007 till 2015, what happened was that one of the problems with Hadoop was that you have MapReduce. Fine, no problem. But what MapReduce does is batch processing. It is slow and it does batch processing. So people wanted to try different type of workloads in Hadoop. So some of them wanted to write SQL queries on top of Hadoop. That is where you got Hive. Then we got Impala. Then we got Presto. Now here you have Drill and many tools. So around 10 plus different SQL tools are there which can explore the data in Hadoop. And some other people wanted machine learning to be done on top of Hadoop. So if you, in the earlier versions before Spark, when people want to do machine learning, they use something called Mahout, Apache Mahout. Here you can see Mahout somewhere, here. This is your machine learning library. But what is the problem? Machine learning is what? Okay, you guys can teach me, right? Machine learning is all about what? You are all sitting. Huh? Fine. It is about iteration. What do you mean by iteration? Like you are taking the same data and iterating over and over again, right? One of the things which MapReduce cannot do is iteration. Because if you write a MapReduce program, the mapper will run, producer will run, it will push the data to hard disk. Again, the second iteration, again you have to read it. So when Mahout was doing machine learning, the problem was that it was very slow because internally it uses MapReduce on top of Hadoop. So Mahout came, but this became your machine learning tool. Okay, and so interactive we covered. For graph processing, we got GraphLag, Pregel. So these are the tools which you use for graph processing on Hadoop. Traditional Hadoop, no Spark or nothing. Then people wanted to do streaming data analysis, real-time data. That is where you got Storm, right? So you see the problem, right? Over the period of 8 to 10 years, people started developing different tools to handle different workload. So if today I go to a Hadoop system and if I am very new to Hadoop and if I ask somebody what tool I should learn, then he will be confused because all these things you have to learn, Pig, Hive, Mahout, everything to start working with Hadoop. Another problem is if let's say one fine day you start learning Storm. Storm is real-time processing. You have to first learn Storm's API, Storm's language. Then you have to install it on top of Hadoop. You should learn the integration, then only it starts working. So learning all these different tools actually became a problem, okay? And what happened in 2014 when Spark came, the biggest USP of Spark is that it is a unified processing engine. What these 50 plus tools on Hadoop are doing, Spark alone can do. That is the real advantage of Spark. Now many people confuse here, because if you go to anybody and ask like why somebody should learn Spark, they will say because it is faster. Now speed is a byproduct of Spark. It is faster, I know, but the real reason why people are migrating to Spark is that all these tools, whatever they are doing, Spark alone can do. So you don't have to learn like hundreds of tools. You learn one tool, one language, and you can do everything. But you need to have some basic idea about what you're going to do. For example, if you want to do machine learning, Spark has something called MLlib. machine learning library. That will allow you to do machine learning. But you should know what is machine learning, then only you can do. Otherwise, you cannot explore it. But I don't have to install 10 tools or 20 tools. Spark alone can do it. So the primary reason why people are going for Spark is this general unified engine. In my experience, the second reason is speed. Obviously, it is faster. I will tell you why it is faster, how it is faster and all. The third reason is ease of programming. Like, you know Python now. So you can get started with Python in Spark. The language is Python. And if you want to write SQL queries or streaming or machine learning, for everything you can use Python in Spark. That is not the case in the traditional world. Pig uses a different language, Storm uses a different language. So every tool here actually uses a different language. Even for graph processing in Spark, you can use Python, normal Python. So ease of programming is another thing. Because I have struggled a lot, because I have worked a couple of these tools. I have worked as part of the project. And then the major problem is that you will take some 3-4 months to learn the tool first. Then when you come back, that tool will be obsolete. They'll say, go and learn some other tool. So with Spark, that gap is gone. So that is why every company want to migrate to Spark. No, he is asking, in Spark, so there is something called streaming. We will come to that. Streaming data means you want to process real-time data. Say I gave you an example, right? So let's say credit card fraud detection. I swipe my credit card and that has to be immediately captured by some system and it has to say whether it is fraud or not. This is real time, right? Now to implement this, one solution I have is Spark streaming. In Spark, I can do it, okay? But Spark does something called micro batching, meaning it is not able to capture a single swipe as it is. It will collect 1 second worth data. So I cannot go below 1 second, 1 second worth data. But if I'm using something like Storm, it can even pick one swipe in that microsecond and say there is a swipe. But I'm saying that is not so important. 1 second worth delay you can suffer at least. Still you can manage with Spark most of the cases. But yes, Spark supports streaming. So in this and this Pregel, Giraffe, these guys are gone. So graph processing is totally gone. We have Spark for that. Most of the Mahout is gone, I told you, right? Tez is there, soon will be gone. Almost soon will be gone because Tez is middle of MapReduce and Spark. What Tez does, it makes your MapReduce faster. That is what Tez does basically. So Spark makes it more faster. So it is in the middle. So almost it will be gone in a couple of years. Hortonworks is the company who's promoting Tez. So probably they'll keep it because they want market share, right? That is the reason. Okay, let's see what is Spark, right? So in Spark, you have scheduling, monitoring, and distributing. I will show you this practically. And I like this diagram a lot because this will show you the Spark architecture in a very nice way, actually. So how does it look to you? Like if you look at this diagram, what do you think it is? Everybody is saying it is solar system. So the point is, at the core, you have Spark. So when you download Spark, you get something called Spark Core, okay? And that is the lowest layer of abstraction in Spark where you can start programming directly. And I will show you what to do there. And you see there is a RAM and hard disk picture which came up, which means Spark can use both RAM and hard disk. And I'll tell you why this is very important later. Usually other systems can also use. And these are the 4 languages currently supported in Spark core programming. So this is Scala, this icon is Scala, this is Python, R and Java. As of now in 2.3.0, only 4 languages are supported. So you should either learn any of this. And you already know Python, so it makes sense you can continue with Python. I teach Spark with Scala. That is also a very... the source code of Spark is actually written in Scala. That is the reason some of the folks want to learn Scala and do it. But now, so earlier in Spark 1.6 version and all, if you write a Python code, it was slower. There is one thing you have to understand. If you are in Spark 1.6 and if you write your Spark code in Python, it will be slow. And Scala code will be twice faster. It was like that because they didn't do any optimization. Java also slow, slower than Scala. Fastest one was Scala at that point in time.
Both Scala and Java runs in the same JVM, right?
Correct. Still, it will be a bit slow because they didn't implement the certain libraries that were related to Java to support the optimizations in Java. So this is only in 1.6, and 1.6 is very rare. In Spark 2, what they have written, they have written an abstraction layer so that you write the code in any of these languages, your program will run at the same speed. So it doesn't matter you write in Python or Scala or Java, everything will be same. So as of now, we don't have to worry about it. SQL is also there, but SQL is not a language as such. I mean, you can also write queries and all using SQL. Okay, go for one more orbit. Yeah. So these are so you will be thinking that if Spark is able to do everything, right, how it is able to do it. So these are the libraries available in Spark. Meaning, when you download Spark, you get something called Core Spark. Fine. And that is like MapReduce. You can write. But maybe I'm not a core programmer. I know only SQL. I want to write SQL. You use something called Spark SQL. In Spark SQL, very much like Hive and all, you can create tables, and there's something called data frame. Okay, you can create them and query the data. And the good news is they integrated Spark SQL with Hive by default. So what will happen in a Hadoop cluster, if you install Spark, okay, and if I open Spark SQL, I can read the data from my Hive table. So previously, when you are running queries in Hive, it is very, very slow. Now the same tables you can read in Spark SQL and then query. So these days, Hive is just used as a storage. Most of the processing will be done by your Spark SQL because it is faster ideally, right? Another library is MLlib. This is what I was saying, your machine learning libraries. So whatever you are learning, you can implement here. I don't think deep learning and all are supported because for deep learning and all, you will be using TensorFlow. Do you have deep learning in syllabus? Yeah? Now by default, it will not come, I'm saying. You have to download and import it separately, I think. Third party. But your regression and all, like normal stuff, right? They are all supported by default. So what algorithms you learned so far?
Only one.
Which one?
Regression. Linear.
Only regression. So no naive Bayes and decision trees and blah, blah, blah. Okay. So they are all coming in MLlib anyway. And graphics is a framework where you can represent your data using a graph. Have you ever done graph processing? No, right? I have done. Okay. Because why this is important? If you have studied engineering, computer science, you could have learned graph theory, right? I mean, I have learned, I don't know, it was there in your syllabus. There is something called graph theory. So there you have some stuff like you have edges and relations, you have to define like this, right? So this will be me, this will be you, this will be you1. And then you write relations between them. Like I like you probably, you don't like me, so you like someone else. Like this. So, I mean, you have property graphs where you have an edges, okay, which represent some property, and then you have relations between them, okay, and then you can query the structure. So for some type of, we partially work with a social media company in one of our projects, not like Facebook and all, they were a startup actually. Their entire data was like this. Even Facebook, right? If you download the data from Facebook, it's very difficult to do it. Okay, you can't directly do it, but there is a way to get the data. Data means all the publicly available data. They will give you in the graph API format. The format in which the data comes is graph. It doesn't come in JSON or XML, it's graph API format. Because Facebook is actually using this graph structure to store. Not the Spark graph. I think they have their own some system, but the representation is in the form of a graph actually. So many times this is required, this graph representation of data. And Spark can do this graphics library, which can represent your data. And then streaming data. Streaming data is where I was saying you have real-time data coming in and you want to process it real-time and then make a decision based on that. Yeah, so some of the queries, if you write like this, it will be much more efficient. The multi-relational queries. Say, for example, this guy like this guy, this guy. So if you want to find out patterns and relations, representation using graph is easy. in some cases. Let me give you another example. This airport data we had. If you're having airports and flight data, right? So let's say I represent airports like this, Bangalore, Chennai, I don't know, USA, somewhere, right? And if I represent all the flights which are going in, you know, I can do this using SQL also, but the graph queries will be much, much more faster for me because this directory structure, right? The graph structure is able, it is easy to traverse in the graph API. So probably between two airports, you have like thousands of flights currently flying. So you want to query them and track something. So always for airport data, we use graph type of a system rather than SQL will work, but it will be slower if the data is really high. Even Spark SQL will be slower. So there's airport management, right? How many flights are flying in real time and so on and so forth. They use this graph API a lot. So only for certain use cases where you are having, let's say, two edges and lot of relations between them. Social media is another example, right? So I want to find out what you like in Facebook, let's say. So I have to do a lot of comparison. How many friends you have and what your friends actually like. Do you actually like that? So traversing these queries in SQL is very difficult. In graph, I can easily traverse. I can just say that these nodes find me these type of relation. It'll easily tell me. So social media companies do use a lot of graphics actually. Even Twitter use. Twitter, how many people are you following and how many were followed by you? So these relations, right? These are all learned from graph APIs in Twitter. We will not go to graph. So, and there is a NoSQL, this is different, okay. There is a NoSQL database called Neo4j. Neo4j. It's a NoSQL database. They store data in graph format. So, I mean, that is a different use case. That is for real-time queries and all. But this company actually uses only graph to store the data. Okay. Graphics is different. That comes part of Spark. Neo4j is a NoSQL database. I had worked in a small project where they were using Neo4j. I didn't learn it actually, but I've seen that people are actually using it. Okay, what do you, some of you might understand, but some of you may not understand. So we went one circle further, right? So we are in one more orbit. Okay. Now, let me ask you, what do you make out of this? Who is this? No. Is there anything special about this picture? Fine. I mean, so what is this? Flamingo. Okay. What is the flamingo doing? Waiting for who? Be creative, right? So what is the flamingo doing?
Standing on one leg.
Yeah, you are very creative. Exactly. This is called standalone mode of Spark. I didn't create this slide. It is Databricks slide. So if you have to blame them. Exactly. Flamingo is standing in one leg, right? So you have to be more creative, okay, for learning Spark. So these are different modes in which you can run Spark, basically. Okay. So don't get confused with the name. So the top one, this single PC, that is called local. Local mode means you are running it locally on one machine. Okay. You cannot expand to more than one machine. And you use only for development and testing purpose. And that's understood. This mode is Mesos, M. This is the icon of Mesos. So originally Spark was created on top of Mesos. I told you, right? So still, if you want, you can install a Mesos cluster, right? And then install Spark on top of that. It will run. No problem, right? And this is standalone mode. So what is standalone mode? I want to install Spark in a cluster, but I don't have Yarn, I don't have Mesos, I don't have anything. Then Spark give you its own cluster manager. That's called standalone. But this is very rare because ideally it will be on Yarn. And this is Yarn, Spark on Yarn. This is Yarn. So ideally in most cases what you see is Yarn, this blue ball. I mean that is Yarn. Because most of the organizations will already have a Hadoop cluster and Yarn. And it just makes sense to integrate Spark on top of that. Another very important point, a lot of people get confused. That is why I'm writing it. Spark has no storage. There is nothing called storage in Spark. because it is an execution engine. Like MapReduce. Is MapReduce having any storage? No. It reads the data from Hadoop, process it, then probably store it back in Hadoop, right? Similar to that, Spark also has no storage. There is no storage component in Spark. It is just an execution engine, which means you should provide the data somewhere. So if you are running Spark on Hadoop, the data is on HDFS. If you're running Spark on, let's say, your PC file system has the data, standalone or Mesos, whichever, up to you to decide. Okay, if you're interested, some extra knowledge, Spark can also run on Kubernetes. Spark on Kubernetes is, I think, production ready now. You know what is Kubernetes? So, okay, for those who don't know, probably these things might be useful in future because Kubernetes are actually running somewhere. So, you have something called Docker, right? There is something called Docker. This is a very old tool. Very old, like 4 or 5 years, I think, I don't know. What Docker allows you to do, you know what is a virtual machine, right? You know what is a VM. So in your laptop, if you create a VM, what will happen? Let's say I install a Windows VM. The problem is that this VM will use a lot of resources, right? Operating system, you have to install everything. So if my laptop has 8 GB RAM, I need to give 4 GB RAM only for the VM. What Docker does, it allows you to create something called a container. Okay, meaning on one laptop, I can run like 10 Docker containers, one Linux, one Windows. It will use the libraries that are already available on my base operating system. So it will not install a full operating system. That's what I'm saying. So instead of giving 4 GB RAM to a VM, I can give 1 GB to a Docker or 512 MB to a Docker. And if it is on Linux, it is much, much good performance. So Docker became a big hit because if you are a programmer, you wrote a Java program, you want to test it. You want to test it on Apple, you want to test it on Linux, Windows. How do you do all of this, right? So you can just launch Docker containers on your PC itself, like 10 of them, run your code, see whether it is working. Very easy, right? Kubernetes is the next level of Docker, where you have something called container orchestration. In a data center, you are able to run multiple containers like Docker containers. You can manage all of them using Kubernetes. If I am correct, it is a Google project. Okay, so it is a data center orchestration. So Docker is like you are running it on one machine, probably 10 machines max. So here, once you install Kubernetes, it becomes a data center manager actually. So you can give like hundreds and thousands of servers to Kubernetes and say that I want these many containers, Docker-like containers. It will launch them and manage them for you. So Kubernetes can become one of this. Instead of Yarn or Mesos or this thing, Kubernetes can become your resource manager. I can install Spark and then I can say that I want to run Spark program. If I say hit enter, it will go to Kubernetes. It will launch containers for me to run the Spark code. Docker containers. Yeah, cloud. Cloud, everything is available on cloud. Cloud, everything supports. So in cloud, you have multiple options. Either you can directly run, say I go to Amazon, I create some machines myself, or I can use these services like EMR, Elastic MapReduce. I can go to Amazon and say that, hey Amazon, I need you to create a Spark cluster for me. Say 10 machines, 100 machines. In 5 minutes, it will create and give it to me. And then I can run all my workload. But these are like disposable clusters. Once you complete your job, you have to delete them. Otherwise, you're paying money continuously, right? So, Kubernetes is on the cloud also. I mean, it is local data center as well as cloud. So it is available everywhere. I don't know. I have not extensively gone to Kubernetes, but I think you can search because it is something which is coming up in a big way. I think Google is the Kubernetes, whatever you call it. So this is production grade container orchestration. So the problem with your Docker and all is that it is very difficult to manage the containers. With Kubernetes, you can manage them. Like, it is a cloud only. I don't know the exact architecture of Kubernetes, like whether they launch their own container or Docker container. But basically, So it is all coming to an abstraction now. Previously, everything was very clear. For example, you buy a server and you can see the hard disk, right? Then you install the operating system. Now what Kubernetes says that give me a data center, you don't worry.
Data center means
Group of servers. Give me a group of servers like a data center and I will launch as many resources as you want. You just tell me how many containers you want. I will ensure from where I need to launch, how I need to launch. So like, same like that. So like an abstraction it is getting, right? So, but probably, so it says, Kubernetes built upon 15 years of experience of running production workloads at Google. Yeah. So originally this came from Google. Google was already running this. Not in this name, some other name. So they now, even Hadoop came from Google, right? So same like that, they are creating this Kubernetes. I think Spark on Kubernetes is available. That is why I was speaking about this. Spark on Kubernetes. Yeah, very much available. Spark 2.2.0. You must have a running Kubernetes cluster, blah, blah, blah. It is Docker only, okay? Docker images, see? So internally it is using Docker only, nothing else. Blah, blah, blah. Yeah, so it is supported. So it is not in the slide, that's why I'm saying. In the slide, you don't see Kubernetes. Slide is a bit older. And if you pay attention to the slide, I can show you one small change. You have to tell me what is the change, okay, if you pay attention. Did you see? There is some change in the slide. What is the change? No. Somebody is on top of this, right? That is Zookeeper. Zookeeper. Oh, you didn't say, I'll show you once more. See, it's gone. Now it will come up. You saw that? So what it technically means is that all these three modes, whether you are running on standalone or Mesos or Yarn, can be highly available using Zookeeper. Zookeeper supports your high availability. If you, like Spark, if you are running, if one machine crashes or if all these states are maintained by Zookeeper. So Zookeeper is integrated with Spark. Zookeeper is another Hadoop ecosystem tool. Why it is used is for communication between the machines actually, to put it very simply. Like in a very large cluster, if one machine goes down, then how do you know? No, it's not like a load balancer. How can I explain? So I'll give you a simple example, otherwise Zookeeper might become another big problem, right? And Zookeeper is an admin thing mostly, so you don't have to worry about it too much, but still. Do you remember I told you can have a active name node and standby name node, right? So in a Hadoop cluster, you have two name nodes, right? This is active. This is standby. Correct? Now what is the idea? Only one should be working. Only active. If the active crashes, this question, who will tell this? That's the question. Let's say I am connecting to the cluster. How do I know who is active? I can't connect to two machines, right? So this guy will have an IP address. This guy will have an IP address. One way is that I can keep on pinging who is active currently. How do I know who is active? Who will tell me, right? There is nobody to tell. So one way is that I can keep on pinging both the machines to see who is alive, who is not alive. So like that, there are many situations in which you have to understand which machine is alive or not alive. So with Zookeeper, what happens is very simple. It is a service. So this active name node will register with Zookeeper. Okay. Standby will also register with Zookeeper. Now you just ask Zookeeper who is active. It will tell this is active. If this guy crashes, okay, this guy will inform Zookeeper that I am the new active. You again ask Zookeeper, Zookeeper will tell you. So it's a coordination mechanism. Zookeeper is used for coordination and high availability. What this slide means is that Spark supports Zookeeper. So for talking between the machines and management and all, it can use Zookeeper if possible, if available, right? So this is the icon of Zookeeper. It didn't just come. This is the actual icon of Zookeeper. You are asking, I know, because normally people are not much aware of Zookeeper. No. It is for all the services actually. Let me show you. So Zookeeper is for any service to coordinate. So one example I gave you is that how do you know name node is working? Ideally, this will not automatically come up. The Zookeeper has to inform this guy to come up. If you look at the architecture, okay, if you implement high availability in Hadoop, normally what happens if I don't have Zookeeper, if this guy goes down, I have to write a command to make this up. That is actually a wastage of time, right? It should automatically come up. So these guys will be connected with Zookeeper and there will be a keep alive message sent. So if, heartbeat. So if this guy goes down, Zookeeper will know that this guy is gone. After let's say a second or two, there is a timer you can configure. It will ask this guy, come up, okay, and update the metadata here. So basically this guy holds metadata, who is doing what in the cluster. Otherwise you see there are a lot of services in a Hadoop cluster where there is an active and standby. Not only name node, resource manager, your yarn resource manager is an active and standby. If you take HBase, there is a service called NoSQL. HBase has a master and standby. So if I go to a Hadoop cluster, if I start asking everybody who is the master, who is the slave, it's very difficult. So I go to Zookeeper and this guy will have all this knowledge. Even for Spark, you have an active and standby master, okay, if you're installing Spark independently, and that can be coordinated with Zookeeper. That is what the slide is saying. So Zookeeper by default will be available in most of the clusters. We again went back. Now what? So this orbit is over. Spark can read from almost any file system, and that's by default. HDFS, I don't know what is this cube, by the way. This I don't know. This is S3, Amazon. This is local file system. That is some other file system, maybe. In any file system, basically. So it supports a lot of file systems even which we are not aware of, right? Local file systems. It can read from all these things, any NoSQL database, any RDBMS. That is, I think, a very cool feature because I will show you if you have a MySQL DB, Spark can directly read from the table. Or if you have MongoDB or any NoSQL database, it can read from the table and process the data. Output probably it can store back it into that table, right? It also supports Hadoop input formats. Spark streaming can work with Flume and Kafka. Meaning you are doing real-time streaming, right? So the question is that how do you get the data? So this is always a challenge because what happens is that normally you will have a Spark cluster running. So let's say this is a Spark cluster. Hadoop cluster only where you have Spark installed. So let's say you have a Spark cluster running. I want to get Twitter data. So actually Spark can directly get the Twitter data. There is no problem. It can directly come to the cluster and you can process it. But the problem is if one of the machine who is receiving this data crashes, you will lose the data for some time, right, in Spark. So what you can do in this architecture is that for high availability, you can either use Flume or Kafka. So you can ask these guys to get the data for you. Flume or Kafka. So Flume is point-to-point delivery of data. Like I can configure a Flume agent, we will see in the webinar, which can get the data from Twitter to here. Kafka is a message queue. So you can get the data from here. So even if your machines are not working, data will come here, right? You are not losing the data. So for that reliability, you are using a Flume and Kafka. If you have a Spark cluster, right? So this is a Spark cluster. And I'm talking only about Spark streaming, okay? Not like normal processing. When you configure Spark streaming, one of the machine will start working as something called a receiver. Okay? So what is this machine's job? To get the data. That's all it cares. And it is a normal data node. Now, the drawback of Spark streaming, not the drawback, I can say, if this machine crashes, okay, your stream will be lost. Of course, it will switch to another machine, but it may take some time. So that, let's say 5 seconds or 10 seconds, you are losing the data, right? You are not storing it anywhere. Correct. So if I want to avoid this, if this machine goes down, then my stream will be gone. If I want to avoid this, what I can do, I can say Kafka, hey, get the data in Kafka. Okay, from there I'll get it to Spark. Even if this machine crashes, another machine will come up, the data will be available here. So Spark streaming, if you want reliability, you have to use Kafka or Flume. Direct stream, you may not have reliability. Okay, so if we are covering Spark streaming, probably in that architecture side, I will speak. The distributions we already know. And these are some statistics, and I think you should be aware of it. Developers from 500 plus companies, you have 3,000 developers, and etc., right? This is a slide. Some of you are asking, will some of the tools go extinct? Yes. Your Hive, now nobody is running a lot of Hive queries. Everything is Spark SQL queries these days. And Mahout for machine learning, everybody has migrated to Spark MLlib. Storm, most of them are in Spark streaming now. And this slide just compares the different ways in you can run Spark. For example, instead of MapReduce, now most of us are using Spark. The resource manager can be Yarn or Mesos. Doesn't matter, any of this. And the storage level in Hadoop is HDFS. This Tachyon is not there now. Tachyon was a storage manager like in 2009, long back. When originally Mesos came, the storage was handled by a system called Tachyon. Now this is renamed as Alucio, this project. It is still there. It is a storage layer like HDFS only, distributed storage you can get. So one common problem in Spark is that you will try to bring the data from different places. Like Spark will be running on Hadoop, but maybe some of your data is in Hadoop, some of them is in DBMS, some of them is in Cassandra. So if you use normal HDFS, it's fine. If you are using this Tachyon, or now it is known as Alucio, it has a caching layer. So it can speed up your processing by caching the data. That is only advantage. Not extensively used because setting it up and all are a mess actually. Okay, I have seen it once. That time it was called Tachyon only, not Alucio. I think they renamed it. If my memory serves me well, Tachyon is Alucio now. Spelling I have to look into. Alucio or Aluxio, whatever you call it. I don't know. Aluxio, formerly Tachyon. Open source, memory, speed, virtual distributed storage. I don't know how many technologies are there, so many other actually. This is like, so let's say you have tons of data and you need a storage layer in between, caching layer to make it faster, then you use Alucio. That is only use case. Otherwise, everybody is using HDFS only, normal HDFS. In SSD caching it will do. So it is costly also, it is costly but faster. But only use case is that if you are processing a huge amount of data, like we had like Bank of America. Bank of America, they had like tons and tons of data to process, like terabytes of data. And it keeps on coming. So storing them on HDFS, first time read will be very slow. Anyway, will be very slow. So they push directly to your this thing, Alucio, because that's an SSD caching layer. From there, they read it. So the read is faster actually. That is only use case you are seeing for Alucio. And this is another use case of it, right? You have on-premise storage and cloud storage, and you're getting the data. It comes to an Alucio layer. From there, you can start your computing. So it is a storage layer abstraction. You can store data in multiple places, okay? And Alucio will get it in one place. From there, you can start processing. So it is like bringing the data into a caching layer and then processing it, okay? Don't worry, if you don't know Alucio also, it's perfectly fine. It's not like a mandatory component or something. Okay, now can you tell me what is a drawback of MapReduce, if there is any drawback? What do you think? So Spark is replacing MapReduce, right? So what is a drawback of MapReduce that you saw? Yeah, so mapper output you persist, then shuffle output you persist, then of course reducer output you have to finally persist, right? So that is why MapReduce is very, very slow. So that is what is in the slide actually written. So, and if I have to do an iterative processing, right? I read the data and 10 times I have to process it. then I have to schedule the jobs. 10 MapReduce jobs I have to run because it is very difficult to chain them together. Intermediate read and write always will be there, right? That is where Spark becomes very different because, and this slide just says that you can use Uzi to schedule all these jobs, nothing else. Spark does something called in-memory processing. And this is very confusing for many people. The first thing you need to understand is that in-memory processing means it will use RAM if available. It doesn't mean that you always need to give RAM. If RAM is provided, so let's say you want to process 10 GB file. And if your cluster has 10 GB free RAM, it will read it into the RAM and it will do all the calculation. Only the final output, it will push it into your hard disk. Intermediate results are not stored onto hard disk. Second point is that it will, what if RAM is not available? Then it will start using hard disk also. Step by step it will read. It will read whatever data that fits into the RAM, process it, then again it will read it and process it. Like that it has to go. There is no other way, right? If you don't have RAM, still it is faster than MapReduce. Okay, because from ground up they have designed the code of Spark. They have not modified MapReduce code or something to create Spark. And that is why here it says 10 to 100 times faster than MapReduce, typical MapReduce, right? So in-memory processing, we will see how it is faster and all. That end is Cassandra, that I, there is Cassandra. It just demonstrates that you can store the result in Cassandra. From anywhere you can read and store also. These are the distributors and applications which uses Spark. So of course, Databricks is the major distributor, and Hortonworks, Cloudera, all these guys are having, Spark as of now. And these all applications can use Spark for processing. So mostly BI tools and all, right? Visualization tools. So previously, if I'm using something like, where is it? Pentaho BI, okay, to visualize my data, what it will do, it will fire a query to my Hadoop cluster. Hive will run the query and visualize it. And now Spark SQL will run the query. So it's much, much faster. So all the BI tools and the ETL tools now use Spark for moving the data and processing the data and so on and so forth. This slide is a bit old. This is the 100 terabyte sort competition in 2014. So every year there is a sorting competition that will happen. Even you can participate if you want. So the thing is that they will give you 1 terabyte of data. Okay, you have to sort it. Okay, and the data, they will already give you the format and all based on how you have to sort it. Is it integer sorting or quick sort or what sort? They will tell you. They'll already give you the data also, sample data, and you have to write an algorithm to sort. Can be a Java program, any program you can write, and whoever sorts the data fastest will win. That is the conclusion. And in 2014, when this ran, Spark did it in 23 minutes, Hadoop in MapReduce in 72 minutes. But look at the cluster size. Spark was running on 206 machines. MapReduce was in 2,100 machines. That is a difference. 1/10th of machine, still it is faster. Because a lot of RAM was available, everything was in memory, so faster sorting will happen. And even for 1 petabyte, they did a sorting, and again, Spark became the winner there. Okay? So you are having these notebooks. You know what's a notebook, right? In Python you use, right? So you know what it is. Luckily, I don't have to teach that. So, I mean, the code is actually written in a notebook. Okay? But we will use a shell also, bit understood, because I don't like notebooks personally. Okay? Do you know what is a driver? These are some things you require, otherwise you cannot understand Spark. That's why. What is a driver, you know? Not device driver, okay? Which drives the program. That's actually correct, right? Driver is the guy which... So when you're writing a Spark program, the program will have something called a driver, okay? And this is the master of the program. Driver is the master of the program. And then you have something called executor. This is the slave. So let's say I wrote a Spark program. In the Spark program, definitely there will be a driver and an executor. Without that, the Spark program cannot run. I mean, these are logical concepts I'm saying. Okay. Now, when you want to run that program, okay, one way you can run is that you can say run it locally. I can say that, hey, I wrote a Spark program. Okay, run the program local. When I say local, what will happen is that a JVM will be created, like a JVM. Okay, both my driver, executor, everything will be inside this. So this is the local mode of Spark. Java virtual machine. Still a container will be created similar to this. JVM in a general I'm saying. Okay. So a container will be allocated. So this is like a yarn container. So a container will be allocated. In that both your driver and executor will run. So the local mode is not very efficient because you will get only one container and everything is running inside that. Right? So if you're submitting the Spark code, actually when you say you have a Python code, right? It will read your logic and will convert and run it inside a JVM. End of the day, everything is inside a JVM only. Without that, it cannot run. Even MapReduce programs, we wrote in Java, right? We can write Python code in MapReduce. So if I'm writing a Python MapReduce program, if I run, I will say submit the program, then I have to mention some jar files. And those jar files will be in Hadoop. They will read your Python code and convert that into a format which will run inside a JVM and execute inside a JVM only. Because end of the day, it is written in Java. Or if it is Spark, it is written in Scala. Right? So everything has to be inside a JVM. So the local mode, the problem is you get only one container. Inside that, the driver and executor, everything will run. Okay. So this is only good for testing purpose. Right? So you just want to test a Spark program or you want to learn Spark. You will normally say that, hey, Spark run in the local mode. I write some code. It just runs. If you are in a cluster, this is where things becomes more interesting. And this is a bit confusing also. Okay. So this is my Hadoop cluster, right? And I have 4 data nodes. Imagine. I have 4 data nodes. Imagine. I created a Spark program. Now the first question is that when you are running the Spark program, what are you analyzing? Okay, I am analyzing a file. What is the size of the file? Right. So let's imagine the file is in Hadoop. Okay, just a simple use case. The file is here, here, and here. Just an example. And somewhere. The total size of the file is, let's say, 10 GB. So I have a 10 GB file in Hadoop. That may be in blocks and all. So that's understood. And I want to process it using Spark. Now, and that is in a cluster, right? So when I submit my program to a cluster, I have to ask Yarn for executors. How many executors you want and what is their capacity? Meaning, I can either say, hey Yarn, give me one executor. And in that executor, 20 GB RAM I want. No problem. What will happen? An executor will come here. This is your executor. It's a container, nothing but a container. And this has, let's say, 20 GB RAM, okay, and some 4 processor core or something. And then your entire Spark code will get executed inside this. But normally people will not do this. This is like one machine is executing everything. So possibly what I will do is that I will ask Yarn, hey Yarn, give me, let's say, 4 executors. Just an example I'm saying. Give me 4 executors. So Yarn will give me 4 executors, right? And each executor, I tell Yarn, give me 5 GB each executor. This is 5 GB, this is 5 GB, this is 5 GB, this is 5 GB. RAM in memory. So total 20, but 5 GB, right? And so imagine there is, and then there is a driver, right? So this is executor. Imagine you have 5 nodes in this Hadoop cluster. So here my driver is running. Okay. So what will happen when you submit the program in one of the machine, the driver will start running. And in the program, you have asked Yarn, give me 4 executors. And each executor I want 5 GB RAM, 2 processor core, blah, blah, blah. So yarn will launch 1, 2, 3, 4 here. And whatever code you have written, this driver will push into all 4 machines at the same time. And each machine will process your code. This is how in a cluster Spark is processing. But this is not so easy as it looks like, because you should know how much memory you need for processing, right? And how many executors you want. Will Yarn actually give you those? I cannot say that give me 100 executors each with 100 GB RAM. Yarn will say that I don't have capacity. I can't give you. So normally wherever I have went for consulting and all, if you write a Spark program, you will discuss with your admin. Okay, I want to write a Spark program, because in Spark, if you want to get the full performance, it should be in memory. You need maximum RAM. And that is a challenge in every Hadoop cluster. So you will go to your Hadoop admin or Spark admin and say that I have written a program. I need 100 GB RAM in the cluster. So he will tell you, in your program, you ask for, let's say, 10 executor, 10 GB each, something like that, right? That you will configure as the number of executor, how much RAM you want, and then you submit your program. So Yarn will launch these things, and the driver will be running on a separate machine, right? And whatever logic you have written, so driver will read and start pushing to all executors. And the output normally comes back to the driver, whatever output you have. In the driver, you can write a logic, either store the output on Hadoop or store it in Cassandra or wherever you want. That is possible. And this driver normally will be your app master. This is your app master. Remember app master from Yarn? That is your driver. So a lot of people ask, what if this machine goes down? My driver machine goes down. Obviously, if your driver machine goes down, then the processing will be disturbed. Now, Spark program will not crash. Okay. In Yarn, you can configure application master restart timer. So restart. So if this machine goes down, it will restart your AM on another machine, application master on another machine, so that it can continue processing. This application master is in constant touch with your resource manager. So there is an ID, application ID, where it will not tell what you have processed or what execution is going on currently. It knows those things. So your resource manager will launch one more application master. That will become your Spark driver. Get the code. It starts running from there. So the driver is the master part of your program, and these executors are where you push your code. So depending on your cluster, you can ask for the number of executors and how much memory you want for each executor. That is how it actually runs. And there is something called application master restart timer. You have to configure in Yarn. There you can say 3, 5. So it will try to restart it, the application master, on the same machine. Sometimes what happens is machine will not crash. Your application master will crash. The driver process will crash. So it will restart it on the same machine. Can be due to many reasons. Maybe the resource not available. So you can configure that timer. And if it doesn't work, then only you'll go to another machine and say start from there. You need to understand something called RDD. Okay, so that is why RDD fundamentals it is written. So RDDs are the basic building blocks of Spark. So first thing you need to understand is that in Spark, your data is represented as something called RDD, right? Any data that you have, if you want to process in Spark, the first step you do is that you create something called an RDD. RDD stands for Resilient Distributed Dataset. It is like a variable or a pointer, you can say, right? So these slides will give you some idea about RDD. I will also practically show what is an RDD. So just look at this picture. This picture is very good in understanding how Spark is working, right? So I have 4 blocks of data in Hadoop. So that is what is represented there. HDFS, right? So 4 blocks of data is there, right? And I want to process them. Now that is one file. Even though it is divided into 4 blocks, it is one single file I want to process. And what is this data? It's some text data. Imagine each block has like this: error, then a timestamp and a message. Again, warning, some timestamp and a message. Some log file, imagine, right? 4 blocks of data. So we are assuming they are on 4 data nodes and you want to process them. Now from here onwards, it is going to confuse you. Okay, so I'm saying in advance, you will get confused. Okay, but don't worry. So where is your original data in hard disk? Right? As blocks in HDFS. So that you have to keep it in your mind. Now, I have already written a program, imagine, to process the data, right? In the program, the first step I need to do is to create an RDD. Okay? So I have to say that create an RDD. An RDD is like a variable, you can say, or a pointer. So here, the name of my RDD is called log lines RDD. You can call it Raghu if you want. I just say create, hey Spark, create something called log lines RDD by reading the data from this file. You can give the location, where is the file. And if I run this, what is going to happen? And imagine in this case, I have asked for 4 executors. In my Spark program, I said, I want 4 executors for some reason. So what will happen in each data node, one executor will be launched in ideal situation, right? And I have one block on each data node. And I say, hey Spark, create an RDD called loglines RDD for me. And if I hit enter, all this data will be copied into the RAM or the main memory. Because RDDs represent your data in memory. Assuming RAM is available, ideal condition. So if I redraw this picture, this is actually a Databricks picture, right? But if I redraw this picture, now don't think that always the file is in Hadoop, right? In my typical example, I have the file in Hadoop. But there is one small thing here. Let's say you have 6 nodes in Hadoop cluster. 1, 2, 3, 4, 5, 6. That is the same architecture. And block 1, 2, 3, 4. Now the big question. You want 4 executors. Which machines will launch the executor? Who is launching the executor? Yarn. Yarn has no data locality awareness, right? Yarn doesn't know where is your data. Right? In MapReduce, data locality is there because your blocks are residing here. Let's say your blocks are here, right? So these are the 4 blocks. I write a MapReduce program. What is going to happen? In my MapReduce framework, it is written that, okay, I need to have 4 mappers. One more very important point you need to remember. In MapReduce, if I'm processing the same data, 4 JVMs will get launched. Correct? 1 here, 1 here, 1 here, 1 here. And this will copy here, this will copy here, this will copy here, this will copy here. That is how your mapper runs. Because can you process 4 blocks using 1 mapper? Not possible. You will have number of mappers equal to number of blocks or number of input splits, we say, right? Ideally, you can say number of mappers equal to 1, but then what is going to happen? This block will process, this will go, then the next block will come and it will process. No, that's not possible. Because the size of this mapper, this container is like 1 GB or the default yarn container size is there. This is your yarn container in MapReduce. So when yarn is launching containers for your mapper, ideally how it launches is that it will launch one container for each block, right? And your block size is fixed at 128 MB, right? So in yarn settings, you will say that my container size is 1 GB. I want 1 GB container, right? And what will happen? 1 GB, 1 GB, 1 GB, 1 GB, 4 containers will be used. It is very rare that manually you mention number of mappers. You can't ideally do that because that will affect your performance. And also, if you are launching 1 container only, you can't resize it. So this is like a 1 GB container. So there is a property called set spark.dynamic execution enable or disable. That is to yarn. So you are telling yarn, I want 8 executors, but don't kill everybody. I may use it or may not use it. So it will keep it for you. If you enable it, that is where it will kill. You are saying that if it is not getting used, just kill them. I don't want them. So if your data size is small, it will kill them. Remember. But coming back to RDDs and our discussion, I am saying that in that example, you have 4 blocks of data. So that is these 4 blocks. My Hadoop cluster is, let's say, 6 nodes. And you want to read this data and process it. So what you say, I want to create an RDD. The name of the RDD is called loglines RDD or whatever. RDD is just like a pointer. Okay. And when you do that, when that code runs, what is going to happen is that you ask for 4 executors also. And let's assume the executors are launched here. So there is an executor here. Okay. There is one more guy here, one more guy here, and one more guy here. So these blocks will be copied to here. So now where is your data? Your data is residing inside the RAM of 4 machines or 4 executors. This is called an RDD. Because otherwise, how do you call it is your data? You need some way to mention like a variable. So that is called your RDD. So now once the data is available in the RAM, let's say now the data is there, you have a representation to your data. So this entire log file is now called log lines RDD. Also, in Spark, there is something called partitions, meaning right now your data is lying as 4 blocks. So we say that this is a 4 partition RDD. So normally when you're reading from Hadoop, you will have blocks. Each block will become a partition. What if you're not reading from Hadoop? Let's say I'm reading from my local PC. I can mention how many partitions I need for the data. Say on my Windows laptop, okay, I have a 1 GB file. If I simply read it, it will come as a single 1 GB partition. Okay. If I want, I can say that, hey, this is in my Windows laptop. Okay. I can say that, hey, Spark, read this 1 GB, but create 4 partitions for me on this. What is the advantage? Each partition can go to an executor. An executor will process a partition, not a file. So always your data has to be partitioned. The more partitions you have, the more parallelism you will get. No, that's just an example. Anyway, in the personal laptop, I cannot launch multiple executors. I'm saying you're reading from a personal laptop and dumping into a Hadoop cluster. Imagine it's not from a Hadoop file system. Or let's say you're reading from Cassandra. A typical example. Cassandra is a NoSQL database. Cassandra doesn't have blocks or anything. Blocks are on Hadoop. So if I get the data from Cassandra, I read a table, I will get 1 million rows, right? 1 million rows, I cannot give it to an executor, right? Then the processing will be very slow. So what I will do, I have to have an idea about my data. Let's say 1 million data is 1 GB or something. I will say that when I'm creating an RDD, I can say that take this data from Cassandra and divide it into 4 partitions. Each partition will go to an executor. An executor can manage more than 1 partition also. Minimum 1 partition it should get. Depending, so let's say I have an executor with 20 GB memory. So let's say a partition size is 1 GB. It can manage 20 partitions. Data locality is not 100% guaranteed when you launch an executor. 100% it is not guaranteed. So is this clear? Because you have to figure out the number of executors. Okay, first thing, that depends on what is the size of your data. So in Hadoop, normally this is not required because in Hadoop, what happens? By default, a block is a partition, right? But again, that will make sense because what is the block size in Hadoop? 128 MB. 128 MB is the block size, right? So I have a file with that is divided into 10 blocks. So total size of the file is this MB, that is 1.2 GB. I want to process 1.2 GB file. Now the question is that how many executors I need. That depends on your cluster configuration. I can even process this in a single executor. I can ask, hey Yarn, give me 1 executor, 2 GB RAM or 3 GB RAM. Just a safe side I'm saying. So Yarn will launch 1 executor, let's say 3 GB RAM, okay? And this has 10 partitions. This file has 10 partitions, 10 blocks. All 10 partitions will come in that single, container, get processed. Copy. Original data is in HDFS anyway.
But it's happening in the same RAM, right?
So in this case, I'm asking for 1 container. So this executor, right? So this executor you are launching, okay. So you can ask how many executors you want. He is not understanding what I'm saying. So this is my Hadoop cluster. That's what, it is not very effective, I'm saying. You can do it, it is not very effective. So the more partitions you have, more processing speed you will get. This same example if you take, so I have 4 partitions, right? 4 executors I launched and each is getting loaded into one partition. This will be faster. I can also launch a single executor here, copy all this 4 here. It may not be so fast. And another very important point. So these are all related to resource management, but you should also understand this stuff, right? An executor is a container, right? A JVM. One processor core is required to manage one container. Meaning, if this is a dual core machine, how many maximum executors you can launch? 2. If you ask for 8 executors, what will happen? It doesn't work. So an executor is a JVM. To manage a JVM, JVM has RAM and CPU. RAM, you can say, I want 8 GB RAM, 10 GB RAM, fine. But within that, to manage, ideally, for a single JVM, 1 processor core will be allocated. Minimum 1 processor core, right? But again, the question, if I have 16 GB RAM, 16 GB RAM for a container, that will have lot of partitions inside that. Maybe 1 CPU core is enough to run all of them. Depends on what is the processing power of your machine. But you have to keep all these things when you're launching a cluster. Performance side, I'm saying. So to put it short, ideally you don't have to do these many things. When you're launching a Spark program, you should know the size of your data and how it should be chunked. Correct. So the idea is, if the number of partitions are more, so let's say I have a file, whatever the size may be, X, the size is X, right? If the number of partitions are more, that means the number of splits are more, ideally. So I'm saying that I want 10 partitions. So I get 10 partitions. Now, if each partition can be inside an executor, 10 executors can process that data. So parallelism you get. But if it is less, let's say I want only 2 partitions, then they are in 2 executors, then 2 executors are, so ideally your this is less, what you say, processing. So the more partitions you have, the more processing power you can get. So if you are loading, let's say, a text file, right? So if I am loading a text file, I can say that create an RDD, number of partition 5. So what, it will equally split that text file into 5 and then give it to one executor. But the point is, you need 5 executors to process it. So if you go to Yarn will say, I don't have enough resource, so I'll give you only 2 executor. So 2 executor will get 5 partition. One guy will get 2, another will get 3. So, and each executor is having 1 CPU core, right? So it will be a bit slow. So if you have enough resources, parallelism works actually better. So usually what we do in the I will redraw this picture so things will become clear to you. I think I just drawed it in one manner only. So my point is, I'll just delete this, okay? Give me one moment. Number of partitions. So that's what I'm saying. If you have a file, this is your file, right? This is your file. And this file is divided into 10 blocks in Hadoop. Okay? So I have what? I won't exactly write it, but let's say 1, 2, 3, 4, 5, 6, up to 10 blocks you have. Okay? Now to answer your question, right? When I read the data into Spark, it will automatically do something called partitioning. And each block will become 1 partition by default. And you cannot change it. Okay? By default, it is 1. And most of the cases, we keep it. But what you can do, so I get, this is 1 block. This is 1 block. So all this is red. So this is my partition 1, partition 2, partition 3, right? This is what? Partition 4. And I have partition 10. Right? Similar to input splits. So you have 10 partition. Now you want to process it. That is where the speed and all matters, right? To process it, what you need? You need RAM, you need CPU power, right? So where this partition will go, this is hard disk. Blocks are where? This is hard disk. Blocks are in your hard disk. When I say I create a partition, partition is in RAM. It won't just sit in the RAM. It has to be inside an executor or a JVM, right? That is where the data should come. Then only the processing should start, right? So then you can decide, I have 10 partitions. Okay, how many executors I need? Can I ask for 10 executors? Yes, you can do. You can say I want 10 executors. Okay, so you will get what? Executor 1, and here you will get executor 10. And each partition will go to an executor. Partitions always go to executor. So this P1 will go to this executor. Now this executor, I have asked for 1 GB RAM for this executor. I also have 1 processor core. That means this partition can be managed by this executor. Same, your P10 will go here. Okay, this executor also have 1 processor and 1 GB RAM. But the point is, your yarn should allow you to give you 10 these things. The same thing I can do in another way. I ask for only 2 executors. Example, okay? I ask for 2 executors. This executor has 5 GB. This executor also have 5 GB. This has 1 processor core. This has 1 processor core. And P1, P2, P3 up to P5 will come here. P6, P7, P10 will come here. Now if you write a program, so let's say I wrote a program, I say filter the data. So my driver is here, right? This is what? My driver. In my driver, I said filter the data. Where is the data? In partition. So this filter is your logic. This logic will be pushed to this executor, and this filter will apply here, 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 here. Who will apply? This processor and RAM together, right? So 1 processor core I have. Using that 1 processor core, can I parallelly run this? Probably. I have multi-threading and all. I can parallelly process this much amount of data. Good. Otherwise, one by one it will process. It will take some time. Depends on how. Yes, your processor core you can increase. You can even say I want 4 cores for the container. When you're launching this executor, I said 1 core by default, right? I can also say, hey, yarn, give me my executor. Each executor requires 4 core. But then the problem is, if this is a quad core data node, only 1 executor can be launched because you already took 4 cores. If you ask 1 more, you will not get, right? If this is a quad core data node, if you launch 1 executor, you cannot launch another executor. Already you have taken 4 cores.
In the same system.
The same system. There is multi-threading. So I think by default it can handle only 2 partitions max. Multi-threading means 2 threads, right? So in production, how we do it is that once we design our application, we look at the data, from where the data is coming. Will it already come partition, or you have to partition? Because if you are reading from Hadoop, it already is partition, like blocks and all. But if you are reading from Cassandra, Cassandra doesn't by default partition the data. So you get like 1 big chunk. So while reading, we decide, should we partition? Yes, we partition. How many? 10. So 10 means what will be the size? This much. So how many executors you need? So then you go to your admin and say that, can I launch a Spark job with this many? Will I be getting? He will say, yes, you will be getting. Then you launch them. Now,
Cassandra is not a HDFS.
no. It is a NoSQL database.
It is out of this.
Out of this, but you can read from there. And you have connectors in Spark where you can read from Cassandra. So are you able to follow what I'm saying? I mean, some of you are like, he is talking Greek and Latin, right? There is also a way where you launch the job default. So if you don't want to mention all this stuff, you just say run my job. So Yarn will figure out the best way to launch. Probably it may not be the fastest way, but it will just execute your program. That is also possible. So now you're thinking that this guy is trying to fool us because he's saying you can ask for 3. I will practically show you 3 executors running by launching. You can actually do this. It's not like some theory stuff. When you're launching a Spark shell, you can go to Yarn, say num executor, executor memory, driver memory, all you can ask. And it will give you those. And you can see them. Okay, I got 3 executor or 4 executor or whatever you want, right? Now, if you have understood this much, I'm going to again confuse you, because if you ask for an executor, right, you say, I want an executor. And how much memory you want executor? You say, I want 10 GB. By default, you get only 90% of it. Okay, because 10% is allocated for system calls. It is a container. It has to accept system calls and respond. So you say 10 GB is full, it will not give you full 10 GB. 10% system will take. So what you get? 9 GB. In this, you will not get. In this, you get only 60%. So ultimately, some 54% of the RAM only you will get. Because it is a JVM, right? There is garbage collection, JVM management. All that requires memory. So in reality, if you look at a Spark cluster, if you ask for 10 GB container, you get around 5.8 GB for RDD. Remaining all system will take. Please keep it in your mind because this is an interview question. So you will go and say, 100 GB RAM I will get. They'll say, no, it will not, boss. So by default, if you ask for 10 GB, 10% system calls will take.
System calls in the sense container.
Container has to communicate with your operating system, right? And yarn. So for these things, it will reserve some memory, right? So from 10 GB, you became 9 GB. In this 9 GB, your JVM has to manage its garbage collection and communication. All this, it will take another, I think, I don't know the exact number, 30% or something it will take. It will drill down to total, I think 54 or 56% of this 10 GB only your RDD memory you will get to actually fit the partition. Which means in 10 GB, you get roughly around 6 GB to fit the partition. So don't think that you get a JVM 10 size, you can fit 10 GB of worth partition. No, it doesn't work like that. So these are actually internal to Spark, but when we run, we will understand. I mean, in production, when we run, because then your calculation will be wrong, right? If you don't understand this, your calculation will be wrong. Okay, so this part, partitions and parallelism. So now if you look at the picture, does it make more sense, this picture? So you have 4 blocks, you ask for 4 containers, 4 partitions, ideal case, each is loaded, and that's called your RDD, right? Now the real question, how do you write a Spark program, right? Basically, that is what you want to do. Apart from RDD or RAM and all, once you get the data, you should analyze the data. So how do I analyze the data? In Python, did you learn something called a higher order function? Function, you know, right? So normally when you write a Python function, you will say function, then function name, blah, blah, blah. That's how def and all, then you write a function. And you will reuse the function. Why are you creating a function? You can call it anytime. There is something called anonymous function or disposable function. Let's say I want to create a function. I will use it only once. I don't want it anymore. So you don't have to really give a name for the function or definite. You can create it on the fly. That is called anonymous function. It's called anonymous function. Anonymous. Okay. In Spark programming, what we do is that we have something called higher order function. There is something called higher order function. What is a higher order function? Let's say I have a function called ABC. I can pass another function to this function. That's called a higher order function. Meaning, this ABC is a function. And normally you will pass some parameter or something, some value, right? You will say A is this, B is this, that is what you send. But I can have a function and I can pass another function to this function. That's called a higher order function. So we will be passing anonymous functions here. This lambda is an anonymous function. I will show you the code, it will become better. But in Spark, basically what we do is that once you create an RDD, now you have the data ready. Your data is, now I want to process the data. How do you process the data? You have something called transformations. So it is actually there in a Spark website. It's also good that you can look at Spark official website. How do you go? Spark.apache.org. Hey, why it is not showing? Yeah, so spark.apache.org is the official website of Spark. And if you go to documentation, it will say latest release is 2.3.0, right? And these are the older versions and all. If you click on here, you can see all the Spark versions. You can see that 163 was the last Spark 1 version. Now we are on 2.3.0. This is our version, I mean latest version. And if you go to documentation, let's say latest release, imagine latest release, okay? If you scroll down, okay, Here you can see RDD programming guide, see? And if you click on this, okay, and scroll down a bit, this we will come back. You can see Resilient Distributed Dataset or RDD. This is what we created, right? So we just created an RDD, at least theoretically. So once you create an RDD, I will show you how to create it, okay? You have RDD operations. So now my data is available as an RDD. What can I do with the RDD, right? So that is where you can start writing your functions, okay? Anonymous function. And yeah, these are the transformations. This is what you need to understand. So these are all transformations you can use in Spark. Map, filter, flat map. There are many actually. So if I want to filter my data, I will just call this filter. Okay. If I call filter, it will ask me, what do you want me to filter? Within this bracket, I will write my expression to filter. That is how you filter your data. Map is another, it is like for each. Okay. Map I will call, map will ask me like, what do you want me to do? So you will write an expression within map, what map has to perform. So these are all higher order functions, map, filter, flat map, these are all higher order functions actually. So you do something called transformations. In one RDD, if you apply any of these functions, it will create a new RDD. That's called transformation. That is how you analyze your data. Let's say I want to filter my data, I will call the filter transformation. And RDDs are immutable, very important point. Once you create an RDD, you cannot change it. You can only create another one by applying some logic. You can never edit an RDD, they are immutable, right? So if I go to my PPT, yeah, so we have created our log lines RDD, fine, till this we have understood. And then what I did, probably I'm interested only in error messages from this RDD. So you see there are a lot of data, info, warning, error. I want only error messages to filter. So what I can do, I can call the filter transformation. Okay. So I can call a filter transformation and then I can say that, hey Spark, okay, match only error lines and give it to me. And I'll show you how to write the logic. This will produce another RDD and I can call it as errors RDD. This is the steps in which you write a Spark program. First you create your RDD and now I want to do a filter. I will call a filter and it will, change whatever. I mean, it will filter only error messages and that I will store it as another RDD. Now somebody was asking me what will happen to the memory, right? So it will delete this RDD. I mean, if there is not enough memory. So let's say this RDD fit into the memory and then you call this filter action. It will filter whatever is required and this will be gone. This is not required now because you have this, right? Because next processing will start from this step, right? I will show you what you can do. Okay. Originally, let's say, assume in the normal use case, you call a function, it creates another RDD and this RDD is gone now. Now this is your current data. So if you have enabled in Yarn dynamic allocation, then this will be gone. I told you, right? This is actually a partition and there is an executor running here. Now this guy will be idle because it doesn't know what to do. It cannot predict that there will be no data, right? So that is one more problem. Now your problem is you have 4 executors. The second executor has no data to process because it filtered all the error. There is no error. Now this guy will be sitting idle. So one data node will be there, one executor will be there that has no data. It will simply sit idle. So that becomes a problem, right? How can I solve that problem? It's actually very easy. In Spark, there is a transformation called coalesce. Coalesce is a very common transformation. And why do you call coalesce? You pass a number, it will reduce the number of partitions. You can resize it. Because, and you have to calculate this, but in this example, assume you know that. See, now if you look at the data, second partition is empty. Third partition has only one line. That's also not so. So I am assuming that I want only 2. So I can tell Spark, take this RDD, apply coalesce, keep all the data, but delete 2 partition and 2 JVM. I want only 2. So it will just bring it into 2 partitions now. For example, just an example. If you are having 1 terabyte of data, right? And you take a good sample of that data, let's say 10 GB or 100 GB, and you run it once. So then you can understand, after the filter, okay, you can call a collect action. So let's say after the filter, I want to see the data, I can do it. So I know that originally I loaded, let's say, I don't know, 1 GB data or 10 GB data. After the filter, when I get the data, it's only 5 GB. That means half is reduced. So I can calculate, okay, if I'm loading 1 terabyte of data, I don't have to manage these many JVM. So after this step, I should call a coalesce. I can do that. Now the most important point, surprising to you, is that let's say you wrote a Spark code in which you wrote these 3 lines. Create an RDD, filter the RDD, you say coalesce. And you say run, nothing will happen. This is the surprise actually. You wrote a Spark code where you wrote all these 3 lines. Okay, read from HDFS, filter error message, then you set coalesce and you submit the job to the cluster. Nothing will happen in the cluster because all of these are lazy. There is something called lazy execution, meaning Spark will not start execution unless you call something called an action. These are transformations, meaning you are changing the data. But you are never saying that show me the output, right? You are saying repartition the data, filter the data. Okay, so what? Where are you saying show me the output? You are not doing that. So unless you call something called an action, where you say that give me the output, nothing will work. To do that, you can call an action called collect. Collect is a most common action in Spark. When you call collect, okay, you are telling Spark that I want to see the final output. That's it. So collect will look at this cleaned RDD. So you are asking, give me the output of this cleaned RDD. And Spark will understand, if I want cleaned RDD, I should have errors RDD. If I want errors RDD, I should read first. It will go to your hard disk, read the data, do all this stuff, and then show this is the output, right? Show this on your screen. And then the entire pipeline is emptied. Spark never keeps your data in memory. Once the processing is over, okay, you got the result on your screen, right? This you saw. Everything is gone. No RDD, nothing is there. No container, no partition, nothing will be there. Everything is gone. So only for that split second, all these things happens. Now, if I want to know whether I should rerun or repartition, what I should do is that I should go back here, okay? I will do a save of this error. You can also do a save method on an RDD. When you say save, it will save as a file, a text file. So I will say save as an action on this filter RDD. And then I have to check what is the size, right? My original data is 10 GB. After the filter, it is 5 GB. So to process 5 GB, why I'm launching these many things? So I can rewrite my code in that way. So collect will simply display the output on the screen. There is also an action called save as text file. Okay, I'm not just talking, I'm showing stuff. Can you see actions? Now, his question was, what if I don't want to do it? So he had a very good question. So he is asking, so the problem with this is, if I run the Spark code in a split second, everything will happen. And then I see the output on my screen. No RDD, nothing is there in the memory because this is called DAG, Directed Acyclic Graph. Spark will create a DAG, a graph of execution, and will perform step 1, step 2, step 3, step 4, a result, and then everything is gone. Again, you run, again it will load. That's a different thing. Now, so he had a question, I will come to that. So I will give so collect is an action where you return all the elements in the driver program, meaning you see the output. You can also say save as text file. There is an action that will save as text file. If I say save as text file for an RDD, whatever data is there in the RDD, it will save as a text file. So I can see that in a Hadoop or wherever you are storing it, right? Now, is this the only action available? No. I have save as Cassandra table or many other ways to save the data. Ideally, text file save we do just to see the data, okay? In the initial phase of reading the data, even MapReduce or Spark, everything will be same because it is blocks you are reading, no difference it makes. Once the data is available in memory, then the difference comes. Because here you see we did a filter, then what's that, coalesce, and then let's say something else also we did. For doing all this, the data is still in the memory. You are not writing anything. There is no intermediate result you are pushing to hard disk. Once you call collect, you can write 100 functions and then call collect. All those manipulation will happen. Final, the collect only will display the output. That is a speed. No, very good question. Only one action can be called at once. Very good question. Yeah. So there are many actions, or let's say collect and save as text file. Collect is one action. I cannot say collect and save as text file. No. So first collect will run. Again, if I say save as text file, again the whole operation has to start. So you will be wondering, is there a way I can improve it? I will show you. Okay, so probably that is his question. So here I will show you this. So once you execute the DAG. DAG is nothing but directed acyclic graph. It is a fancy way of saying Spark creates all the steps to be executed in a graph format. And I will practically show you the DAG when we run Spark job. You can see that. You can see partitions, you can see the DAG, you can see how many executors it is launching, everything is visible. It's not just theory I'm saying. But unless I speak about it and just show, then you will say how this came, how the partitions actually came. You will be confused, right? And the driver collects the data. So this is the full step if you want to look at it once more. No, if you wanted a filter, you would write it in mapper. Reduce is only aggregation. So either you can say sum or multiply or it's an aggregation function but because you get one key and all the values in the reducer. So what do you want to do with all these values? You can't filter them. So you can aggregate them or do whatever. So if I have to write a filter, I would write it in the mapper side. Here I can, so here the final stage is the collect. So before the collect, I can do whatever I want. I can filter. And here the advantage is it's not just key value pair. You can also work with key value pairs in Spark. So I can create a key value pair and similar to MapReduce, I can operate. I can reduce and I can do all these things. Yeah, he was asking a question. I think I will answer that because if you look at the picture, I have a very good picture to explain this. Just see this picture. Same stuff I'm doing. There is loglines RDD, errors RDD, cleaned RDD. And finally, I'm calling an action called count. Count is another action. So if you say count, everything will work from the beginning because it has to count, right? So count action called and what happened? It showed me the result as 5 because there are 5 lines in the RDD. No surprises. Now I also want to call one more action on the RDD called save to Cassandra. The problem is if I call this action, pipeline is empty. Spark has to start from reading from the block, creating the original RDD, then filtering, then errors, then I can save to Cassandra. Okay. Now, one more thing. Then after I'm doing one more filter, I want only messages 1 from this data. See, message 1, message 1, message 1. I just get only message 1. And then I say collect. So I just want to see this. But again, what will happen? It will start from the top. So if you look at this 3 actions, you can see all 3 actions depend on this RDD. Everything is starting from here, right? That is where you can cache an RDD. It is possible to cache an RDD. So when I say caching, whatever data you have in that RDD along with the RDD will be cached. And then where can you cache? You can cache in RAM, you can cache in hard disk. And you can also say RAM plus hard disk, like wherever you want. So there are multiple options to cache it. And once you cache an RDD, let's say you say count, it will count. Then you say save to Cassandra, it will start from here because this RDD data is already cached. And don't think if you're caching for 1 month. Once your Spark program is over, caching is deleted. So this caching is valid only till your program completes all the action. Once all the actions are over, you exit, everything is gone. Then you are not. So I will show you tomorrow when you start a Spark application. If I am a developer, I will create something called Spark context object. Okay, there is an object I create and that represents my program. And ideally when my program finishes, I'll kill that object. If I kill that, everything is gone. Even caching will be gone. Because that caching is valid only to speed up my existing program. I'm not caching it for a program I'll write next month. That is not possible. During that execution time, I want to speed it up. See, I create this cleaned audio or whatever, and I say count. It will count and delete all this thing from memory, right? So it is not in memory. During the execution, it is in memory. After the execution is over, nothing is in memory. Then you should keep the intermediate data in memory, right? You should tell Spark, I will call an action, show me the output, but this RDD, whatever data you have, don't delete from your pipeline, keep it because I want to reuse it for some other action. Then it'll keep, that's called caching. So there is a command called unpersist. Unpersist is an action, it's not a transformation. If you say unpersist, it will delete it from cache. I'll show you how to cache tomorrow, it's very easy. Otherwise, if you kill your Spark context object, like your session is gone, it will automatically delete it. So basically, so you may be thinking, so how do I start programming with Spark, right? I want to write a Spark program. So first thing you should learn how to create an RDD. If you know how to create an RDD, then you can start with these simple transformations, map, filter. Now, there is also a flip side of all of this. The flip side is, initially when Spark came into the industry, everybody was mad about RDDs, okay, transformations. You know, I'll write a map, filter. People were literally dying on writing these things, okay? But soon there was a problem with this. See, the problem is, if you write your code using these transformations and actions, there is no way Spark can optimize your code. Why am I saying this? Is that you say filter, okay? In the filter, you are saying that filter only error messages, right? Unless Spark runs it, it doesn't know what you're talking about. And these things do not have a very strict schema. RDDs are not having very strict schema. So when you want to process structured data, let's say like CSV file, okay, I want to read a CSV file and I want control, I want schema, everything. RDD is not a good way to process it. You can process it, but Spark internally will not be able to optimize your code. That is where Spark SQL comes into picture, or data frames we call it. So Spark has a module called Spark SQL, and Spark SQL is much more powerful and optimized than core Spark. So when you write Spark SQL, you should know how to create a table and query using SQL. It's end of the day SQL only. So it's easy for to program. And more than that, it is much more optimized than core RDDs. Because you are using all Lambda. And Spark has no way to understand what Lambda you are using unless it runs it. Right? I wrote a Lambda code, some weird code. Spark has no way to understand what is the meaning of this Lambda unless it sees the data. But if it is a table, I can say filter on this column. Spark knows what is that column, what is that data type, where it is, right? It can avoid that column by loading the data to optimize, I'm saying, right? So if I write a SQL query, it has a filter, group by, then join and something. Spark can read it, apply the schema and understand what you are talking about. I will talk about in the data frame class, I will talk about it. So any questions on core Spark, like so far we have discussed? If anything is not clear, just ask me, okay? So don't think, okay. So these are some of the common transformations. Map, flat map, filter. No, these are the name of the transformations. And these are some of the actions that we have, right? Yeah. So anyway, we will get started with the core hands-on tomorrow, but we can look at some of the things. So when you have a cluster, so I'm just connected to the cluster right now, right? Spark gives you a shell to work, like the Hive shell, if you remember. So you started Hive and started typing. So very similar to that, Spark gives you something called a Spark shell. And the Spark shell is available in Python, Scala, and R. There is no Java shell. Java as such does not have a shell functionality. You have to write using IDE or something, right? Now, if you want your Spark shell in Scala, we are going to do Python, but I want the Scala shell, I can simply say Spark shell. If I simply type Spark -shell, I think why Spark shell is not working. I think I have to export a path to get started with Spark shell. Okay, so let me try this. Let's try the Python shell PySpark 2. This should work. 9.9. So this is Java 8. As of now, Java 8 is supported. Okay, I think in the cluster, they have disabled Scala shell access. Maybe I have to export some configuration to do that. That's why I'm not able to open the Scala shell. But if you want the Python shell, you type PySpark 2. That's the command. Why PySpark 2? Because we are in Spark 2. This cluster has Spark 1 and Spark 2 installed. You can try this. We will just do some basics, not like advanced stuff, but I don't know why it's taking this much time. Usually the shell starts very fast. Why the shell is not starting? Let me just check. Yeah, so started. So very simple. So this is your Python shell. Okay, and what it says when starting the shell, it says type help and blah blah blah, logging level for Spark R and all. It says Spark version is 2.2.0. So on the CloudX lab we are running 2.2.0 using Python version 275. That's okay. Okay, Spark session available as Spark. I will talk about this later. What is this Spark session? Okay, but it just says Spark session available as Spark. Okay, and this is your Spark shell. So now from here you can start creating RDDs and then writing transformations and everything that you want. Okay, now I will just see if I can show you this. So if you type this command PySpark, simply type PySpark, okay, dash help. Sorry, PySpark 2, right? PySpark 2 hyphen help. Yeah, so I want to show you these options. Okay, just have a look at this. So I'm just saying that I want to start a Spark shell, okay, and I need some help in starting that, right? So what it says, what are the options you can have? So one is master URL. So this we don't have to worry as of now. Okay, if I scroll down, I can show you. Can you see this? Driver memory. So when you start Spark shell, okay, a driver will be created. Okay, and then you can ask for how many executors you want, right? How much memory you want for the driver, right? One question. And then here you see, what is this? Executor memory. I told you, right? You can ask for how many executors you want and how much memory. So by default, I think it is 1 GB. It is written here. Default is 1 GB. Okay. But you can ask for executor memory, right? And if I scroll down, see here, executor core. How many processor cores you want for an executor, right? And see here, driver core. How many processor core you want for the driver? Number of executor, default 2. So if you are starting the Spark shell like this, interactive shell, you will get 2 executors, 1 driver, each executor has 1 GB RAM, default setting. But using these arguments, I can say how many executors I want and what is their memory and so on and so forth. Now, another important point, let me try this, okay? Just give me one moment. I will just do a PySpark 2. Okay, and let me open my mail, because the Spark also has a UI, and that UI was sent to me in my mail, because for every cluster it is different. Sign in. Just check this. This is a yarn node, I think. Okay, let me just check. Okay. So one of the URL, I think it is not working. Probably it will work now. I don't know. Yeah. So can you guys see this? GL faculty, great learning. This is me. Okay. And it says 55 seconds before I started as a shell. And this is actually showing you the history server. That's what I'm wondering. Okay. 55 seconds before it started. Let me just go to the application. So you have to actually see this URL, but it is not showing. Okay, maybe I think it is giving the old UI. Let me exit from here, okay? I refresh. So what you are looking at here is this history server URL, and this is not really useful to us because once you start a Spark shell and then you exit it, it will display here. You can see here PySpark shell, it was launched by me, 1.8 minute, I exit from here. And then you can see here. But this is not really useful to us because this will come only in the history server. That means once you exit from Spark. Okay. So there is a real UI. That port number is not working. Currently, when you're running the Spark, it will show there. But I can show you something. So this session I stopped, okay? I didn't do anything, I stopped this session. And if I go to this application, this is the Spark UI. So here you can see the jobs and there are no jobs. And if I expand this, can you see executor 1 added? And there is executor 2 added because default you are having 2 executors. And here you can see executors. And there was 1 driver and 2 executors. So there was 1 driver active and 2 executors we got as per this, right? And one more important point is that when you simply say PySpark 2, if you simply say PySpark 2, Spark will start in the local mode. That means you are not talking to yarn or anything. If you want to talk to yarn, you have to say -- master yarn. This is the option you have to use. So whenever you are starting the Spark shell, otherwise if you start in the local mode, what will happen? Driver, executor, everything will be in a single JVM. And also the resources will be allocated by your operating system, not by yarn in the local mode. Yarn has no role in your local mode. And that is good for learning. If you simply want to learn, say PySpark 2 and then you can just start writing your code, whatever. Ideally, when you are launching the Spark shell, you have to say PySpark 2 and then you have to say -- master yarn, meaning I want to register with yarn and then launch Spark. So what this request will go to yarn and yarn will allocate containers to you. Now let's try to do one thing. Let's try to launch it with our own parameters, right? So what were the options we have? PySpark 2 -- help. So let's look at what are the options. Let's say we want more executor. I want 3 executor probably, right? So what is the option? Num executor, -- num executors. I will say 3 and -- executor cores, let it be there. I want memory more. So where is memory? -- executor memory, right? Default is 1 GB. I want probably 2 GB, something like that, right? So what I can do, I can simply go to my shell, PySpark 2. I can say master is yarn and I can say number of executors, probably 4, I don't know. And then what is that? Executor memory. Why this is there? Okay. Executor memory, I need 2 GB. Hit enter. PySpark does not support any application option. Why it is saying that? Probably we are asking for more. Let's see. Let's see whether we can get 3 executors, okay? So first we will try that. Then we will see whether we can get more memory or something. So right now I'm saying that, hey, launch a Spark shell. The master is yarn. Sorry? Not mem, right? Memory, right? Yeah, wrong command, correct. So now I asked for 3 executors and it started and we can't see it here unless we exit. So let me exit from here. So it will go to the history server. Okay. I'll refresh here. This is what we started, right? Can you see? Executor 1 added, 2 added, 3 added. Can you see? So 3 executors were given to me. And you can actually go here, executors. Can you see? This is one driver. These are executors, right? You get executors. And here you see the memory, right? So how much memory did you ask? Huh? I think one default we selected, right? 1 GB we selected actually. So for RDD storage, right now you are getting what? 384.1 megabyte. So how this rule actually works, like I told, around roughly 50% of the memory will be taken. And remaining, it will give it to you. You will actually get around 600 MB in this, but it will display only this much because you are not loading any data as of now. It is simply running. The executor is simply running. You don't have anything inside this, right?
If it is 600 MB, it is going to give it to the
Yeah,
right?
for the RDD.
But why it is showing out only 384?
That's what, you don't have any data as such, right? When we load something, we can actually see the memory it will occupy, how much amount of RDD you have, it will occupy.
It's telling that 0 byte occupied for out of 384.
So 384 right now it has allocated, but there is no data inside that. 0 byte it is saying that. But when you actually load, let's say 500 MB data, it will show 500 MB actually occupied in this. Because up to maximum 600 MB, I think you will get, because 40% anyway will be gone for your system calls and JVM, right? So up to 600, 500 and something, 50 or something you will see here. Okay. So right now you can see only less memory because we are not actually doing anything with here. So that is why it is simply displaying, this much. And I exited from here. So what if we try to change this? Number of executors 4 -- executor memory, right? Memory 2G. There is a threshold value, I think. If it is more than 1 GB, let's try this. There is a threshold value. What is this? It says an error occurred while calling Java Spark context. Required executor memory is above maximum threshold for this cluster. So the cluster administrator has said that you can ask only maximum this much. So what they say? 2048 plus 384 MB is above. So it is saying that max to max you can ask only 2048, 2 GB of memory. But here, what will happen when you launch an executor is that initially it will allocate a 384 MB. Okay, then it will keep a 2 GB as, excess to be allocated. So it is saying that the total memory is above the cluster administrator, what he has said, you cannot launch. So we can try 1.5 G or something like that. I think 1.5 gigabyte should work ideally. Let me check if that will work. Okay, I'll exit. And we'll try this tomorrow, don't worry, okay? I just wanted to check whether the cluster is running fine. We will try this together tomorrow, don't worry. Oh, okay, so how do you mention? So see here, size must be specified as bytes, kilobytes, megabytes, gigabytes, terabytes, right? So I think you cannot say 1.5 G, that will not work, right? So how do you mention megabytes? M, right? Did I say G? So what did I type? I typed G only, right? Then why it didn't work? M should work. M should work ideally, right? 1500 M. It should be whole number, I think. You cannot say 1.5 G. Like you can say 1 G or 2 G. Okay. So now it launched and I will exit. So, but now what I'm showing you here is not correct because I'm showing you from the history server. Like I'm starting Spark Shell, then exit from there, then I'm showing you that this is the UI. That is not correct. You should see live, right? If you're running the job, you should see live. That UI is not working. I was asking for that, and I don't know why. So these jobs will display anything which is running. Why you are not seeing anything here? Because we don't have any RDD or any action, or if you have something, you will see here. Okay. And stages I will talk. The storage will show you if you have cached an RDD. If you cache an RDD, it will come here in the storage section. Environment is where it will show the Java libraries and all. Executors will show how many executors and driver that you have added. Jobs is where if you run a job, it will come. Like you said, this thing dot collect, it will display here. Like when you run an actual job, it will display here the DAG and all. Stages, it will show you in the job how many stages are there and how those stages are created. We will see that tomorrow anyway, okay? Then you have storage and then you have environment and executors, right? So environment will show you the different libraries and all which are part of Spark. So if you go here, now you can't actually mess with me. What if I want to see this from the shell, right? So I'm just saying PySpark. I'm starting it again, okay? And I don't have a GUI access now, but there is a command. What happened? What it is saying? Spelling mistake? M, sorry. So there was a command sc._conf. There is a weird command which can show you all this from the shell. So now you are seeing this in the GUI. What if I don't have a GUI? So I can do an sc._conf.get all. Perfect. So I remember the command. I'm happy. Okay, so there is a weird command. Nobody remembers this command actually. sc._conf. Okay, but the output is weird, but you can see something from the output. What is that you can see? Can you see number of executors? Somewhere it will be, here is driver memory, right? This is driver memory. And you can say master is yarn. Somewhere see here, executor memory. How much it has allocated? 1500. You can also see number of executor. Where do you see? It's very difficult to read from this. I can copy paste, that's better. It's not even allowing me to copy. See here, when I'm copying, I'm getting. So this command is like $1 million command. I'm quite sure nobody will know this command. Even I came to know very recently. How can you see the Spark configs from the CLI? sc._conf get all. It's a shortcut actually. I'll show you the command. This is the command. Please make a note of this because sometimes you will start working in a cluster where they will not give you GUI. Then how do you know how many executors you launched or what happened? You have to look at this way. So this will give you an idea about the number of executors, everything launched. Live you are seeing, like now you launched, now these many are there. sc._conf.get all. Now the good news is we will try something in the shell. The bad news is you will actually try most of the things like this. Jupyter Notebook. So how do you create an RDD? From PySpark, import, SC, blah, blah, blah. Just all output clear. Okay. So KDD, cup data, row data, parallelize.
This brings us to the end of this big data analytics tutorial. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending the session and have a great learning ahead.